Good morning, everyone. I hope you're all good today. Yeah, it's one of these rare days where I'm really motivated, so we're just going to get right into it. Once I've got the chat open anyway. So yeah, we're going to do revision first. I haven't even eaten my breakfast yet, so you might hear me chewing. Hopefully that's not going to be too distracting. So yeah, the chat has not come up yet. One moment. There we go. Fantastic. All right. Yeah, I'm not entirely sure what we're going to be doing today, but I just wanted to get started, like, instantly. Hello, it's the annoying guy. Yells some people in chat. No. Hello, Ratchet. No, it's all good, it's all good. My Benny Taste, hello. Welcome. So, I want to be super locked in today, because, I don't know, I'm just motivated. I haven't finished eating my breakfast. But you know how these streams go. We're going to be doing Mabdo describing you. Yeah. What we're going to be doing today is we did about 7 hours of work yesterday. I felt like that was good, but you know, we could do better. So I'm probably not going to be super advice givey today. I feel like a lot of what we did yesterday. I've also I'm not going to play the music that I want to listen to, just because I want to listen to one particular track for like hours straight. So I don't want to torture you guys with that. Hopefully that's okay. Because I'm the type of guy to listen to the same song over and over and over again non-stop. So yes, we're going to do revision first. Probably going to do a bit of planning afterwards. I don't really know. Here's the thing. This is the thing I had yesterday, right? We did a bunch of GPU-driven rendering work yesterday. That's effectively what we ended up doing yesterday. We started with planning a particle system, but that requires a compute shader. And I was like, well, if we're going to use a compute shader anyway, and most of the work is going to be in the compute shader, why don't we just make this a GPU-driven renderer system where we can do a draw call and cull things as well as update the particles at the same time. Now, I have no idea if this is a good idea. This could be a disaster waiting to happen. I don't know how to do the maths as well for points or for things like view frustum culling. We'll have to see how that goes. I don't know if I need to do like a sphere that projects like because I don't know how to I don't know if I need to do that sphere preserving that preserves view perspective distortion around things. Hi Emmanuel. Honestly, same. I listen to the same song over and over again and then end up hating it and never listen to it again. Yeah, pretty much. So yeah, that's what we're going to be doing today. We're going to be investigating this. I really want to dig into this. Yeah, I'm working right now. Just came in to say hi. Thank you. Hope your work is treating you well. Yeah, so we're going to be completely crushing this today. We need to get better at programming. We need to get better at everything. We need to become an expert. And I can't go easy on myself. I just can't go easy on myself. Have a good stream. Thank you very much. That's very lovely. So to do this, we're going to have to try even harder. So, this is just not acceptable, this stuff. 45 minutes, 11 minutes. So we need to be putting in more work. We need to be trying harder. And I'm just motivated today, so just started my Obsidian setup using that video link you linked in the how to become an expert video. Like you said, we need to become experts. Yeah. Yeah. Sorry, I muted briefly because I was chewing and then I didn't unmute. Practice, 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 indeed. So it's exactly what we're in. I'm in that vibe today. We might even watch that video just to give ourselves a boost throughout the day. All right, cool. So let's start our timer. And start up. Okay, so I'm going to start with the spherical billboards again as revision. And we should be good, and I'm just going to work my way through here, I think. Also, yes, I'm going to make the notes. That's the other thing I need to do. I need to make the thing that Alex told me and make a note on a push descriptor that Ratchet told me yesterday. Outside of that, what else do we need to do? Inline. We need to make a note on inline. Yeah, I'm sick of not doing this, so let's get this in as well. This is something that TT told me, so this is a TT note. So yeah, we're going to make notes on these. Yeah. A formal notes, we're just going to expand on these perhaps a bit. So yeah, that's his particle system, that's Ratchet's puts descriptors, and that's TT's inline description. What else do we need to do here? Let's start a timer actually. Actually we are. Okay, we're already good. What are we looking at? IBLs. Sometimes I look at my code and think that Mike Acton would be disappointed in me. Yeah, I feel the same way, to be honest. There's too many booleans in my structs. Right, is there anything else I need to make notes on? No, okay, so these are 3 notes I need to make things on, so I'm going to make them. Alright, let's dive into what we actually need to do. Okay, spherical billboards. Actually, that's not the first note. The first note is, what are billboards? So yes, need to keep revising this because these are new. What are billboards? So there are 3 types of billboards: spherical, cylindrical, and polyboards. This is nothing to do with the geometry, but how it's orientated relative, how its orientation works relative to the camera. Polyboards are basically triangle strips that act like billboards. Yeah, polyboards are used for effects where billboards need to connect to each other. Think of a lightning effect and other such line graphical effects. Cool. So yes, I'm just going to be munching on porridge at the same time because I've just got back from the gym. Polygon trimming is to do with optimization for billboards with large transparent regions, useful in such as, that doesn't make sense, useful for tree imposters. Yes, this uses maths to trim corners of things. Cool. Spherical billboards, what are these? MFs. Okay, spherical billboards are defined by a center point P and 2 radii Rx, Ry, equal to half the width and height. The billboards can rotate about what? Billboards can rotate orientation. Rotate about, comma, but the orientation of the normal vector needs to always face the camera. Cool. Mike Acton left ear Mozart speed up, yeah. Okay. Always need to face the camera. So the union of all possible orientations is a spherical radius of r squared y r. Okay. We need to move move the billboard vertices into billboard object space. Let's say that let's set this up so MC, which will be the transform to camera space to world space, and MO, which will be the transform from billboard object space to world space. Okay. To connect both spaces MC and MO together, you want to get both vectors X and Y to be the positive X and Y axis of the camera matrix, given by give me a moment. Okay. X, Y, and X and Z. X and, what am I saying? This is one thing I don't quite understand. How on earth is this relevant? Oh, this is the general case, so we can get perfect spheres. Because right down here we only have this one, which is orthogonal. Sorry, not orthogonal. Yeah, orthogonal to the camera's X, Y plane. Bam! Finally got to see some of your stream. You've been streaming super early for a few months. It's 2:48 here. Well, I plan to stream for about 8 hours today, so hopefully we'll be able to see hopefully we'll be able to see the end maybe as well. What is this application? This is called Obsidian. It allows you to make like a Wikipedia type connecting note system. So I have like links to other things that go to other pages, and it has like nice you can put code snippets in. And if I open up this is kind of like the idea. You end up building like this node network of things. So I'm just going to keep on reading. So right now I'm just reading about spherical billboards. Similar to Google's notebook, probably, but there's no AI in this. That's all I know. It's effectively a text editor, where what is this? This is the matrix of the camera. Denotes the J of the matrix. If you place the vertices of the billboard in the plane determined by point P and the direction of X, Y, then the resulting polygons are always parallel to the projected plane, which is what we end up doing. To get a column vector out of a view matrix, you would want to do something like this. If you have 4 vertices, V1, V2, V3, and V4, if you have 4 vertices, these, and apply the transform based on the XY plane of the camera, you get these four equations. These are linear equations. Right. This is how you can use matrices. You can actually build up a matrix. Yeah, exactly. I'm an obsidian shield. That's my real grift. I'm just gonna write a note to myself here. Note that these are 4 equations which can be grouped together into a matrix calculation. No, in our case it would be vector calculation. Yeah, so note these. So we do a xy plane multiplied by the radius. So these are the, okay, you gotta remember that these are xy planes. So we're actually doing a plane operation here. Okay, and that's just where the origin is, minus or plus the point. Okay, this makes sense. Okay, so yeah, note, I'm not going to worry about system of linear equations and stuff like that. Doing a, what is it called? A plane equation over 4 vectors. Sorry, 2 vectors. To transform these points. Yeah, so they're not really vectors. They're kind of like, we've kind of extracted a plane, and then we're just kind of transforming the points by a plane. If the origin, if MO, which is the object space, contains a scale, then the XY need to be normalized for objects made of a single billboard. Okay, so also we need to talk about this in a different place, I think. Only billboard, okay. Yeah, because this is not really brought up here at all, the difference between the two. Alright, cool. For a single billboard, it is often the case that P lies on the object space. This means that, right, let's make a space here because it's ugly. P lies in objects, lies at the object space origin. This means that the vertex position are simply a sum of differences between of x and y. This sum of differences, This is what I do in my, this is what we do in our code below. So we just do the simplest thing. This doesn't work for particles. This doesn't work for particle systems that contain a large number of independent billboards. When you have billboards that have point P that isn't represented at the center of a billboard. Yeah, okay, that makes sense. These equations only produce billboards that face the XY plane of the camera, not actual positions of the camera. Except in those cases when billboards lie, the center of viewport. Okay, this is mostly good enough for a visual standpoint, especially when the billboards are small in size. So this is the sum of the differences, as far as I'm aware. Okay, so spherical billboards, done those two. Okay, so references: GPU Zen book, page 123/124, introduction. So I think what I'm going to do is I'm not going to split this up into notes, but I am going to revise it. This is a source note, so it's not like officially a note yet, but if I don't revise these things, I'll end up just forgetting them. Anyway, particle systems haven't changed since since the 2000s as most. Only render a couple of hundred with the exception of rain, which runs on the GPU. Most particle systems aren't GPU based, which reduces performance. If you have a GPU based approach, you can do something like 1 million. All right. Oops. Million particles. So this introduces a compute shader approach that limits the amount of interaction with other shaders to avoid moving things through memory. This bulk refers to a visibility buffer which calls triangles from geometry, and if there are no triangles left in a draw call, then draw gets called too. It does things in two phases, one for translucent materials and other for opaque materials and triangles, whatever. I think materials is probably less accurate than triangles. No, I'm going to go with materials actually, because you know, that implies like the geometry itself is what thing we're worrying about here. It builds a buffer with 1 bit for working out if a triangle is alpha masked. 1 bit for storing the draw ID, and 23 bits for storing the triangle ID relative to the draw ID. I believe this is a poor man's mesh shading approach to cull triangles from geometry, meaning I don't think you need this for a GPU driven particle system. Cool. Could you recommend some reading resources on Vulkan multi-threading? Ooh, that's a tough one. Let me think. The Mastering Graphics Programming with Vulkan has a section on multi-threading Vulkan, but that uses that only does like one thing. So outside of that, I don't really know how to. I don't really have like a good resource that like really goes into the nitty-gritty of how to do this. I recommend looking at maybe that book. I think it's chapter 5. If I remember correctly, or chapter 4, multi-threading Vulkan, which is only one chapter, by the way, so you're probably going to have to figure out other stuff, and then also going into resources about how other engine developers have done it. A lot of the threading, though, is mostly, it's not really Vulkan specific. It's like, do you know how to avoid race conditions and what shared data is and that kind of thing. Like, if you know that, you're going to have you can have an easier time threading Vulkan. But yes, I think a good starting point would probably be that book's chapter. But again, it's not that expansive. It only teaches you how to do, and on top of that, it has a race condition in there that I didn't quite figure out how to fix. So even its own implementation isn't actually 100% correct. Over the past 10 years, we figured out that multi-threading commands buffers isn't really worth it compared to GPU-driven approaches. Yeah, you're kind of right there. The only thing I would say maybe it's good for, maybe you can bash me over the head with this ratchet, is I/O support. Like if you can have a I/O thread that and render at the same time, making sure everything's synced, you kind of like you can load things dynamically, without like loading screens, because you're not blocking any thread. You're not like waiting sequentially for the I/O to come in. Then you have to like render what's there. But I think Ratchet's right there. The reason I think he's correct is because I haven't heard It's all been GPU-driven rendering, this, that, and that, and that, and that. I haven't heard anyone talk about threading in a while. But yes, that's what I would... So yeah, maybe look into GPU-driven rendering. That's like a good idea. I think that's a better approach if you want to speed up your renderer. Yeah, there you go. So Ratchet is currently multi-threading his pipeline building and texture loading. That's probably more... That's where I would spend my time as well, to be honest. The actual recording to multiple command buffers, I think... Now, again, people shout at me in chat if this is wrong, but this is just speculation. I would guess it's only really useful if you have massively parallel... so you have lots of queues, and you have a lot of things to record, and they all somehow run in parallel without blocking each other, so the synchronization is already there on the GPU side. Maybe then it would probably be beneficial, but I think for most renderers you would probably only want to do that anyway for transfer commands, and even then it's like not that big of a deal as far as I'm aware. I want to load a complex model and command buffers is recorded on the main thread. Stalls the renderer until that model is loaded. Yeah, that's probably what I look into then. Yeah, that book, what I described earlier, just be aware it does do that, but it's not quite correct. You're gonna have to like dig into... Threading is a pain in the neck, and even people who've written books... I wouldn't look into anything else in that book, by the way. That book has... I would take that as a suggestion, not as an implementation guide, due to the fact it uses Vulkan 1.2, meaning it uses render passes. So you'll see how to do it, but I recommend after that kind of... yeah, looking into that. Escape point. The number of queues in a queue family does not correspond to the number of actual physical queues. I was thinking of yeah, having multiple queue families, not necessarily... Yeah, I should have said queue families. But number of queues in a queue family does not correspond to... Yeah, so I meant like multiple... Yeah, so if I had like a queue family for transfer commands and a queue family for... NVIDIA provides 16 graphics queues, but internally they get merged into one command stream. Oh, right. Okay, I did not know that. That's actually really cool. I thought of making a... If it's loaded false, then just read in the GLTF file separately on a separate thread, creating the buffers, and finish model. Yes, that's effectively like a good idea. That's what that's kind of what threading nowadays is kind of used for, as far as I'm aware. But yeah, the actual threading, the command buffers themselves, yeah, I haven't heard anything about. Anyway, data management. You can define a particle system as a collection of particle sets. A particle set is a set of particles that share the same particle properties like texture, size, max speed, or AI behavior. Each particle within a particle set keeps track of position, age, and velocity. Multiple particle sets can achieve more complex effects. Okay, cool. You can create a buffer and allocate memory on any thread. That's what I do. There you go. That's what I would look into. Yeah, avoid the... Yeah, I'll retract my statement on look at how to thread things based on like GDC talks. A lot of them are quite old. And the only threading I have ever done is like honestly for IO. And, you know, not blocking the render thread. Which does simplify the... size, position, particles per second, color, light radius, particle type, light bit field, max particles, initial age, Boyd stuff. All particles are stored in the same buffer. So we have different so vertices and index buffers can be tossed into another thread. What have I done with that? I can't remember. Do you do that in multiple threads, or do you just do the texturing? I think you can. Yeah, I think you can have different resources in different threads. Yeah, because even if you have like image views, which loads the textures, then. But I don't know what would be. Off the top of my head, I can't remember exactly what's great off the top of my head. Like what if that's officially a good idea, you know? I tried the other day with something like that, but I tried with textures, and the way I loaded them from tutorials with a small command buffer. Yeah, yeah, give it a try. Yeah. Okay, so keeps track of whether the particles emit light and what particle set it belongs to. This is an optimization. Right, I'm just going to eat the rest of my breakfast real quick so I don't get hungry later on. Uh-huh. Okay. Cool. Just yeah, let me just sort out everything. I just knocked the microphone. Sorry about that, guys. That should be paused. Doing a spotter revision. Just revision. Revising some of our notes from yesterday. So hopefully, if I can you guys hear me? Let me just check the audio, since it's all kind of not the microphone. You guys can't hear that because that would be annoying, because this is I'm gonna play this for hours straight. Wish you a great day, mate. Thank you. So yeah, I'm revising particles at the moment. So, for example, if we have a light clustering shader, and we detect if particle is dead or not, we're just by looking at the bit field without unpacking the entire particle, which it belongs. We need to make sure that our bit field and our particles are one-to-one, meaning if we access bit fields on the ith element, we should that should correspond to the same index particle. That's quite interesting. I've always wondered how to keep track of this stuff when I've grown up with the feeling. I've grown up with this feeling. So much fun to even do it myself or look at others doing it at the same time. Yeah, appreciate that, dude. Yeah, anyway, so this is the bit field stuff. I'm not going to go into that. For both particle buffers and bit fields, divided into 3 main sections. Section 1 contains particles that emit light and cast shadows. Section 2 are particles that only emit light, and Section 3 is for everything else. We divide these into 3 sections, into visible and active. Visible, I'm going to say visible / active, that's easy to do. And one for inactive and invisible particles. When we have an additional buffer that stores the bounds of each section in a small read-write buffer, it's computed when preparing the shaders. Alright, cool. What's the overall goal here? Right now I just want to revise everything so I don't forget anything at all that I've studied yesterday. And then we're going to try and do GPU driven rendering for particles, right? So we're going to make a particle system. And we're going to hopefully be able to do compute shaders stuff, do view frustum culling, all that kind of fancy stuff in one compute shader. Build up graphics, build up draw calls for each of those things that uses instances, and then once we do that, we should be pretty good to go on like blasting the screen with millions of particles, assuming that they don't emit light or cast shadows. With reasonable performance. The overall goal though, just so you're wondering, is to make this space scene look a bit more like nice and to deal with, and to have a particle system that's going to last for the foreseeable future. So if I turn this off, we do have a space scene at the moment, but this is the at the moment the light. This is the one particle that we have, and yeah, so we have this nice lit section, and eventually we're going to have all sorts of stuff going on. So yeah, that's the thing right now. Alright, thank you for joining us, by the way. Okay, so how do you use an indirect? Okay, so this is not playing. Why is YouTube so irritating? Okay, there we go. We assume we have some foundational. Okay, so we have some. Yes, that's fine. Damn good shit. Thank you. These are the steps on how indirect buffers would work. Yes, Yeah, feel free to constantly ask questions. If you have more questions, Sherry, I'll always answer them. But we're going to be going for like many hours today, so I'm going to start off with making sure I don't forget stuff that I learned yesterday. These are the steps on how the indirect buffers would work for a compute shader that builds up a VK indexed indirect command struct. It first writes out the buffer in the compute shader, and then we read it in the vertex shader. It is important to note that I've left in barriers here because it's important. Because it's important, obviously, for synchronization. I think I'm also going to do a bit of synchronization revision as well. Yeah, VK command multi-thread. We need to do that just above the threading. All right, so I'm not going to go too much into the code because we're going to do that later in a minute. So this is a vague compute shader that's important to note. It's important to note at the bottom of the shader we are writing to a buffer with write only. Yep. Okay, so a lot of this is older things, and we have like index count. The vertex offset. I don't know what that is off the top of my dome, but yeah. Wait, that's just deferred host operation. Mad. Yeah, I actually don't quite know what that means, but there we are. Next, based on the command buffer we have written out, we need to specify the offsets of the command buffer we are going to upload to the shader. Right, I'm gonna skip this because I go over this again. Okay, so when this is the main meat of this. When we want to use indirect an indirect count buffer, you want to create a buffer that is filled up on the GPU. So you can count how many draw calls you have. This allows you to create a buffer that's filled up on the GPU, full of draw command data. Okay, so it's an actual thing, meaning that you need to make sure that it's you set that in this. Okay, so with VMA you don't want to do anything host related. So I need to say both buffers will be worked on created. Both buffers will get their data from the GPU. Yep. The count buffer will get its data from a VK command, VK fill buffer, I think. What is this called? I've forgotten. Okay. So put that in the quotes for code, meaning that we need to make sure that its VK memory properties local is set up in the memory info required flag of the VMA allocator create info. You don't want anything host related in the VMA allocator info as that doesn't make sense. Okay. The count buffer should only contain a 32 number, I guess. So 4 bytes of data, as it's only increasing. I should have left that alone. Increasing a number to keep track of the index when we need to create a new draw call. For our draw call buffer, right? Right, fantastic. Okay, so here we go. This is important to get this right. So, buffer handle, indirect count, buffer handle, invalid buffer handle. Okay, so we retain resources. We exit one if it's bad. The buffer handle is here. Then we set the name, size. The type usage doesn't have the transfer now, remember? So there's a VK usage storage buffer. Indirect buffer handle goes in here, so we can use that later. And the global offset is for dynamic, uniform dynamic, which I might want to research, but I don't know. Oh, one moment. Oh, laptop's dying. Right. Okay, so the VK create buffer info. VK structure type buffer create info, and then we have the transfer, which we're going to be using for this, only for this buffer. Storage, because it's going to go into a SSBO type buffer, and it's going to be an indirect buffer bits guy. It's going to be size 4. We have the allocation info. We set it to auto because we're going to let VMA deal with that without any of our silly shenanigans. Like we said, we're going to make it a required flag of the device properties. Then we just set up a empty allocation info. We run the create buffer thing with the VMA allocator, which we set up earlier, which is not here. The buffer create info, which was here. The memory info, which is here, and then the actual buffer itself and the actual memory allocation. So this comes out. We set the name of this buffer, otherwise we're going to lose track of it if we end up having to debug it. And oh, quick question, by the way, is this slower if I set the name of a resource in Vulkan? Does anyone know? So I'm just wondering if I need to surround this in like a guard, so on release I don't ever do this. Let's just say like I want to do a distribution release, not. No, okay, it doesn't slow it down. Okay. VK device memory allocation device. So the indirect. Okay, so yes, we get this out. Okay, so let me get this fella in. Okay, so this is the important part to remember. To set this up properly, then we need to start doing a memory barrier. They're basically NARPs, fantastic. I disable naming things in release builds. Any reason for that? Source, pipeline stage. If you disable it, which... Oh, right, okay. So it is slower if you don't disable them. I actually don't know. I just haven't looked this up. I just wonder if you guys know. If you don't, that's fine. It is not needed. Okay, so it's nothing to worry about, basically. Okay, so we... Yeah, this is the thing I want to revise first, actually. Before we continue, I am going to do a bit of revision on one particular synchronization thing, which is just access masks and stage masks. I can't remember what the source and the nuances between the destination and the source. So I'm just going to go into that real quick. Where are we? So I've written good notes on this, so you don't worry about explaining that. I can explain it well because the nuances are quite okay. So the difference between source and destination stage masks. So the VK stage flag, a source and destination can be thought of as one being the consumer, the source stage, and one being the producer, the destination stage mask. By specifying the source and the target stage, you will tell the driver what operation needs to finish before the execution of the source. Okay, so we're telling what things needs to be finished before which is this, and what can't have started yet, which is the destination. So that needs to have finished, that needs to have... Okay, that makes sense. So why waste cycles on doing it? Makes sense? I will... Yeah, that's true, actually. It is, there is a few cycles that we wasted. I don't know how many. You are right, it will be faster. Based on that. Even if it doesn't do anything on the... Even if it's a no-op on the CPU side, GPU side, sorry, it's still wasting cycles on the CPU, because it has to do something. And I don't think the compiler will know what the hell's going on with that. For example, if we have this execution barrier set up like this, we have source stage, and the source stage is the top of the pipe and the other one's bottom of the pipe. Oh, sorry, destination, other way around. When we add this execution barrier, you are saying that every command needs to have finished and no work must start before the transition happens. Effectively, the barrier will wait for everything to finish and block all work from starting on the next command. This isn't very good because you have a pipeline bubble. I name literally everything, so it probably adds up more lol. I see, okay. No, it's probably a wise idea, to be honest. Thank you for the feedback, guys. It's appreciated. Let's use a better example. Let's say that you want a vertex shader that stores it stores data via an image store, and you want that to be consumed by a compute shader. In this case, you wouldn't want to wait for the fragment shader to finish. So yes, so we want this to finish, but we don't care about if this is done or not. In this case, that wouldn't be the destination. In this case, you wouldn't want to wait for the fragment shader to finish, so we let a piece of work pass through. If there is a compute shader command, we must wait for that vertex shader to finish. Yeah, okay. The way we express this is we have the source stage mask to be the vertex shader, the consumer, and the VK compute start shader bit to be the destination mask. The idea here is that the two action commands will execute at different pipeline stages. They execute the execution of the green parts. Oh, I see. Okay, so within meaning that our fragment shader can run fine, run without run after the vertex shader, and whenever it likes. Because the compute shader here isn't dependent on that. The commands that contain still go through the same You may be thinking, what if the command, sorry, I'm trying to word this, has a compute pipeline stage, maybe think that's okay. That's I'm gonna. You may be thinking that the first command has a compute pipeline stage. Does that get blocked? any command, any action command that say so all action, yeah, let's say all action commands have to go through each stage, but in our case here, the command that runs the vertex shader does a no-op on its own compute shader pipeline stage, meaning that it's just ignored. If you no ops, you never have to worry about action commands blocking themselves, because they typically do one thing. Cool. Good. Too much work, just spam gigabarriers. Yeah. Exactly. So in the case of the first command, we're skipping over the compute shader. I'm just going to say this again, because the command does a no op on that pipeline stage. Nothing is waited on. This is important that we don't get recording command buffers and submitting queues mixed up. Yes, this is important. With work being done, which refers to action commands running through the pipeline stages to execute. This is extremely important, guys. Don't get that mixed up. That is something I constantly get mixed up, and I got so confused over and over again. Recording command buffers is not the same as work actually being ran on those commands. So when you're setting up your pipeline barriers, just be aware of that, right? Right. I think I'm just going to also revise real quick on access masks, which I don't think it's going to be that difficult, because these are much simpler, despite making things technically harder to, work with. I think once you understand execution barriers, like memory barriers, are like basically the same thing. Anyway, how to make GPU memory visible and available. Below is an example of how to take L1, how to take things from L1 cache, from the L1 cache, and make it available on the L2 cache for a color attachment. So we have a VK pipeline barrier. We make sure that we don't start this until the VK pipeline stage color attachment bit is finished, and we then say VK access color attachment right. Okay, so in this example, where the L1 cache needs to be updated, the L2 cache needs to finish writing, yes, the VK stage color attachment output bit. The VK access color attachment right moves the L1 cache to the L2 cache, making it available with the color attachment right bit. For different situations, you would need to change the memory types to something else. Yeah, makes sense. Using the destination flags, we are moving things from the L2 cache to L1, making the memory visible. Okay, so the destination stage mask, so things can't, and the transfer must have completed before this point. So the VK color shader read, for example, let's just say that we have VK command 1 that writes out color memory into the L1 cache. VK command 2 wants to do something with that memory, that the VK command 1 has finished. When after with the memory, when when the VK command 1 has finished, the cache hierarchies you've written differ from the GPU. The cache hierarchies you've written differ a lot between GPUs. That's fine. It's I think I said earlier on. That's a good point, actually. Yeah, I should say that. For the people who are watching and are like kind of like worrying about cache hierarchies and stuff, visible and available don't really mean anything to the actual hardware, really. The graphics driver itself does a lot of the what is it called? Heavy lifting, depending on your hardware. So like L1 and L2 just visible and available. It's not like we have like a strict cache hierarchy depending on the GPU. This is just us transferring the data to what's visible and available, right? And effectively what you have to do with your memory barriers is make sure that the when you've transitioned the memory, you need to make it available and then you need to make it visible. That effectively just moves things from a big L2 cache into a single warp / wavefront, depending on your hardware manufacturer's naming convention. And then like that warp, I'm going to use warp because NVIDIA, that's the one I use. Then that warp can like go crazy on that L1 cache, whatever that hardware cache hierarchy may be. But Vulkan is going to take care of this for you. Hey, hi Flash. Hey, I'm currently learning C# and cannot grasp the concept of length of dimensions. Can you teach me if you are free? I'm gonna use warp because of Star Trek and Vulkan. Yeah. That's kind of funny. That I like that. Length of dimensions. Do you mean like length of dimensions? I don't know C#. That might be a C# thing. But if you're talking about arrays, the length of an array is just the size of the array. Oh, length of multi-dimensional arrays. Yeah, I thought so. Yeah, just think about it like this, right? You have an array. You have a grid. And you have rows and columns. And you can think of it as like when you have one-dimensional array, you have one column. Sorry, wrong. You have one row, and it has lots of columns, right? It goes off like just like Excel. I don't have Excel at the moment open. Yeah, I can throw this in here real quick. So if I throw in this table, right? This is like, can I get rid of? How do I remove array? Delete a column. Yeah. Alright, fine. Right, we're just going to imagine this is like your array, right? This is a standard array. This is the size, right? If you have a multi-dimensional array, literally this is all you're doing. Right? So, one dimension is just one line, and then 2 dimensions is this. So when you're counting the dimension, like the size, you're kind of counting like, one, how many columns do you have, which would be one dimension, which would be the outer dimension, and then two, how many rows do you have. Now this is conceptually like how this is not how the computer will represent this in memory, right? Computer memory is different, so don't worry about it too much. This isn't what I'm only saying that is so you don't think like, this is actually how the computer is going to store it. I don't know how the computer is going to store it. But anyway, so yes, that's how it works. Can I delete this table in one go? Can I just backspace this maybe? Yeah, cool. First thing in the morning. Thanks, Stephen. Yeah, I'm really trying to grind today because I'm pretty motivated. Anyway, so we need to pull the memory from L2. Okay, so for example, I'm just going to read this, guys. Hopefully that's chill. For example, let's say we have VK command 1 that writes out color memory to L1 cache. Command 2 wants to do something with that memory when command 1 has finished. So we need to pull the memory from the L2 cache to the L1 cache. The source access masks. As the source access moves the memory from command 1's L1 cache to L2 cache with the destination masks. Is that right? Give me a sec, I might have got that mixed up here. The source masks, the source masks, yes. With the destination masks, yeah, telling command 2 to transfer the memory from L2 cache to its own L1 cache, making it visible. Okay, yes. It can, so it can complete its operation in the fragment shader. Cool. Thanks, by the way. Are you building your own? Yes, I'm building my own game engine. We're trying to make this like look better. This is what we're trying to do at the moment. Not that, the menu. We're trying to add like loads of particles in the scene. This is one particle. We're trying to make it GPU driven. So this is what we're trying to grind out today. Yeah. Anyway, right, I've done that. So now we need to go back to this, which is the important part. So this needs to finish the pipeline stage. We are moving this to the L2 cache, the VK indirect command read. This can't start the transfer until we've made the, and we make, oh, this is wrong. This is a pipeline stage, which is not a access mask, which it will compile if you do this, by the way. Be careful if you do this. This is just an enum. So this enum will correspond to the wrong thing. So do you pay for Obsidian? No, I don't think it's worth it. When you can just push up your code onto GitHub and then everything kind of works. So yeah. Is Obsidian free? If you pay for it, you get free synchronization and no hassle. But because I can use Git and I have a GitHub account, I can just push up my code, my notes to there and not worry. So I've made a mistake here, so we need to make sure that this is correct. This is extremely fragile. So where's the call thing? Okay, so here we are. So yeah, it needs to be try runs for right. Who would have guessed? Who would have guessed? Like, there we go. Okay. So that needs to be in the L. So this is for the transfer command. That needs to happen. We ignore everything else. We do the whole buffer. We have one buffer memory type, which I believe, as far as I'm aware, this is basically irrelevant. But whatever, you know. Maybe there's some optimization that you can do in the future. Yeah, then we do the command, the transfer command synchronization, and then we can fill up this buffer. Completely chill. Okay, yeah, I was thinking about it because I've had to switch off Notion. Notion is horrible now. Oh, is it? Oh, dude. Yeah, that sucks. You weren't supposed to say that. Escape point. There goes your Obsidian check. Yeah, That's right. I mean, you're supposed. Yes. Sorry, guys. Scratch that. Obsidian is the greatest thing I've ever used in my life, and the only way to become good at programming is to pay for Obsidian. Hopefully that works. Hopefully people. Hopefully the Obsidian check will come through. Um, um, we also need to create the draw command buffer, which should be empty, as this is going to be filled with a compute within a compute. Within a computer, yes, that is true, but in a compute shader is more specific. That's why we need a bunch of. That's why we did a bunch of work earlier to fill up. A buffer with zeros, I should say. Okay, because we are going to use that compute shader to go through each element within a draw command and exclude things. Yeah, we don't need. This is the power of fully GPU driven rendering. Yeah, now they give you a pension check. Fantastic. There we go. Whoop whoop. Yeah. So you say buffer handle. Buffer handle. Buffer handle indirect. Buffer handle. Yep. Okay. So we set this up. As we do this, we set this up. I don't know. Yeah, I still didn't work out why this is so big. This is a huge buffer. But anyway, it's not too important. We say this is device local again because we're going to do this on the shader. So we create the buffer. So we access the buffer through the buffer resources pool. We say pipeline stage shader vk shader bit. So this needs to be. This is pushing things to the L2 cache to make it accessible. Once this to get stressed, so we make it accessible and shader read. So once the compute shader is fit, this can't have started, and the transfer needs to be shade writable, shader access writes. Cool. So the dependency info. Cool. I leak 6-7 bytes each frame for the memes. Yeah. You should have an error message at the end, like a custom error message, if you run out of RAM. After we have filled the count buffer, we need to transfer the buffer to a be readable in shaders. Okay, so that needs to be moved. That is what we're doing here. Cool. And okay, next, the next step is to create a compute shader that fills up the so what I think I'm going to do after this is try and make a compute shader thingy. Now, I have not done this in ages. We push our indirect buffers. So yeah, this is I think this needs to be moved, and I need to make a new note here. Hang on. Right, so here we need to make the indirect. Now with all our memory in the correct format, we need to make sure we need to run the VK dispatch. To actually do the work of creating the command buffers, the draw commands. You can set the number of draw commands you want to create. That's what the draw count is. Is 4. We also are using our push constants, like to push pointers to the memory. I'm going to just make this. Okay, so we're using push constants to access these buffers via a buffered device address, right? I don't think my code leaks a single byte, lol, because I don't do manual allocations on the CPU side anyway. You don't do manual allocations. Does that mean you use you always use shared pointers and smart pointers? Unique and shared pointers, and weak pointers, I assume. Okay, so yeah, that's the. It's also important here to avoid having to do SPIRV. SPIRV. Nope. That's, come on, whatever. Reflection. I'll look that up in a minute. I can't remember the acronym. I can say it, but I can't type it out, you know what I mean? It's kind of strange. Yes. SPIRV. To look up the number of threads. We are just keeping the relationship working between the and the number of threads ourselves. This, just be aware that if you get this wrong, you could. Alright, yeah. More fragile, but less work has to be done on the CPU. I'm not using smart pointers. I haven't need for them yet in this project. So you're not allocating any memory on the heap at all? Is that what you're saying? Yep. Okay, so the draw count, bind the pipeline, get the two things, we push them to the push constants, we get the number of threads, which is just the draw counts plus that, minus 1 divided by this. So in our case, it'll just be one draw command. I don't know how to do the maths effectively to figure out how many instances are we going to have per draw call, but I think that's... So we're going to use an instance rendered indirect draw call. How are you... Sorry, I'm maybe a bit confused then. So you're not manually allocating anything. How are you not using smart pointers, and you're always guaranteed? How are you allocating stuff on the heap if you're not manually allocating anything, and you're not using smart pointers? Just kind of curious. I'm clearly not understanding how you do that. I'm sure you're doing it correct, or I'm not. Don't take that as a criticism or anything. I'm just don't know what you're doing. The next step is creating a compute. I said computer shader again. That fills up the VK indirect, or in our case, we're not doing the indexed one because we don't need to do that. We don't have an index buffer. We are pushing our indirect buffer and indirect count buffer. Okay, yeah. Once we are... One we are purely writing to, and the other I believe we are purely reading from. Yep. The compute shader and the C++ code are tied together. Okay. Yeah, so I basically say the same thing here. So I don't think I need to do anything else. I'll give you a few minutes to think of a way. Hint. By not manually allocating, I mean that I never call malloc/new. Yeah, I'm lost. Anyway, if you are not using a mesh/task you can do this at because we can store the draw commands outside. This is us the filling up the command buffer. Fantastic. This is really... I hope this works when we actually get to it. This example here is doing... This example here is going off a compute shader that just fills up the command buffer and does nothing at all. In the comments in void main, I'm assuming you are eventually going to do stuff. Next step is transitioning the buffer we have written to be able to be writable. So we need to transition it. That makes sense. Then we access these fellas. Let's just make sure these are good. Have you read the latest edition on the Vulkan sample game engine tutorial? No, actually. I actually don't know what that is, actually. Is that part of Chronosis, or is that like okay, so the VK pipeline stage compute that can't have that needs to have finished. We are then taking this to L2 cache. The VK pipeline stage draw indirect bit. And then the VK stage vertex shader bit. Okay, so then we need to take the indirect, yep. Fantastic. And then we do this with the, I assume this is the count one. Yes, so that needs to be finished. The VK shader write bits, then the indirect draw call. Cool. Fantastic. Okay. Part of Chronos is an extension. It's an extension of the refreshed... Oh, okay. Right, cool. Containers is how you're doing it. Got you. First thing we must mention is that we are going to increment by 1, going over the indirect, yeah, draw count in the compute shader. Yep. Wait, we already... So this would be in a pass, I think. So I'm just going to put this in a... Hang on. What? Okay, so let me organize this a bit. The advanced Vulkan computer tutorial compute tutorial was added like Monday. Oh, okay, let's have a look. That might be useful for making sure that we're getting things correct. Advanced Vulkan compute. Oh no, I'm gonna have to look it up like this, aren't I? Vulkan simple game engine tutorial. Huh. Wow, yeah, I didn't know this existed. That might be good for timeline semaphores, slang is the primary, modern. No, why are you using that? No, that's so annoying. Oh well. Improve synchronization. So, all right, okay. This is brand new to me. What the heck? Why does it look so bad? I mean, it's got shadows here, but it's kind of like they took a screenshot or something of a. What is going on? I don't understand why you would want it to be lit like this. I mean, obviously it's probably really good, but right, this is cool, yeah. So advanced stuff. I assume this is advanced. I don't know. Planar refraction. Oh, okay, yeah. Wow, this has got more than I thought. So forward plus. Yeah, so this is actually really good because I actually needed to know, like, huh? How does this work? So rendering compute. Okay. I'm confused here. Yep. Is there anything explaining anything? Okay, it's a bit more explained here, but I don't understand where the source code is. This series builds off the core Vulkan tutorial. Ah, okay, so there's more. Ah, okay, so, right. I didn't know that. Okay, so there's 2 here, and I assume there's a GitHub or something? It assumes that you've done this. Ah, okay. Engine mindset. Filling gaps using the Vulkan guide samples. Yep. So the Vulkan tutorial, interesting. And got ya. The original Vulkan tutorial has been updated a while ago. Includes. Okay, cool. Let's see. So I assume that this is like, okay, so building a game engine, and then we go to mobile development tooling, subsystems. Tiling, I don't want to use really. Sync to. Okay, so it has animation. It has LOD, which is nice. So my I wonder if it's got the tooling perhaps. Right. Okay. So this is just more like research and development. This kind of stuff. Oh, I see. Okay, I didn't understand how you're supposed to navigate this website. Okay, so there we go. Okay, this is what I was expecting from a tutorial. Because I was a bit confused. I was like, how on earth? It can't just. So if I want to do forward rendering, then I go. What to read next to this? I assume it has like. Huh? Where's the? It has a GitHub, I guess, and because this might be like a really solid resource if we can just work out how it works. Where is the source code? Maybe. Oh, left hand side. Sorry, I wasn't looking. Let me look at the the right hand side. So if I get to this, how to use this tutorial? Okay. Each chapter builds up on a small end-to-end. All right, I'm getting distracted. I kind of want to do this more, to be honest. In the compute shader, we have a condition for draw calls. We need to limit the draw calls. Okay, yeah, that's fine. I'll look at that later. That's if I can't figure it out quickly, then it's not worth. I really want to drill on this. Like this is. I know it seems mad, but I feel like I'm falling behind. We're not getting stuff done. So I've just got to grind this out. Yeah, this is not going to be in the fragment shader. Oh, we actually did not set this up properly in the compute shader. Thank you for sending me the link. It sometimes doesn't let you unless you've done it in the Discord server. Advanced compute power. Okay. So this is cool. And then if I go into these chapters, I assume it has something in here on this, and then next. Okay, cool. That's good. Yeah, we'll probably look into this then, because I obviously want to make my compute shader fast. I thank you for the direct link. I don't know quite where it is. But I probably don't need to go into the heterogeneous ecosystem or... Right, okay, so I think, and specialized math and all that kind of stuff. Cool. Cool. Right. This is okay, I think we understand this enough now. So what do I need to do? That's the next step. So let's just write some things down in a list. Oh no, we need to do this next. Okay, so inline. This is a C++ thing. What? Okay, so what is inline? Inlining in C++. Okay, so C++. This needs to be in the C++ index, which I thought would be bigger, but it's really small. So inline outside of a class means that you violate the OD. What the heck does that mean? ODR, what's ODR? One definition rule, okay. One definition rule. Okay, so it's not, you know, you spell violate. Okay, so we have this. No, we're not going to make that a heading. Which I might have to make this as well. Maybe there's a strict definition that I should know. Right, thus. Okay, so I'm going to make a quick note here. I'm sure I understand what this means, but I want to make sure. Alright, so this is the same thing. So a function. Okay, so it's not useful. I just need to see the definition. Only one definition of a variable, function, or class. Enumeration. Concepts, templates is allowed in one translation unit. Okay, some of these may have multiple declarations, but only one definition is allowed. Okay, that's fine. I'll rob that probably. Which states that I'm gonna get rid of concepts in this manner. I guess I don't know. Maybe I should leave them in. Yeah, what is this saying? Concepts. Alright, cool. Whatever. Since C++20 templates are allowed. Okay. Cool. Thus, one instance of a global variable. Static. Okay. Maybe I should look up just like what inline means, because that's going to be probably more useful. We've got the one definition rule now. Okay. This is so I never forget this ever again. C++. What does inline mean for global variables? Do got violated, indeed. An inline variable in C++ is a variable that is declared using the inline specifier. It is an exception to the one definition having multiple definitions across multiple translation units. Okay. Meaning that we have multiple definitions across different translation units. Cool. All right. It is an exception to. Okay. Yep. Editor. Inline a variable have an external linkage when not declared static. External linkage. This, maybe I should make it like this. Hang on. If we're going to be reading stuff, we're going to be studying. Yeah, we should do it like this. Get rid of this. Yeah, maybe I should throw this in its own thing. I think I'm going to do that. Just because. What is what is the one definition rule? Okay. Cool. It's just worth having that there. Separate sentence. What is inline? And I'll probably just link this, perhaps. CPP reference. Let's see. Definition and ODR. One definition. Rule. Cool. Alright, cool. Go. Fantastic. Okay, that's good. So then we can connect this here. We can do like a like this. Bar ODR. ODR. One definition rule. Okay, cool. Got that in. Go. Oh, wrong way around. What are you doing, dude? Cool. Okay, get that there. ODR. One definition rule. Cool. I'll put this down here as well. One. What is the one definition rule? Cool. This needs to be connected to C++. And get rid of that. Cool. Next. Right, after this I'm going to blast through as much Vulkan as possible. We're going to go crazy in the Vulkan soon. Meaning that we have multiple definitions across different translation units. Go in here. Without making it static, it has external linkage. Okay. How do you use inline variables? It's very easy to use inline variables. C++, three-step process. We use the inline keyword to declare and define a variable in the header. Now we will include this header across the inline variables in source files we want to use. Run the program. We can easily declare an inline variable as inline using the inline keyword before a normal declaration. We can also assign a value to the variable with help. Yeah, with the assignment operator. An inline variable defined inside the header can also access by importing the header using the Yep. Here we need to go. Okay, so it's for properties of inline variables. The following is the main properties of inline variables. Unlike inline functions, inline variables can have static storage duration. This allows us to have static storage duration. If an inline variable is defined within the scope of a class, it behaves like a static, right? If an inline variable is in the scope of a class, then it behaves like a static member variable. Such that, and we can initialize this within a class. Cool. It also makes the scope of the variable static. Okay, yep, it's fine. I have a few legit INL inline files that contain Vulkan templates and inline functions that get included into many places. They're not header files. Oops. And they don't need to be pragmat ones. So inline files are special, are they? Actually, I've never used them. I know of their existence, but that's about it. Inline variables have the same memory across all translation units. Yep. Why is this leaking? What is going on? Sorry, my water bottle just leaked everywhere. Nice. I might look that up later. But yeah, so I'm gonna crush these 3 notes out, and then we're just gonna like code Vulkan for the rest of the day until my eyes bleed. C++11 allows multiple definitions of inline variables in different translation units, and each translation unit has their own copy of that variable. We can, in C++17, have different definitions. Oops. Of inline variables, creating in variables in translation units, creating new copies of these variables. All this talk of coding and Vulkan is making you wet, yeah, making your water bottle wet. Exactly. Inline variables have external linkage by default. If you want to define a inline variable with internal linkage, you have to make it static. Static means you have a global that are instantiated for every translation unit. This goes for functions as well. Statics might get duplicated in the binary, depending on what LLMs decides to do. Right, okay. But just correct that. Oh, I thought that was a misspelling. Cool. That's good. Done that note. Thank you, TT. for that. Come back, please. I meant the no, not TT. TT can do what he wants. When did you start learning programming? I was on and off. I've been on and off for years. I only started really taking it seriously in 2017, but I kind of like started to try and do game development stuff in 2011-ish. Shaders spoke to him in a dream. Yeah, exactly. Right, so we've done that. We need to go back to our... But you can get way better than I did over those years. I kind of had like 20 different hobbies that all kind of ate time away from each other, so... this is Ratchet. What are push descriptors? Right, I'm just going to take his word for it in this one because I don't want to spend too long on this. I feel like that C++ one took longer than I wanted. Vulkan descriptors. Vulkan descriptors, and probably want to do push constants, some kind of push constants. What are push constants, maybe? Yep. And what are descriptors? And then maybe something about using descriptors. Yeah, creating descriptor set or something. I don't know. Really enjoyed your recent video about learning programming. I'm the same bit as you, programming on and off, and but you're way more consistent than I am. Yeah, it's I just decided a long time ago, probably when I was like 28, like to take it serious, oh, okay, I need to like go. That was like when I dropped all my other things. So I started taking my hobbies seriously in 2017. Like when I was 28, then I was like, oh, okay, I really need to focus on getting a skill. And I was like, all right, 2024, and no, I'm sick of being a rubbish programmer. Let's time my stuff, right? So that's what I ended up doing there. So yeah, very much appreciate. Yeah, I'm glad that video was good. Yeah, what's up, Escape Point? Good to see you locking in. As always, I locked in today, and I implemented a flat shader into my C SDL renderer. Yo, nice. Yes, we are. Hello as well. Hello to you too. Hope you're having a great day. So we need to put this in the descriptors. I don't know where to put this, to be honest. Probably at the bottom. What are push descriptors? So that's, thank you for that, Ratchet. So the push descriptors are not the same as push constants. They are typically used to transfer renderers from OpenGL to Vulkan, I should say, I guess. I don't know why I'm correcting it here. To Vulkan. They are less efficient and more limited versions of normal descriptors. The only game apparently that seems to use them is Minecraft's experimental Vulkan backend. Fantastic. Okay, so that just means like don't use them. They are completely irrelevant. I probably don't need to look into them that deeply. Get rid of this, and we have the particle system that Alex talked about. What you could do instead is use an instance renderer and update the instance buffer in the compute shader, which is probably what I'm going to do. Assuming that you get the buffers correct synced up with memory barriers, etc. Alex collides them with the depth buffer and renders them after the update. Okay, cool. This allows you to do things like change instance points to UVs and get some nice splash animations on rain when a collision detection is found. I see. Right, okay, yeah. So we can collide with everything based on the depth. Got you. And I believe this is because we are using the depth buffer. Yeah, and just colliding with whatever it hits. You might need to do multi-indirect draw calls. So yeah, so fantastic. Okay, so this is what Alex does. So I don't know where to put this. We're gonna put this in. I don't want to lose it. An explanation on a basic particle or something. Let's see, where can I put this? This is graphics theory. I'm gonna throw this in a source note just because I don't know what to do with it yet, because I haven't quite decided. Yep, here. This might be like this might be like an extra introduction. Suggested high level view of a particle system. Right, okay, cool. Right, so let's start writing a compute shader path, and we need to... Alright, that's cool. We've done enough revision-ish. Let's go to the top. Go in here. Right, next. Where are we up to? Let's run the engine. We have written, I believe, the simplest compute shader as well. You know what we should do? Yeah, let's just goal, right? Here's our goal. You know what? Let's do what Tokyo Spliff does. Hang on. I don't know how to make this work. Alright, I'm gonna pause this for a minute, just while I do something else. Is there a way to like add a extra thing? This might be like a waste of time, so I'm not going to spend too long on it if it's not. No, I don't know how to add anything. What we should try and do is maybe Tokyo Spliff has a timer, like a countdown timer. There must be a way to add a timer, because that'd be cool. I want to do that. Let's see if there's a quick. So stream, labs, add, add a timer to the. I don't know. Yeah, that's what I'm trying to do. Is there a way to do that, like, quick? To install it. Alright, so if this takes too long, then I'll forget it. I don't want to faff around with this, to be honest. A Tanish. A bit off topic, but when you said you decided to become a serious programmer, did you have to leave other hobbies? Yes. Asking because I have a hard time juggling my hobbies, yes. I watched, like, what really was the tipping point for me? I don't know. See, people hate this guy, and I want to just add a caveat, right? So I'm gonna share something that people may dislike. Sam Hyde is a guy that I believe has the ability to kind of deliver advice really well, and just because I really like some of his advice doesn't mean I endorse every single thing he's ever said ever about anything, right? So I get a skill. I think I've just talked about this briefly, but this video here is incredible. I do recommend watching this. There is something more than this is something you need more than really anything else, and I think it's like it's like a hard-hitting video, and this was the tipping point for me. This was like, I'm gonna start taking basically my life seriously now. I'm not gonna be trying to learn guitar, learn Japanese, learn, I don't know, origami, which I was also kind of interested in at the time. You know, I was like, okay, no, I need to like push forward, and you know, really take things seriously. So that was I can provide this link if you want. I understand that this is not everyone's cup of tea though, because he has like some crazy views on things. But like I said, I don't, just because you like one thing doesn't mean that someone said doesn't mean you need to endorse. I don't endorse everything he said, has ever said, but I think that's one of the best things he's ever done. So yeah. But to generally speak, to sum it up effectively, I'll sum it up just in case you don't want to watch that video. The idea of that video anyway is that you don't want to basically get to the age of 40 and have no skill in anything, because you've spent your times kind of splitting yourself between lots of creative, you know, avenues, and you know, doing this, like trying to learn to paint, and then trying to learn to draw, and then trying to learn to play all the instruments that you can get a hold of, and then trying to be a music producer, and then trying to become, you know, write a novel, and then trying to become an illustrator, an animator, you know, all these type of things. Like some people can get into this like rut where they just like do 20 different creative hobbies all at once, and the downside of that is you never get good at any of them. And when it comes to creativity, and I believe programming, what I'm doing specifically anyway, this type of programming where you're trying to make a game, is a creative field. To really ever make money from doing this, you need to get the bare minimum you need to do is get very good at it. For example, if you want to say get really good at, you want to make money painting, for example, like the bare minimum requirement is that you get really good at it. And you know, you can say like, oh, what about Jackson Pollock? What about this? What about that? What about this guy who was 45 years old and then started to paint, and then he made money? It's like these are typically exceptions to the rule, and the rule is typically, if you are trying to do something creative, or you are trying to, you know, take your life seriously, I think, then getting a skill and getting very good at something is extremely important. And I honestly do agree with that. That's why I'm like trying to do this like for many hours per day, and I've kind of like decided to leave other things behind, because it requires sacrifice to get good, and sacrifice means that you have to give up things. It's not for everyone, I have to admit. You know, most people don't do this, but I don't know. I just think like there is no way that I could do something creative and not trying to become an expert, you know. But that's the video summed up. I don't know how much people agree with that, but I think that's how it works. And what's funny, side tangent as well, Sam Hyde also mentions this, that the chances of you actually creating something, if you're rich, that's worthwhile, and you know, forging your own path with that creative thing, it's just like a side thing, right, are much lower because you don't have to try. Whereas, like, you know, if you're not as well off, yeah, I disagree. What you should really do is put all your money into something Into a big, beautiful bonfire, yeah. Yeah. Yeah, because it all comes down to this, I think. You're not competing against me. You're not competing against, like, other YouTubers when you're trying to, say, like, I don't know, make a game, or like Edmund McMillan, right? You're not competing against Edmund McMillan's Mugenics when you're trying to become a game developer, for example. I can only really talk about this from a game developer point of view. You're competing against time, right? You're competing against the point where you can't ever do this because you get sick. You're having to fight against losing money over time, right? Versus doing something else. Like, that's what you're actually competing against. So that's why I I think taking this seriously is if you really want to do this, like becoming like a serious programmer, like that's what you're fighting against. You're fighting against like the world, not necessarily other people. I think that's a nice observation. I kind of like that idea. Let's just say you like learning C++ and you're I don't know, you're 40 years old. It's like you've only got like, let's just say, I don't know what it would be, but like cosmically, there's only like 10 years for you to actually get good at this before programming is never going to be a career path for you. Because something's going to happen in the future, right? And if you just assume that you've got infinite time, then you end up kind of wasting it. And yeah, everyone has limited time. And so I think if you do want to do something like programming and make a career out of it, whether that's being an indie developer or a C++ developer, whatever, in a company, you only have a limited amount of time to do it. Only 40 years old right now. No, I am not. But I'm closer than I would like, I guess. I'm 33, so 7 years until I hit 40. So yeah, that's my diatribe on that particular thing. But I know this is kind of like this goes against the grain of like what I don't know. I don't know where this comes from, but there's this culture that you can learn anything at any point, and you can change your life around, like immediately, like dead easily. But if you're sitting on your sofa, like smoking weed, every day, doing nothing, and you do that until you're 40 years old, like you're in a really bad situation, and it's going to be extremely hard for you to make anything good if you've been doing that for a long period of time. Damn, you sound such like a younger dude. No, thank you. I assume that's a compliment, but there we go. Yeah, I'm turning 30 this year and about to start as a senior draftman and assembly engineer on a US nuclear submarine. That's really cool. I used to work Game Arc. Oh yeah, I remember. Yeah, I remember Game Arc on the flight sim. Yeah. You're kind of quiet, to be honest. I'm listening to music. Am I? I think I'm full volume. I don't know. That might be you, Angelica is a cutie. But yeah, the flip side, that's the reason I titled that video, by the way, about becoming an expert. You're likely not going to make it, because most people don't do this. Most people try and fail. But the flip side of that negative, like, kind of, I don't know. I don't know how to turn myself up on my end, to be honest. The flip side of this, I'll just finish this off, is anyone can do this. You can do this. Anyone in chat can do this. Like, anyone who's listening to me, you can become that engineer that you dream of becoming, or whatever. Insert thing that here about whatever, right? Like, there is nothing stopping you, unless you're, like, severely disabled, in my opinion. But failure is something still, though, right? As long as you keep going. Yeah, just keep going, dude. Like, people will say that maybe that you're past it, but you know, you can technically, like, even though, right? Okay, so it's nuanced. This is a nuanced topic, and it's kind of difficult to explain. Like, becoming a burnout, neat over, I don't know. Let's just make it extreme for like 50 years straight. The chances of you becoming like a success after that point are very low, but you still can do it. The nuance here is that because you can do it, you can get this in your head that there's always time to do this and take this seriously. And if you can constantly tell yourself that over and over again, you're never going to make it. So that's the nuance, right? It's kind of difficult to explain. I went from creating art/detailed simulations of while studying to become an engineer. Oh yeah, I remember. Yep. And now I have the highest security clearance one can get, and setting up parts for a nuclear sub. Wild. And in my free time, I'm working on a Vulkan game engine. That's sick. Yeah. That's really wild, yeah. So, yes, the nuance is, if you want to take it seriously, don't tell yourself you have enough time. You can do this tomorrow. You know that forever. Tomorrow will never come. You know, do it now. Because the people who tell themselves that, yes, they can because it's technically true, they can become, you know, what they want in life, like Relic says, you know, done. They can become like Relics in the chat. They will never do it, and they will succeed. They will fail, and that's why most people never. That's why that's one of the reasons why people don't succeed. I have started reading the Nantu Tetris book. Working on that. I don't know. That's good. Yeah, that's what you need to be doing. Yeah. Best advice is to go into a path that allows you to branch into different fields. There you go. Yep, I don't deny that. So yeah, that's the thing. That's why you know, for me, if I want to make a game and put it on Steam, for example, in my own game engine, like, I've got to work hard. There's no getting around. There's no getting around it. And the more creative your field, the more creative you want to get into, unfortunately, I think the harder you have to work. I think that's just how it goes. Being able to transfer skills and abilities into different jobs is super valuable. There you go. Yeah, I agree with that. Yeah, and I think transfer skills here, we're talking about but you have to have that skill at a particular level, right? It can't be just I've been dilly dallying with Photoshop every now and again, right? You know, you have to kind of like, all right, if I'm going to learn how to do illustrations well, I'm going to have to like do it well. Yeah, do it proper. Failure are a capitalist philosophy. Most people have done many good things over the course of their lives. They're just on display for everyone to see. 100%. But I'm not talking about making money necessarily. What I'm really talking about is taking a skill so you can forge your own path in life, and being like that could be like helping your buddies out, right? That could be, you know, it doesn't have to be anything that you can sell. Even like you could be like a really good priest, right? You know, I don't know what that would be, but become skilled in a few commodity skill sets which can grow together. Yeah, 100%. Yeah, it's just the opposite side of that is just not doing any of it, right? Not trying to get good at anything, in my opinion. Yeah, it's all about forging your own path and fulfilling your potential, whatever that may be, rather than maximizing profit, right? That's yeah, because this is a nuanced topic. It is kind of tricky to talk about. And if you constantly put it off, like I said, I think I've said this multiple times now, but if you constantly put it off, you won't be able to forge your own path. You won't be able to support your friends. You know, maybe you don't have any friends, but I don't know. You know, family. You know, you'll be able to support your family very well. You know, if you've got no skills at all, right? Like at all. I'm picturing in my head, like, say, someone who's just on drugs, who's like doesn't take their life seriously and is at home in a messy apartment, right? / flat. Like, that is what you want to run away from. And it doesn't matter if your skill is, you know, in the video I talked about earlier, you know, he talks about like knowing all the plans for knowing all the phone plans, you know, for like so you can sell them to people, and it doesn't have to be like a grand skill, like in capital letters, like I'm this. That becomes your identity, right? I'm gonna make it infinity. They can't stop me. I don't know who they are, but they can't. Yeah. And yeah, it's tough out there if you're trying to be creative. That's all. Especially film. I think film's probably the hardest. Look at myself drinking a beer in front of a PC monitor. 4 PC monitors while awake at 5 a.m. Still living in my parent basement. Yeah. But you know, you're not I wouldn't say that, Relics, you're like a drain, right? It's not like the opposite of what I'm saying is necessary. You know, I guess I don't know how to phrase this any well. It's just the last thing you want to do, basically. How do I explain this properly? But you don't want to wake up one day, and then think to yourself, "Fuck, I fucked it all up," and like have massive regrets because you didn't put in the effort when it mattered. That's what I'm trying to tell you guys, right? It's not, oh, I didn't make money, or no, it's not that. It's like you don't want to be like, ah, shit. If I only didn't fuck around for 10 years straight, then I could have done so much more. You know, like, damn it. You know what I mean? Like, you don't want to be in that, because that's not a nice situation for anyone to be in. So that's why I'm trying to tell you guys this, is not to make money or, you know, whatever. It's so that doesn't happen to you. Off topic, but what's your biggest challenge when you're learning game development? Time. It's like I literally feel like I don't have enough time to learn all this stuff. Have I been in that situation before? Somewhat, yes, but it's not to the degree what I'm talking about. So I've been like, if only I just took programming seriously, I would have been better off. Yes, I feel that pretty often, but the situation you would end up in that I'm describing is like, I don't know, you're 60 years old, you're kind of sick, you can't do much anymore because of some injury, or you're ill. And then the plans that you've had in your head that you've always wanted to do, you can't do because you just didn't take things seriously. That's the situation you want to avoid. And I think if your potential is to become, if you want to forge a path ahead that's creative, or you want to forge a path ahead, you just want to provide for yourself and, you know, do whatever. You don't want to like feel like you've messed it all up. So yeah, the ability to have self-reflection and awareness that you need to change something, then you actually follow through and making the changes is something that few people can do. 100%. Yeah. What if I'm in my mid-20s and also are you financially comfortable and independent right now? Financially comfortable somewhat, and not quite independent, no. So I can't say that I've made it. I don't want to claim that. So I do feel that kind of regret still. So if you're younger than me, guys, you know, and you want, I don't know what you want to do. I literally have no idea, right? I assume programming because you guys are here for that. I don't know. You know, if you do, yeah, I want you guys to succeed. That's all. With whatever that may be, so you can forge your own path, and do what you want to do in life, so you don't end up, you know. Because I do have some regrets personally. If you want to do something, do it now. If you want to do something, do it now. Is what you mean, yeah, to put it bluntly. Yes. And that might be uncomfortable, right? That might be, oh, I need to practice maths for 6 months straight. I don't know. You know, it could be a lot of things, right? If you're taking it seriously, whatever it is, you know, it's sometimes gonna suck. But like I said, it's gonna suck worse when you realize you didn't take life seriously and you can't do it. You can't achieve anything. You can't achieve the things that you wanted to achieve, and you fail to live up to your potential. That's gonna hurt 10 times, 100 times, maybe infinitely more. I don't know. It's gonna hurt so much. Needed this pep talk. It's motivational. I'm glad it's. Everything sucks at first. The first times are the worst. Yeah. So yeah. So I would say that to wrap this all up, you know, don't fall for the. It is true that you have time, but I think that's a siren call that will pull you in a direction of directionlessness that can eventually lead to massive regret. And Relics in chat has said things that are quite cool. Like, you can have like skills that you don't have to have like one master skill. You can have multiple skills that compound together to have a good foundation. And this is all about forging. I'm saying this all so you can forge your own path in life, and, you know, support your friends and community or whatever you want to do in life. This isn't necessarily about making tons of money. That can be related. It's not necessarily the thing, though. You just don't want to get to that point where you kind of regret not taking things seriously. So that's everything wrapped together. Thank you. After work, I'm going to start learning Vulkan. Yeah. Wish you the best, guys. And yes, just an addendum. I should have mentioned this. If what you want to do in life and you feel like you need to do something that is creative, I don't know what that is. You have your own. You probably have you'd have to look inside yourself and you feel like, I really want to be a creative type. Unfortunately, that's a harder path to follow, generally speaking, than other paths. And it's going to require it's going to require more effort to, you know, develop those skills. Just be aware of that. And if you're aware of that, then that's fine. I'm also in that boat, by the way. You know, trying to make a game engine is I believe to make a game is a creative thing, right? And I'm trying to, despite being 33, you know, I feel like I could have been better if I didn't just, you know, pick different things and you know, waste time on things. Learning Japanese wasn't necessarily wasted time, but if I just took things a bit more seriously, I would be in a better situation than I am now. But at least I'm taking it seriously now, right? You know, I've got how many hours in my logged thing? Oops, nope. You just bear with me just a moment. Go into here. Come on, load. Yeah, 2,205 hours. You know, that's like a non-trivial amount of stuff, right? You're only like 18. Yeah. But there you go. The younger you apply this, the better. But I wouldn't say you have to become a programming monk. You don't have to go nuts. You just have to, you know, step up to the plate and take things seriously. Anyway, so I think I've said enough on this. I feel like if you want to talk about this more, you're going to have to ask me a question about it. Because, you know, I need to I need to apply my own advice to myself, right? Otherwise, all this advice is a waste of time, you know? It's like hearing an old drunk talk about how good he was back in the day if I don't bloody make something of myself as well. Anyway, so... But yeah, I believe you guys can do it. Truly. If you need to hear it from someone, you guys can do it. I don't know if you needed that, but yeah, if you needed that, then there you go. Let's keep going, dude. Yeah, you got to remember that Tokyo Spliff, who's got, what, over 100,000 subscribers on YouTube, making his own game engine as well. He started programming when he was 28. And now look at him. You know, because he just took it seriously. Like, you can take this seriously and get good very quickly. Right, we want to do a compute pipeline, and I'm not entirely sure how I want to do this, actually. So I have my old engine, which I'm going to look at, and just see if I want to be inspired by that, or could do something completely different. He started writing the Vulkan graphics for his engine now, yeah. Yeah, he's literally just said that, yeah. I liked his comment. Right. So graphics pipeline. Let's see. Sorry, compute pipeline. Where is my graphics pipeline, compute pipeline set up? So I've done a compute pipeline here, but I did it with this horrendous node JSON thing, which I think was a terrible idea. But I think there are compute shaders, and I want to see how he creates, how he creates. I don't know what. Referring to myself in the past person, creates these things, and I don't know if I'm going to follow the same idea. Because I do have like a struct that I build up and then I pass it in. YouTube UI casually putting me in effing shorts after I press the wrong sequence of letters, thinking I'm typing into the chat. Oh, no. Oh, well, yes, there you go. Alright, so... So we pass the pipeline. So I'm just going to have to remember how I do this. So there's the techniques. We go in here and we get the GPU technique. Yeah, yeah, it is quite frustrating. I don't know why it's doing that. Gonna make me on Spotify soon. Yeah, please share it with us once you do. Alright, so we have... Right, so when I do a compute pipeline, what's the difference? Because the graphics pipeline setup is going to take in some data. Inherits from, so there's an inheritance thing. Is there a compute version? Is cached. So that's the reading of JSON, I think. Oh no, wait. No, this is reading of the thing. Okay. Oh of the thing I just created. Yeah, I've just set loop. Play songs or off NAS or something. Yeah, I can do that. I mean, I've listened to this for a couple of hours. I just can't listen to that. I can turn on this. There you go. At some point, we're all gonna be. At some point, we're all gonna be one shooting Claude code to create our own Spotify and other apps. Yeah, I think for me, even if we had a perfect AI that wrote the code for us, I'd probably still write my own. Compile. Sorry, that's my Windows noise. Right. So, okay, here we go. This is it. So it is just pulling through the pipeline creation. So when it goes to pipeline creation, there must be a compute slash. Okay, so it's depth. Okay, so is depth. Okay, so this is a bunch of gobbledygook. So the render passes, which we're not doing. What? How do we know if this is compute or not? Compile so we compile shaders on the fly, which is bad unless you want to have a particular system. Any advice on how to read books like 3 Easy Pieces OS and TCP IP Volume 1? Well, you don't really need to read part 3 of 3 Easy Pieces. So it's effectively 2 Easy Pieces that you need to worry about. And I personally go slower through these than most people. It depends on how deeply you need to know it versus how much breadth you need. So my recommendations are going to be different from other people's. I personally would say reading 2 chapters well is better than reading 5 chapters poorly. Despite, what other people would say. So I would personally take notes on what you're reading, re-summarize what you've read, and write them in Obsidian, which was what I do. And I've written that for some of the operating system stuff, then do the homework in the operating system in the 3 Easy Pieces. It's not that complicated. You don't have to go into super depth as long as you're understanding the general concepts and can explain it to me or someone else or yourself. And yeah, that's what I would do. TCP IP I've never read. And I don't think I will because I'm not into networking. I don't want to do networking. But yeah, I think same thing applies. My philosophy is, like I said, reading 2 chapters well is better than reading 6 or 5 chapters poorly. The downside of that approach is you're going to take longer. It's going to take you longer to go through resources. Okay, so it doesn't actually say. So I'm going to actually search compute. Okay, here we go. Finally, compute shader pass. Right. So if the name is compute, okay. So it literally is just setting things up. So when we actually create these things, so when we do, actually I just need to know more. Create render pass. This is so, just, can you see why I stopped using this engine? My goodness, it is a mess. I'm going to practice being dead for a few hours. Well, yeah, good luck. And then wake up. Back to continue programming and work. If you're still working, I'll hop in. Yeah, thanks for Alex. Good night, and I hope you have a good night's sleep. No problem. Trade. I hope. Yes. But I know. Like, Coding Jesus. I'm just not that smart, right? Maybe people like Coding Jesus can just read a book, because I think those books have come from Coding Jesus. If you don't know who he is, he's just a YouTuber who talks about how to become a quant developer. And he may be just really smart and can just remember everything he's read immediately, but I'm not that smart, I'm not that talented. And I think most people aren't, so I think generally speaking it's best to go slower, take notes. I don't really like Coding Jesus, to be honest. Yeah, fair enough. I mean, he kind of shields his platform a bit too much for my liking as well, but it is what it is, you know. Okay, so when we... I'm not gonna worry about it too much, so we go in here. I think this is what we need to do next. So if I look at this, hang on, this is peeking here. So it passes... Now, where's the actual pipeline creation? That's what I want to know. Like, parse GPU pipeline isn't the same as create GPU pipeline. As far as I'm aware, anyway. Unless I've missed it at the bottom. Because this is building up the pipeline struct. So this comes out, and... pipeline creation comes in here. This becomes part of this thing. Okay, so this is... I think this is it. I prefer... I mean, not just memory, but probably smarter. Yeah. I prefer reading books than grinding leak code. Yeah, it's... Yeah, same. In the same boat, I've been reading the books that CJ recommended. It takes me forever. Yeah, I take notes of Obsidian. Yeah, that's 100%. Weird, my message disappeared. Is my message... no, it's not, Dimitri. Yeah, good luck with that stuff, because it is kind of tough, guys. I understand. Like, he recommends like 4... Like, I think he recommends like 4 C++ books to go through in order, which is kind of nuts. But I think you could probably get more juice out of the books if you just took your time, so you don't have to read as many. I would, assuming you took notes, right? So when we create a pipeline, what do we do? So pipeline creation has... Right, okay, so let's look at this. Yeah, it's literally the same deal, but I'm trying to figure out like what the difference is. Like, what did I end up doing? So if the cache, yes, we're not going to ignore that completely. Like, because compute is completely different. Well, it's just way simpler. And if we're just like creating a... Is there like an if statement that skips like import assembly and stuff? Haskell is too niche for anything. It's just recommended to do in my college. Oh, I see, yeah. Oh, are you talking about leak code? Yeah. I don't... Oh, here we go. Graphics pipeline. If... And what is this? Right, okay. So if it's false, let me do a compute. So I assume... Da-da-da-da-da. Else... There we go. Okay, so it's much, much simpler, yeah. So VK compute pipeline stage, let me just say the shader thingy, the create compute pipeline, and then we do a bind point, which is, what is this? Oh, okay, this is a Vulkan thing. So, okay, so we have 2 different things, right? I'm not sure if I have these in my engine, but we'll have a look. Okay, so that's actually really nice. We can just use the... So I'm trying to integrate this into my engine in a way it makes sense. I could just like write the compute pipeline just straight off rip, you know. But I'm trying to integrate in a way that makes sense, so I don't have two different ways of doing the same thing. Where's that if statement? So shader, this is a shader stage. Max shader stage. Okay, so yes, we can just throw this in here and kind of set this to false. Cool. Fantastic. And that's how we're going to do this. That's how we're going to start, right? Disaster. Well, yeah, that's a good. I actually don't know. That's actually a really good question. I wonder if Angelica knows. Angelica is a cutie knows. Right, so where's our graphics pipeline set up? So we need to see shader stage. Yeah. Oh, there it is. Wait, I already do this. Wait, what engine am I in? Oh, I'm a doofus. I'm a doofus. Let's get rid of that. You can look them up. They have resources on their official website, but most free ones are outdated. Damn. Indeed. Okay, so, how do we work out if it's a create shader stage? Do we have a is thingy? It's just BRV import, we're not going to do that at all. Right, that's very simply just says, oh, whatever the type is. If the type is... Alright, cool. And when I create shader stage from the shader creation, okay, this is fine. That's the lower level stuff that we need to build back up from here. So create pipeline shaders, and as far as I'm aware, create shader creation. When we create a pipeline creation in our main, doesn't let the message though. If it has a link, Dimitri, it won't let you send that. If you need to send me a link or something, you're gonna have to send it on the Discord in like the resource channel or in DMs. I don't know if you're trying to send a link. That's something it just doesn't let you do. Okay, so the shaders. So we have this, and when we have a shader stages. So we set the stages. Cool. Okay, so this is all just gonna work, I think. And we don't have a descriptor set. We just have. Yeah, we don't have a descriptor set at all. We don't have textures even, because it's a. Okay, cool. I'm being very slow here, but I'm being very deliberate. Hopefully that you can see that. So where do I want to construct this? This is tricky. So we need a new graphics pipeline. Oh. Right, yeah, that's why I didn't send it. You can't send that many characters? That makes sense. Yeah, I've just seen your message, Dimitri. Right. So what I'm trying to do here, I want to have a compute pipeline set up. I'll read that message later. Now, let's read a little bit of it. So, Demetrius sent me a bit of a message here. So, I'll just say, hello, I've been watching your code for a while now, and I'd like to share my experiences with you. I noticed that you really don't use assert mechanisms. In short, I want to say that this was a non-trivial for me. I only started actively using it after 10 years of programming experience, which is a long time. Cool. I do use asserts, but not as they're called void errors and void asserts. I think I've just hash diffed them to something else. Right. So where do I put? I don't know where to put this. Why do I put the graphics pipeline set up for this particular thing? I think I'm going to have to put it in the main and then figure out afterwards, I think. If I think about it too long and then try and come up with a data structure, then we're going to end up in a bad situation. So we need a new graphics pipeline here. Sorry, a new pipeline. We need... yes, we're just going to stick it here. I'm going to say compute. That's just script set layout. Oops, that's not what I want at all. We want compute, particle compute, I don't know, particle compute pipeline. Bro, I'm in the 4th year CSE, computer science engineer student, learning DSA and C++ and MERN. I haven't heard of MERN before, but I don't feel excited about it either. I'm mainly doing them because people say they are good, they offer good money. How can I find genuine interest? Personally, I would always say develop the software you want to develop. I don't know what that would be for you personally, but if you're really interested in, say, audio, like build some audio software. It doesn't matter what people, suggest. There's the most money you can make out of software engineering is quant. Doing quant development. But if you're really not in it, like enjoying it, then I don't know if you're gonna get good enough. I don't know. I really don't know. That maybe a bit. It's a bit harsh but yeah, just find, the general advice is just find something that you're interested in. And if there's nothing that interests you right now, just explore, right? If you're into video games, try and, like, hack a video game. I don't know. That's often a thing that people like to do. Nathan Baggs has a bunch of YouTubes. If you know about Nathan Baggs, he does that. He fixes games by hacking them. I don't know. It's all very it's all very up to the individual. So compute, particle compute, and also learning DSA excessively is often not necessarily the best thing to do either. I don't know. I should become like a. I don't know if you're in India, but that's the only place that I've heard like it's absolutely necessary to know every single data structure and algorithm that exists. Yes, we don't have any depth, I don't think. But I don't think it's as necessary as people think it is. It's like it's a bit overhyped. There's a better profession if you are solely in it for money. Yeah, 100%. Even that, yeah. Quant. If you love computers and you still want to make tons of money, yeah, quant is the way to go. But even then, there's probably better. I don't know. Like being a finance bro, you know. So pipeline creation. So if I have a compute pipeline, how do you deal with this, sir? You better not automatically create everything from scratch. Cool. Right. So that hopefully. Let's use a breakpoint here and see if we have a generic. All right. Cool. Let's do this. Let's build. Let's read a bit more of Dimitri's message. The idea is that I often it's about asserts. Function code relies on underlying assumptions about the programmer's state, and it happens that a variable isn't. Oh. Okay. Yep. Programmer state's fine. Is this done? Okay, it's done. Yep. Let's see. Okay, let's see. Let's go in. Alright, let's go. So hopefully you don't blow up and do something stupid. Yep, that's the same size for everything. Create pipeline layout. Do we even have a pipeline layout? Right, is this correct? You had an assert, which I think. Right, okay, so we now need to build up the graphics pipelines, which is fine. The pipeline layout is valid. DSA in India is so hyped up, I think it's something you can... I think it's something like take a week to learn, or learn on the fly while being... And on the fly, but here it's treated like it'll guarantee you a good career or something by DSA alone. Yeah, that's why I don't understand the big loose goose. I don't. It's just very confusing, like why that's the way it is. Okay, so what do we have in here? I'm not going to say if it's good or bad. I'm just going to. It is just kind of. So you know when I say like. Maybe you need to know it because you're in India. It's maybe you need to know it because that's the only way to get a job in India. I don't know. I've just heard that it's like extremely hyped. Yeah, these need to be like this. I actually haven't transferred all my code over. Let's I don't think it. Yeah, I think it's good to know some of the stuff, but I just don't understand the, like, no DSA or die kind of thing, kind of attitude. It's like, there's other things to learn. What is DSA? Data structures and algorithms. Bro, here companies only shortlist if you've done like 500 leak code questions and have a good rank. Yeah, that's the problem. Yeah, I don't understand that. I don't think that necessarily gets you good programmers either. That just gets you somebody who's really good at leak code. I mean, it's a bit harsh to say this, but if that was true, if leak code was the best, you would probably see the best software engineers in India. And therefore, like, the best software being created in India. And I don't think that's true. I don't know, I couldn't judge, but I generally don't see like new graphical, like game-breaking graphics engines or operating systems that are like, you know, insert thing here that's really impressive coming out of India. But that's not coming. There's a lot of people that's not coming out of everywhere. Like Poland for some reason has got really good at graphics, so there's like graphic stuff. Well, it doesn't... If you don't know... You're not using Indian software, well... I don't think you can know where the origin of the software comes from, so that I'm not saying that Indian software is bad either, by the way. I just don't understand the obsession with it. DSA. Especially with AI. I feel like that's the thing that AI can do really well at the moment. But anyway, it is what it is. I think if you want to be a competitive programmer, sure, 100% get really good at that stuff, but I just don't get it. Yeah, leak code is incredibly boring. I was able to solve 2 problems well. Yeah. Yeah, I don't think if reversing a binary tree is... Yeah. It's like... Right. I won't go down this rabbit hole too much, but like... DSA is like... specific to the field that you're in. Like, no one in leak code is learning how to build a hierarchical Z buffer, right? Like, that's an algorithm that needs to be written in a compute shader. But that is very common in graphics. So if you're going to learn graphics, then you're going to have to learn that. Rather than learning how to... what the sliding window is, you know? I just don't get it. I don't understand. Majority of technical interviews ask for good base in DSA. That's why it's hyped up. I see. There is an entry barrier to be hired, and that's required DSA. Could be wrong though. I'm unemployed. Makes sense. Yeah. Yeah. That's what I think too. Yeah. That's what I've heard. So you know, that's why I think like learning DSA is probably more important in India, but I don't really know why the companies are obsessed with it in India. Anyway, because like I said, I don't think it produces better coders. What am I trying to do here? I've got completely lost. Oh yeah, I'm looking for my where are my notes gone? Oh, it's a rough note. Yeah, I remember now. I was trying to look for something I couldn't find. Let me just look for this for a bit. Right, so yes, I'm trying to grab my compute shader here. Bum, 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 bum. And that isn't to diss that country, by the way. It's just I just don't understand the I just literally don't understand the companies, not the country. Oh, yeah. Scalar block layout required. We need that. Okay, so reference. Right, let's grab. Oh, we need both? Okay, I didn't realize we need more. Oh, okay, yes. I didn't realize. Right, let's put this in. Yeah, it is what it is indeed. $29, syntax error. Right, okay, so yes, we don't have these guys, which is... And... Draw commands. Yeah, I'm gonna get this reference. I feel like it's overused. PTR maybe. It's kind of getting annoying, kind of writing reference everywhere. It's technically a reference. Yeah, draw command count pointer. But isn't it true that being good at DSA improves your overall logic and problem-solving skills, which can be useful in web development, game development, and making software, making software for business? Yes, that is very true. But there's more to coding than just your logical abilities and problem solving. And you can also improve those by just writing software. The thing is, if you write software, you get more skilled at that. You get more skilled at writing software. Kind of may seem redundant, but if you think of it like this, right? The more you write that software, the more of an expert you become at writing that software, right? So, if you want to get good at that, I don't know, like gameplay, like what we're doing here, game engine development, it wouldn't make sense for me personally to spend any time on LeetCode to get good at logic and problem solving. It just makes more sense to do this. And like I said, I don't see having a really good LeetCode thing. I think just gets you really good at LeetCode, not necessarily. Not all it can transfer. It's like it's a nuanced thing. It's a nuanced thing. Yeah, it's so for example, if you wanted to become a quant developer, because that makes most money, like learn to do quant specific stuff, not DSA, unless you absolutely have to for a job. I don't know, because India is very, like I said, the companies love DSA stuff and LeetCode. But you're going to become a better quant developer if you do quant specific stuff, right? So let's just see if that works. Yep, cool. And if I build my graphics pipeline again, we have like there's lots of DSA stuff for games specifically that I need to know, but it's not ever going to turn up in LeetCode. So generally, yes, I would improve if I did LeetCode really like crazy, but I'm going to improve faster if I do this. That's the general thing. 0 active layouts. I don't know if this is going to work, so... Right, so we need an active layout for our, I think, buffers. So let's just copy what we did earlier on, because we do have some. So the debug graphics pipeline. So the shader VK compute push constants, but VK layout doesn't use. Oh yeah, you're right. Okay. Yeah, that's really cool, that. It's like, say, don't read maths, do maths, yeah. Yeah, LeetCode tests for, like, puzzle solving, which is, like, 10% of actual work. Yeah, I admit that. It will, like I said, you will get it, better at problem solving, but solving puzzles is a slow way of doing that. It's nuanced. It's all nuanced, right? It's all like, but I think, yeah, I just don't think it makes good coders. I just don't see it. I don't see like the highest leak code rank person like writing the best software. It's just something I don't see. But again, if you're a competitive programmer, this is 100% a good thing to do. So the pipeline layout. Okay, so what do we need to do here? Sorry, it was a bit quiet then. It's like solving Sudoku to prove math theorems later on. By the way, what feature are you working on today? Are you still on builds? No, I'm trying to do GPU driven rendering. So we're trying to build up a compute shader that's going to be GPU driven rendered for like millions of particles. So yes, this is the beginning of like the particle system. But what I'm trying to figure out is the pipeline. How do I set up the pipeline properly? That's the thing I don't quite understand. Because we don't have anything other than like in the let's look at this. This is the thing I don't. Oh, the push constants. Oh, I'm so stupid. Concentrate, escape point. Come on. I'm letting my brain turn to mush. This is stupid. I'm being stupid. So yeah, so immediately okay, so we need to make this kind of make sense for us. So what I'm going to do is pass in a compute version of this instead. I think that's the best way to do this, I think. Or I could make another struct for the push constants that I want to use and kind of fill it up that way. Let's see, how do I want to do this? Everything else has got this struct idea, so I think I'm going to do that actually. So creation. So yeah, let's make a push constant struct. So push constants, because this needs to be. What the heck is this? Oh no. Push constants creation. Yeah. So. Where are you? Take this. Right. So, how are we going to do this? I think I'm going to be very lazy and just go into the create struct thing. So when we're trying to create a pipeline, we need three things. We need the stage, offset, and I think there is some transferability to learning DSA. I don't think learning DSA, by the way, guys, is like a bad idea. That's not what my... It's like learning too much DSA is a bad idea. Like, if you don't know what a stack is, or like how... you know, how arrays work. I think if you went really hard on what is it called? If you went really hard on like the array part, like the basic array stuff on LeetCode, you'd probably be better off as a programmer. But I think like getting to like solving, I don't know, 500 plus things on LeetCode is probably a waste of time in the end. Like learning DSA is good. I do say that in my guide. But going too deep into LeetCode is probably a waste. You probably just want to specialize in what you actually want to learn. And if you enjoy LeetCode, that's fine. Yeah, so I wasn't like hammering, like saying DSA is a waste of time. I think it can be, hopefully it didn't come off as that. It is worthwhile to do some, so what do you want to do here? We want to reset, I guess. Reset, and we could do stage, size and offset maybe. Yeah. Doesn't really matter. Set, I don't know, create push constants. Alright, cool. Let's go with a default construction of maxenum. So we get a nice error. Didn't mean to do that. So if we forget to do something, please paste, don't duplicate. Thank you. And if we take these, go into. No, I kind of want to copy everything here. Go to this actually. And now we want to take this and do this. Go this in here. Nope. It's because it's commented out stuff. So reset and oh, we didn't do the arguments. So let's go with this flag and uint32 offset and uint32 size. Right. Oh. Cool. This goes in here, and right, yeah. In size, and then offset equals offset, not in offset, and in size. Right. push constants need to be added to, which it is. Okay. Then we are going to go to... Okay, so some things don't have a push constants, which is good to know. If I have... Okay, so... If we go to game, and we set the push constants up here. We go, okay. So we should be able to set it. Let's see. Our push constants. Okay, so then we do what, create, and then we have our shader stage, offset, and 16 because we have 2 bytes, 2 things in. And then if I want to take this and apply it to other things, I will in a minute, but I need to make sure that when I go in here, we have a push constant set for... So if I want to skip this, because we want to make sure that we have a skip, if push constants so our creation dot push dot stage flag is equal to our max is not equal to this, then we want to set through and just set this all up, else we don't want to set it. So oops, this would be this, and we need, so let's just do this for everything for a minute. Offset and size. Okay, that's going to do it for everything. We don't always have a push constant. Now we need to set this up for every single... right, yes. Okay, so this is a whole thing related to that. How do I do this? Else... So what I'm going to do is take this out, put this up here, and only if we have this. Now we've got to make sure we don't have a dangling pointer here, and it can delete itself. So I'm going to move this out, put this here for now. It's just an empty thing. I just don't want to make sure that this gets deleted by the... Yeah, I think it would be. Yeah, the lifetime of this would die, and then we would have a reference to nothing. Yeah, that's good. Larger projects, create some kind of different content for programmers' parts. To me, that's more enjoyable. Fair enough, yeah. Like man versus machine, man versus himself, man versus nature. Valid, valid. Everyone has their preferences, 100%. I like solving problems. Yeah, code for... Yeah, sounds good. I mean, yeah, you have competitive programs. I think the most... I think you can also look at the... lead code questions are giving too much shape for an answer, I guess. As far as I have had seen, it's always have to be a solution optimized for data analysis. I think it would mean shape to the problem. It's like because it's a puzzle problem. It's a bit too, you know, it doesn't match real world as much. I think just to touch on this one more time. I hope I haven't made anyone angry with this, but with leak code, you could easily say that. Let me just think for a minute. Sorry, I'm not concentrating on what I'm saying. I'm just concentrating on the coding. Yeah, sorry. Competitive programmers, I think, even say that being a competitive programmer doesn't make you necessarily a good programmer overall, right? So debug. Right, cool. Next. So we got to find all the pipelines to do this with. Right, next is the main pipeline. But I think we all know this. This is not like uncommon knowledge, right? And so, like I said, I've never understood the drive for some places to get obsessed with leak code. I make some joy of the best specialization solution. It's when there are some features that I have constrained. It's like I can solve for a chunk which fits in the L1 cache, ditching hash maps for vectors. Yeah, I see. Okay. Yeah, I see what you're saying there, Dimitri. Yeah, so you know, if people love leak code, I'm totally for it. As long as you're having, you know, enjoying life, loving stuff, then it's all chill. So it's 24, 100%. Is it used in here as well? Do I use the push constants? Apparently I do. Let's see. Yeah, I don't use that, apparently. Do I use this? Do I use this? Okay, yeah, I use that. Fair enough. And the fragment shader. It's all these together. Why aren't... Really? Damn. Right, so we go in here. We're gonna go in here. And I'm gonna cast that because that's being stupid. Okay, so we need to find all the pipeline creations outside of here. So we've done that, that, and that. With a 2D pipeline creation. Cool. Next is... Alright, cool. Let's go here. So for our 2D shaders, what do we have? We have a push constants of 2, 16. Is it using the vertex shader? No, fragment shader. So we can just make this simply 16. If someone talks about leak code and glazes it, I know it's extremely toxic, yeah. No, yeah, Keen, you're fine. You can talk about. I don't mind people talking about the leak code at all. It's like you know, if that's making you happy, then it's fine. As long as you're not putting people down for not doing leak code. All right. What do I have here? I have. Okay, so we have 3. So, but it's not used in the vertex. It's not used in the fragment shader. Nope. Oops. Let's go to our 2D renderer. Grab out this fella. Go to our skybox. Go in here. And this is a 24. Look at me, knowing the 8 times tables. All this leak code talk is making me realize I should probably do some leak code right now if I want a job in my country, lol. I shall lurk now. Thank you for the good advice and talks. No problem, Tan. Thank you for joining us. You can be toxic, but not in the toxic... No. Like, people talking about their leak code is fine. Like, if you have a high leak code score. But if someone's like, my leak code's better than yours, like, you must be a bad programmer. Like, that's like cringe. No, we're not into that here. Outside of that though, it's chill. Okay, so we have, I think, everything. Yeah. Oh, you meant putting people down. Fair enough. I think leak code does not make you a better programmer. It makes you a better pattern recognizer and increases your problem-solving creativity. Yeah, I can see that. But I think, like I said, doing that in the field that you're going to be becoming an expert in is probably what I would do over leak code. But, you know, to each their own. And also, I understand people's countries leak code is valued more. So let's just see what I did. I'm broke, right? Bleh. Right. Okay. Where are we? Oh, I wish I knew. 2D quad. So we're in the 2D renderer. Oh, okay. So we're doing the what? The push constants in the 2D renderer is in. Oh, it's the main menu. Interesting. Did I miss something out here? 2D renderer into its. And in the 2D renderer shaders, we do. We say there's a 16 push constant, a 16 thing push constants. Okay. Oh, I'm pretty good at multitasking. I was born into a household full of like noise. So yeah, I can totally deal with this. Like, I'm the oldest of 9 other kids, so it's always been noisy, and I'm kind of used to it. What am I doing here? I do get distracted though, like right now. I'm a bit lost. Like, what am I looking for? I'm looking for my 2D shaders. And I'm trying to say that, okay, yeah, there's one here. That's definitely a push constants. But there's nothing here. I don't understand. What? Oh, did I copy this over? Oh, I might have. Oh, okay, it's telling me the opposite. I've set it up in the wrong place. Okay, okay, so push constants is... Yep, size 16 doesn't have any push constants in the fragment shader. Yes. Yes. What is happening? Do I... Oh, do I not... I might not be setting this up correctly in here. Okay, so are we doing anything here that's weird? Alright, I'm gonna look for this everywhere. Okay, that's good because space, there we go. And right. Okay, so yeah, that makes sense. So we need to do this very carefully for each pipeline. And yes, okay, so that's what it's complaining about. I've set this to fragment for no reason. And here, which is also a 2D renderer. Why is there 2 of them? Oh yeah, draw 3D quad. That makes sense. So for a debug renderer, we don't have them in the fragment shader because there's nothing in the fragment shader. In the... Where are we? Which pipeline? main pipeline, there is one in the fragment shader. Yep, that's fine. And in the skybox, there is only one in the vertex shader. Right, okay. That should have fixed that. I call it unit tests, not tests. I'm only a child, and that's noisy. Fair enough. Right, we are done with that. Okay, right, done. And we've technically made the engine better. And we're not shutting down all the resources. What are we missing? A resource pool. Oh, we haven't shut down the pipeline. That makes sense. That's what we're missing. I will do that, actually, because that is important, so I don't forget. Right, cool. We are shutting down, also, the compute pipeline. Got so caught up on the push constants. Particle? I don't know what I call this particle. Particle. Compute. No? Yes, okay. That should be okay now. Cool. Fantastic. Right, now the difficulty begins. So we've set up the pipeline next and the shader. Now we need to do this stuff, which is the hard part. I think I'm going to put this in its own class, its own function, just because, okay, we're going to change the music. We've got stock on some tracks. Let's go with a... I'm really enjoying these, Dragon Ball Z musics. Right, okay, so our engine's a little faster now, in theory. Assuming that the graphics driver is taking the effort to do something for us. We need now to make a new function that does this, because I need kind of like to encapsulate all my stuff in one place, I think. So create indirect draw call data. Let's say setup draw call, something like that. What are you saying there, Dimitri? Making some short, complicated programs is good. Yep. That is good. I think anything that like captures your interest and is engaging is probably really, really good. Alright. Now we need to go into here. And what are we doing next? We want to grab the creation of the indirect buffer. So at the very least, we want to get this done, and then we'll have we'll start the GPU-driven rendering. Now, some of this is going to be wrong, but this would be a. This is tricky. This is a GPU device level thing. Now I think about it. The problem is when I do a create buffer, which is what this is from, we're doing something complete. We're not doing the same thing as we usually do in create buffer, I don't think, because we need local device. We're always assuming that it's not local device. So I think what we're gonna have to do for create buffer. Alright, so let's just copy this out for a minute. So the problem is we could just do a GPU create buffer, right? And this takes in a buffer creation. And I think we need to modify this fella. To have extra stuff in it. Because right now everything's host visible and we can't do that. So we can do the basics though. Alright. So we set the name to, this is the buffer, sorry, the indirect draw count buffer. Right. Next is the size and the flag, right? Usage, which is straightforward. We also need the required flag there, which unfortunately makes it kind of tricky. Now, right now, I could just say that we do two different things based on if it's a GPU buffer versus not a GPU buffer, right? And add a boolean into the creation struct with no initial data. So yeah, we could do these things. Hang on. Instead, it doesn't really. Whoops, it doesn't really matter. Right. Whoops. Delete. No. This, please. Right. So we have the flag, which is. What are we going to use this for? We're going to storage. We need to. We actually need to steal some of the things that we just commented out, actually, instead of doing that, because that's just going to be hard to remember. So the usage I say is it's always transfer. That's the thing we say. This is the problem. My code is too generic, and it assumes too much. Oh dear, this is tricky. I mean, I could just make another class, but I feel like for what I'm trying to do here, maybe that's a bad idea. So what I'm going to do is just head to the loo real quick. I'll be right back. Nope, that's not what I wanted to type in. Alright, so just bear with me just a moment. So I think I might hard code these in actually. But we shall see. To the loo indeed. Right. So, the problem is right now is that this is too specific. Sorry, we have a lot of different buffers to set up, and one of them does not require a transfer flag, which I always assume is true. So there's a lot of assumptions here I'm making that's probably a bad. I'm just going to go to the next one. Nah, I don't want to listen to... Let's go to this. Fine, that'll do. The coolest solution, in my opinion, is to make a Python script and make C++ libraries to make it also compute as well, and make an lang interop. Is that the project you were talking about earlier? Like a project idea? Right. Okay, so we need to work with this, I think, instead, rather than a creative buffer. I'm not going to do this. It's just going to be too annoying, and I don't really know how to solve this architectural issue right now. The rest, though, I can just go GPU. I think we have access to everything, assuming this is a pointer, right? So everything we're missing is literally just this. Now, I don't know about this check. Is that a thing? No, I didn't think so. But the rest is fine. Right. So we do want to have this buffer handle. Where's this buffer handle created? Yeah, so we set this buffer handle, we do everything with it. Yeah, and that gives us everything that we want. Okay, cool. So we should have created a buffer, and I'm going to put this here. And now we can... Okay, check. This is tricky. How do I do this check thing? The problem is create buffer. It's not good enough, and it's going to get really complicated if I try and do stuff with it right now. And I just want to do the simplest thing because it's the easiest at the moment. So, right. So, right. Let's just define this as well. No. What do I want to do? I'm just sharing my ideas with the repo to help someone get hired. Oh, I see. Right, yeah. That's a good idea. Yeah, thanks for sharing, dude. Right, so... Can I just get around this and just... Yeah, let's just do it the normal way. Again, I'm kind of taking liberties here with the shortcuts, but... What am I doing? That's the wrong place. So what I'm going to do is that, and we don't have the VK result yet, but we will. So VK result equals that. Get rid of this here. There we go. So now we should be able to run this and check if it works. I don't know where though, but this is all pre-set up, I think. So for now, I'm going to just kind of put this at the bottom to make sure everything's created. And we should have a buffer. So we should have a buffer that we can use with a buffer handle. And what I'm going to do next is grab and fill this up with a command buffer. Unfortunately, next thing I need to do is kind of annoying as well. So now I need a second function. And it's going to have to take in a command buffer. Right, I'm just going to say like run compute shader, right? Run particle compute. The reason I'm kind of just super generic here is command buffer. Do I want to do? I'll do. This is just going to be the same guy. This is going to run at runtime though. That's the difference. And the first thing we're going to do is transfer this memory from one thing to another, and just see if we can do that with the pipeline barriers. New here. Hello, AIM bots. How you doing, dude? Hope you are having a great day. What we're doing here is at the moment we are trying to get our indirect draw calls working for particles, which will be nice. And yeah. Yeah, aimbot broken heart. I guess many gamers have fallen to many aimbots over the years. Anyway, so now we need to grab the pipeline barrier stuff that we did yesterday, and then we can start debugging this with anger. Again, we're going to use the GPU here to access a buffer with the indirect draw call counts, and that is going to take in what does it want? Yeah. So it just needs a VK. Okay, so we don't use the address here. And oh, that's true. VK command buffer. Right, so hopefully I don't have to do any other synchronization. This is all ran, I think, at runtime, because we need to do this at the beginning of the loop. But now we have a pipeline barrier, we fill up a buffer. We should be able to do this. I'm creating my own APK for learning Python. Can you test it? I have no way of running those packages. But yeah, if you want, you can join the Discord and post a self-promotion to your GitHub. I would suggest not to run random executables that you don't know about. So yeah, it's probably best that you can, if you can share your code, then you can probably get some feedback if you ask for it in the self-promotion section. Yeah, just a warning to anyone: just be careful running executables from the internet. You can get your computer nuked. Oh, this is stupid. So, what we're going to do here is just make sure our command buffer is set up, because that would be kind of dumb not to do that. So I don't think we need to set up a bind a graphics pipeline, but yes, I want to do this basically immediately because I kind of want to see is it safe to test random APKs? I don't know much about app development, and I assume not. So oh, this is a pointer. Oh, okay, we're making this a pointer then. Didn't know. Doom, 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 doom. It is not. Yes, I had a feeling. So you can try my Fruit Ninja game. It's on a website. You can do that, right? But that sorry, but in that way you open your camera and play it. Creating a 3D interactive game using camera for mobile or any computer. No, I'm not gonna do that. But I'm sure it's good. Yeah, there's this thing that people can do. I'm not sure you're doing. The reason I don't want to do this. Some people can set up like a site that, like, I don't know. tries to trick streamers into playing something and then all of a sudden bad things come on the screen. I'm not saying that's what you're doing. I'm just saying that is a reality that I have to be careful of. So yes, I'm not going to do that for that reason. But like I said, feel free to post the source code and the self promotion, so people can look at it if you want some help. So yes, please don't ask me to play anything on stream. So yeah, we're not doing that. Yeah, so no more asking, please. Hopefully you can understand. Yeah, exactly. Angelica is a cutie. Right. Anyways, let's just see. So we set up a pipeline barrier. We do a compute fill. Let's just see if we actually manage to set up this buffer correctly. It's okay, dude. Yeah. You can understand the situation I'm in. I've seen it before, you see. Not a good situation for the streamer. I'm sure it's great. But yeah, post your source code and then people can help you with your feedback. Anyways, right. So what do I do with this? I don't actually exit 0. Don't dodge. Create buffer. Oh, don't it's dodgy, is that what you're trying to say? I think posting source code is fine, but not necessarily the executable. Yeah, I won't. Yeah, this is a PSA for anyone, even if they're in our community, even if you really like them. Be extremely suspicious of executables that people ask you to run. If you really want to do it, make sure they post the source code and you understand and look through the source code. But even then, the executable might not be the source code, right? So it's one of those things where you have to be careful. That's just a PSA for anyone else. But yeah, anyway, that's the problem with like running a game jam. That's the other thing. So I just return the handle, which is invalid. Yeah. So what I'm going to do then is I'm going to set the handle to be invalid, and yeah, I'm going to return as well. Yeah. All right. So we're going to set this to. Actually, we're just going to return. No, this is shadowing. This is bad. Right, cool. Right. Yeah. It is what it is. Security 101. It's also why I don't. I have my Discord on another screen, so if someone was to do something annoying and say, "Look at the Discord," I could see it off and then ban them, and then it wouldn't come on the stream. So yeah, I'm not gonna, assuming that you're immune from these type of things is a great way to get in trouble. But I think I've done okay in protecting myself against shenanigans. Because I've seen that as well. Yeah, people try and I won't get into it, but people raid Discords and like try and get the person to get it on the screen, stuff like that, and that's just like I just don't want to deal with that ever. So we are just never getting in that situation. Anyways, all right. So let's just see what goes wrong. Yeah, I needed to at least get this far, otherwise. So we should fill up a buffer with zeros, and that should be it. Okay. This is why I only did things in bits, right? And the error was dependency info cannot be called inside. Ah, right. Right. Okay, so we need to do this outside of the dynamic rendering, which is completely chill. Oh, that's kind of annoying though. We've got to oh my goodness, I don't want to listen to the song. Let's go with. I might remove it actually. Yeah, I'm gonna get. I don't know why I added this one. There we go. Does Matthew S. burn music and get stream strike? Does Matthew... This is all fine. As far as I can tell anyway. My stream has been copyright claimed a couple of times, but I've slowly like corrected and removed stuff that does that. Anyway. Okay, so we can't do this. We can't do a transfer, which makes sense why he did not do that. But I am kind of curious. Oh, I see. Okay, so does Matthew Burns' music get copyrights? It depends if it's video game music. Video game music is generally very safe because, you know, if a streamer is going to play your game and then you copyright strike them for, or copyright claim, let's use the right words here, their video, then they're not going to play your game, right? So, yeah, if it's video game music, yeah, probably. Yeah, it's probably fine. So does Matthew's burn music get... So I actually don't know. If you have a good suggestion, yeah, we can try and put it on. Anyway, so we want to pull this out of a... Where's my function call? So setup is fine. This is just a general issue here. So if I go into like loop and throw this in here. So when do we set up the dynamic rendering? Okay, so let's just do this before the dynamic rendering. I don't think it matters when we do this. So begin rendering transition. What's this doing? Right, yes. So this is a bunch of other stuff that we do. Let's do this here as well. And we should be good, actually. It's a composer for Zachotronics games. Oh, some things do get copyright strike, like Disco Elysium. And if it's that guy, then unfortunately. Right after Right Hazard. Oh, so this is the second frame. Oh, this is because we haven't finished the rest of the thing. Right, okay, so extra synchronization is required when you have a loop. Okay, let's just dive in and just do the rest of it then. Now we need to create a second buffer and also do the transition. I know we've already done that. Then we need to run the compute shader, which is done here. And then we need to transition everything. And then we need to then draw with our thing. The problem is I don't think I have the... oh no, I'm fine. I can actually do it without. This draw command is going to correspond exactly to something in Vulkan. So Yes, let's start the next step, which is... Yep, so a right after right hazard is because we haven't done this. Now, let's just check. Let's just challenge my assumption here. I assume on the first loop it's fine. I assume on the second loop it's bad. Yep. And then... right after... right hazard... oh. Oh, yeah, frames in flight. Okay, so there's 2 frames in flight here. And then, yeah, that breaks. Okay. That's chill. That makes sense. Right after right hazard. Next is this. We're going to run the compute shader. Now, I don't know if... no, we don't need to do begin dynamic rendering yet, because we're not rendering anything. Push constants. So we need the compute pipeline, which is compute. Sorry, particle compute pipeline. Particle. Hopefully we can have access to... oh, we need to... do we need to access the pipeline first? How does this work? I've forgotten. Yeah, we need to bind the pipeline. And we want 1 draw call. We want 1 instance of this working. And this should... oh, poop. We don't have this set up yet. This is the wrong order. So then we create... yeah, okay, so we haven't actually created the indirect... the regular direct... oh, right, okay, we're missing something. Right. Yeah, okay, so we need to be able to create the graphics pipeline here. So I think we're missing a create buffer here, which is the issue that we're missing. Yeah, so we create this on the fly. But here we create... oh no, wait. We do this, because I remember this being a huge buffer, right? What? This is the indirect. I'm confused here. What is the... no, we don't do this. This doesn't make any sense. Yeah, this is wrong. Okay, so I've made some mistakes here in my notes. So yeah, we don't do this yet. This is too early. We need to fill the buffer, and then we need to also then create the next thing. So we need to create a second buffer. Otherwise, this doesn't make any sense. So what have we created when we create this buffer? Okay, so we created that. Next, we need to create the other buffer. Yeah, okay, so let's grab that. Which you've already done here. Cool. I think we're alright with right after right. I think that shows that we've at least got somewhere correct. So, I'm going to return again. Actually, I'm going to also throw in a void assert, I think. Duplicates. And we don't want to handle twice. This is going to cause an issue. Alright, so first things first is to just go through this and kind of correct things. Alright, so we create this buffer. Yeah, so effectively, unfortunately, what we need to do, like, instantly is, like, write everything. Otherwise, nothing was going to work. Which is usually the case for synchronization, because you can't have half the synchronization in and expect things to kind of half work. So, yeah. We need to create 2 buffers. And that should be good, but we need to obviously do the shadowing issues. I think what we can do actually is we can reuse handle. No, we can't. So this is the handle. I'm just going to kind of cheat a little bit. So buff, draw, count, handle, and kind of just go. Whoa. Next. No, okay, so this is just going to be a pain in the neck. And then the draw handle. Is the same deal. Just a different handle. And there we go. Okay, so that should be good. We should have 2 buffers now created. And we should have created exactly the same, exactly the way we wanted to. Now we have 2 buffers. Now we can access them. And okay, so we've accessed one. The second one that we need to access, which is next, is the yeah, I've written this twice, haven't I? That's what's confusing me. Yeah, so as far as I'm aware, we don't do this twice. Then we do this. This is the next step. And we post this in here. 1. And get rid of this. So this isn't a render loop. This is the pre-render loop. Now, obviously, we have 1,000 issues, but that's fine. One thing at a time. So when we create the pipeline, what do we end up with? So when we have a debug pipeline, okay, so we bind. We can just bind it like that. Okay. So we need to bind the pipeline. The first step, which is pretty. Okay, so we can just, I think, use GPU bind pipeline. Is that what it was? Pipeline? No. Give me a moment. How do I bind a pipeline? Oh yes. Okay, it's part of the GPU. Okay. So, command buffer bind pipeline. This just makes it easier for me, so I can just use a handle. Right, cool. Get rid of this now. Okay, so next is we access the buffers that we've just created. Technically, we have access to them. Oh no, we don't. This is runtime. So we have access to these. Then our push constants. Do we have access to this? Right, okay, so that's fine. We just make a new push constants. And we have more to push. We have an indirect address. What new things to push even? And this. Jeez, come on, take me back. There we go. Okay. As far as I'm aware, we can push different things and ignore the rest. But we'll see if Vulkan screams at me for that. Next is check DMs. Okay. Maybe this will work. What game is it from? What game is it from? I'm fine with this song. Right? I love this song so much. I might loop it one more time. Just gotta listen to it for a minute. Right, so push constants. How do I do a push constants again? Push constants. I think I have a setup here, which I can just copy, paste in, and see what we're missing. So, what are we missing here? Oh, command buffer. Okay. That's the only issue. In fact, let's do it with this one because we kind of. Actually, yeah, this is correct. This is 100% correct, and this is the VK. Yeah, shader stage compute bits push constant 00. Okay, cool. Get rid of this. Now we calculate the amount of threads that we're going to run, and then we finally go a dispatch, which is this guy, which is going to match our 32. So now we should have a buffer that's filled up with a command. Next is then we need to transition the buffers to a different thing. So now we need to transition the buffers again. Now we have access to the buffers here, so I'm not gonna I'm not gonna redo them. So I'm not gonna do this. This is not needed. Get rid of this. So we transition them back, and we do this. And what's the transitions set? Oh, I haven't done that. It's very annoying. Cool. One miss. Want a swing and a miss on that one. So this is for. Is this correct? Yes. And then this right at the end. That's what I missed. Okay, cool. Then we've transitioned the memories again, and then finally we can. What's next? So we should then be able to run the particle shader. But instead of doing a regular draw call, we can do an indirect draw call. And what I'm going to do here then is... yeah, what I'm going to do is just steal this. And kind of do a run. Oh. What is happening? Why is that being stupid? Oh, okay, it's just a spelling mistake. So what I'm going to do is go back to my notes, and we're going to kind of make another function call, right? And as far as I'm aware, this should be everything that we need to do. So we're going to get rid of this. Hang on. No, I'm not. I'm just going to make a new one. So I'm going to make a very quick, dirty new one, which is just going to have buffer handles in. So indirect, and then indirect count. And then we should, hopefully, with those two, which is going to be a bit different from what we were doing, hopefully we now have a GPU-driven renderer after we've copied in our other piece of code, which we wrote yesterday, which is this. So we bind the pipeline, we do all the same stuff. We just need to... Ooh, forgot to do this. Which is up here. And do we have access to GPU? I hope so. I would be a bad program if I didn't. Yep. Indirect first, and indirect count after that. And we should have basically everything done. And now we need to do size of these two things and one draw call. One draw call, please. We'll do instant rendering later. Okay, the size of operator. Ugh, okay. Almost there, almost there. EX Punks is the game. Got you. Alright, I'll stop torturing you with this song. It's just my favorite song right now. Indirect counts. So this is the thing I don't quite understand about this section, is like, what the heck are these size things supposed to do? So when we actually do the indirect draw count, we have a mesh draw and then a size of mesh draw. Hang on. Is this a offset of or something? Like total size versus offset of? Maybe we just need to set the whole thing kind of simplified. So we have the sizes, which I don't quite understand. So offset stride. Right, okay, so if we set the stride to 0, then I think it just does it. If we do the offset, there's no offset, so that's just 0. And so we have buffer, buffer, buffer size, offset. But I think I'm confused here. I'm not quite sure if this should be... Alright, so what I'm going to do actually is do a size of operator for VK draw indirect command, exactly. I think that has the 4 ints in it. Yep. So I'm not entirely sure if we should be doing this. That should be the stride, like we should just be doing that. But now we have these fellas. And instead of doing that, we need to copy in our buffers, which we made. So indirect. Yep, that guy. And then indirect count. Handle, they're fine if I copy them because they're super small. They're only 4 bytes. Now, obviously, this is not going to work, but because it's just too good, it's just too not. Yeah, as far as I'm understanding these things, that's basically what we're supposed to do, and then we end rendering and kind of repeat ourselves. But I'm not entirely sure if I've missed a step. Because yeah, we go what? Call render, right? I don't know if we do something else with the pipelines at the end. But we'll see. No, it doesn't look like we do. Okay. Right, let's see what we screwed up. So immediately straight off, we've got multiple definitions, which is easy to fix. So this is count. And this is indirect. Okay, so oh yeah. And there we go. And the same goes for these. Cool. Oh, yeah, this is not called the same thing. Okay, what else did we get wrong? No, it's a warning. Oh, I didn't see that. Yeah, let's get rid of that. There are any errors, so that should be all the compilation issues. Now, in theory, we have done all the pipeline barrier synchronization that we need. Okay, it's got redefinition of things as well. Okay, yes. So I just need to keep finding these. I assume this is count. It's the first one. Yep. Everyone died indeed. I think I've got in the nitty gritty of Vulkan, and I was a bit too locked in earlier. So everyone was kind of like, okay, he's clearly super. Oops, that was wrong. Super locked in. I think that's what happened. So now he wants. Yeah, we're in the weeds, Because we've done so many pipeline barrier stuff at the moment, it's kind of like... I don't know if this is like super interesting to like watch, but I think it is. Okay, so we're about to do a push constants. Yeah, everything's chill. Alright. Let's just see if we create the... okay, there's another one. Memory info. Fair enough. Yeah, we are creating two buffers at the same time here. Where are we? Indirect. Oh my goodness, indirect. Okay, so we got... I already know this is going to be an issue, so... Count. So before we even bother compiling, we are going to also deal with the fact that this struct here is also going to have the same error. Cool. And now we can change this to indirect. And this is now indirect. Either way, I can concentrate more if everyone's decided to. Allocation info. What's my Discord? It should be linked in the description. If you can't join it, let me know and I can give you an invite. Hey project, thanks for joining us. We're literally just about to see if I've made a massive mistake. So I'm excited. Okay, so redefinition of results, that makes sense. So I don't need to worry about that actually. I can just set that to like that. Oh, an allocation info. Needs to be this. Oh, maybe not that. This then. Cool. Type your Discord in chat. Yeah, one moment. If it's not in the description of the live stream. I did add it, but give me a minute. Give me 1 minute. I will do that shortly. Once I've... Okay, so we've got some more redefinitions. Okay, so this is count, I think. I'm going to say it's the count one. And then this is indirect. This is, no, I'll just call it I'll just call it that, it's fine. So we have to transition the count after filling the buffer, then we actually use the buff. Then we use that buffer, then we transition the buffers once they've come out the shader. Okay, 1 moment, and I will, I want to get rid of the compilation issues, and then I'll give you the link. Cool, no errors. Let's give you a quick invite. Thank you for being patient. There you go. There you go, there you go. Okay, that should be good. Alright, so let's give this a run. Okay, so let's see the validation errors that come from this. Alright, so this is the push constant, size 40. Interesting. Right, I see. Okay, so we're gonna have to make a new one. That's fine. Hey man, I saw your video about improving programming. I just wanted to say thank you. It came at the right time. I've been feeling my skills haven't improved, so I'm glad this vid came out. Thanks, Dan. I appreciate you a lot. Seriously, it's good stuff when I hear that, because it's that's the reason I made the video. Like unironically, yeah. Despite all the AI bros in the comments saying it's programming is the it's ending. The reason I made it was for people who felt like they needed it effectively. So yeah, I'm glad I provided some value. Okay, push constants, let's fix that. So this is going to be pretty straightforward. So we don't have, if we're going to have a different push constants that's going to have new things, we want to just kind of do like this. Struct compute push constants. Because it's so different, I'm completely fine with doing this like this. And now when I go to my game, we do now compute push constants, which should be just those two, which is now 16, which is valid. So it's not 40, which is like 5 times 8, which would be the total size of everything. So that should push constants now should work. So we'll see what's the next thing we break on. Right, so the dependency info type must have, okay, that's a simple mistake. Where have I missed that? Unfortunately, at my job, I've had to use AI to complete my assignments on time. Well, I do have issues understanding the code it gives me, and that's why I felt like I haven't been improving. Hopefully, I can dedicate more time to actually practicing my coding. Yeah, 100%. It's as simple as if you don't use it, you lose it kind of thing, Now, what do I need to do? Now, where's this actually happening? It's just the main loop, or? Yeah, okay, so it's in the loop, and it's here. Okay, so it's definitely here, and it's at this point. So I think it's the... You'll get there though. I think you can easily get back, whatever you're doing. Okay, so barriers. I think what I need to do here maybe is Let's see, what's the issue? If I look at this. So the dependency info, of 0. Have I put this in there? Yeah, there, and this in there. Huh. The S-type we use this 3 times. I mean, I could just set them, but I assume this is how you do it. If you want to set an array. Hi, Captain. Atomic. How you doing, dude? Thank you for joining us. So apparently this is just not... I'm gonna do this just to shut it up and just see, have we even got data in here? Right, yeah, so it should be this, which I'm gonna take from here. Now, if it's number 2 as well, then, or number 1. Good, what about you? Yeah, not bad. Just going through Vulkan validation errors to see if my indirect draw calls are working. Apparently, I'm not setting up my what is it called? Yeah, okay, so it's not set these datas at all, which is kind of awkward. Now, as far as I can tell, if I go back into the Arseni's renderer. So yeah, just debugging stuff. When we want to transition this, we can just throw this in an array, right? As a stack variable. I'm getting a bit hungry though, I'm not gonna lie, so we'll probably break for lunch soon. We'll put on a vid. Get rid of this. Watch some cool stuff. I think I'm just gonna pick something myself this time. I feel like I need to watch something a bit more technical today. So I can get better at stuff. So we might watch like half of a talk on something. So why aren't you being added to an array? Like we have the data in here, but it's not in here at all. Yeah, so you don't... None of this is coming through. I'm gonna lay in bed, just... ship the cycling and magazine inserting and removing. Oh, okay, in your game. Nice. Well done. Congratulations, Angelic is a cutie, for getting that far. Right, so... Oops. Yeah, let's put these in arrays. Maybe that's the issue. I don't know if this makes sense, but we'll see. No, I didn't think so. Yeah, that's not what I thought. Why are you being stupid? Right, so if I put 1 in, does that work, or is it just... Yeah, okay, so none of it's working at all. So, let me think. There's something happening here that I don't quite understand, so... What I'm going to do, actually, I'm just going to completely I'm not going to use member initializing lists. I'm going to say 2. And then I'm just going to go, okay. Much simpler. 0. And then... this guy. Duplicate. And then number 2, you're going to take this. Or number 1 or whatever. I'm going to run that. See if we get the same issue. And We are. Why are you being like this? So that was assigning it, but it's just not. Right, okay. In that case, we can just do this straight instead of having an array. So what we're going to do then is move this up here. This is just going to simplify things anyway and just have less lines of code. Get rid of this, and what we're going to do is we're going to take... I'm going to have to label this, unfortunately. And this is going to be 0. Now you've definitely been assigned values. So this is the indirect buffer. So this is the indirect buffer barrier. Nice. Okay. And same. This is the count. This is the count buffer. Give me a minute. That's why it didn't work. I just noticed. I just made a stupid mistake. That's what's happened. Okay. This is easily fixed. I was confused, but no longer. Alright, just gonna go back. Okay, cool. You see the mistake? I've just called it buffer barrier. I haven't actually done anything with the member variable itself because I renamed them and then I didn't do this. So that should fix that. Hey, watched your expert video. Thank you. Thank you. I hope you enjoyed it. There we go. Fantastic. So we got a read after write hazard. Reads which is previously written as by. So a read after write. Yes, but I thought I transitioned it so it can be read. Practice is really the key to everything. 100%. Yeah, literally. Yeah, I'm glad it's made a positive impact. Yeah, thank you for watching it. Yeah, I appreciate you. And hopefully you'll see that, you know, how many hours have I been going for now? You know, I'm following my own advice, 4 hours, right? I've been coding for 4 hours. You know, I'm not just telling everyone to do this and then expecting them to you know, I am also trying to become better and practice. So the indirect roll call count was previously written by this. Synchronization, no sufficient synchronization is present to ensure that the indirect read is... You are not pulling a pirate software on us. Exactly. That's exactly what I don't want to do. I'm following my own advice. It's quite a different approach, but I really did enjoy it. I really enjoy coding, so as long as I enjoy the process, I see myself yeah, you just get better and better as you do that, without a doubt. Okay, so there's a transfer write, and we haven't done the access to read on our count buffer. Like I myself am creating a 2D animation software from scratch. Yo, nice. Handmade style. Nice, love that. And learning a lot. Hell yeah. Yeah, go for it. Keep it up. We need good software out there in the world, so you know, even if you don't think it's going to be worthwhile, I think it's always worth pursuing. Like I say to game developers all the time, we need more good we need more good games, but we also need good software too. So So indirect draw read, that is true, that just needs to be transitioned to that, but as far as I'm aware, that's exactly what we do. And this is for an indirect draw called count. Yes. And if I go to my game, yeah, lol, pirate software, F that guy, I guess. Yes. I mean, I don't hate the guy, but yeah, I used to be a fan. Let's just say that. Okay, so why, when we, are we transitioning the right thing here? So we transition this to an indirect read, and this to be shader red. We actually don't need to do that, it's not being red in the shader, so we can actually get rid of this. I can't comment this out actually. So I'm going to do this, and I go. Not. Do we actually read this in the shader? Let's think. No. Currently, we don't read this in the shader. Cool. I really have some ideas on games I want to develop. However, I do want to start with more simple games before I'm working on bigger ideas. That's a good idea. I just don't know what games to make right now. I would say also if I should use Unity or Godot. Maybe you should make like a really, really, really simple game in both, and then you can evaluate which had the easier time. Might be an idea. No, OpenGL is my first API, so yeah, it's a tough one. Obviously, scope creep is something you want to avoid. Sure, you can send me some funny things in the DMs. All right, so I assumed this was us transitioning. Or am I missing something here? We transition this buffer to an indirect read. Yeah, we can't start an indirect. Yeah, indirects. Yeah. The compute shader must have finished, and the indirect must not start, as it is in both shader write mode. And I think, what have we got in here? We've got a. What is it in at the moment? It's in Axfer transfer writes. Its prior was transfer write. Okay, interesting. Which is, oh yes, I've realized I'm not using pipeline stage 2 stuff. Oops. So that's what it should be in. I actually have some experience in Godot. Worked on a chess game with a friend, but I mostly focused on the UI. However, I do want to give Unity a chance. Yeah, they all sound like generally good ideas. Are we still using this? That's the question. Indirect handle counts. Oh, hang on. Then give me a second here. Yeah, we don't need to do this twice. I think this is the problem. Get rid of this. Oh, no, not that, sorry. This. Yeah, because we're accessing the buffer at the wrong time. We've got a completely different buffer. Then I think we're going to have the same buffer accessed. Let's see. Ironically, my only time for trying Godot was Pirate Software Game Jam. There we go, yeah. I do not like it at all. I'd rather use Raylib. Fair place, yeah. Yeah, I think I tried briefly the Pirates Game Jam ages ago. But because I was using my own game engine, I just couldn't even get anywhere. Anyway, I'm rodding the ECS library, physics, possibly networking, and definitely some rendering libraries. Damn, that sounds like an intense things, Angelica. Angelica is a cutie. Right, let's see, what have we got? That should at least hopefully not have a read after write. Read after write is still happening. What for what buffer though? Indirect draw call count again. Okay. It's still the same issue. We haven't transitioned. Okay. So that wasn't the issue. That's not how you fix that. Oof, banger song. It is good, isn't it? Gotta love it. Gotta love the old stream hiccup. Oh, is the streamer good? Let me just check. Are we good? Uh-oh. Okay, yeah. Yeah. For me, yeah. Okay, we're back. We're back. I don't know what happened then. Are we crashing the GPU? Maybe this is crashing the GPU. I hope it isn't, because that's not good. It shouldn't be. This is not a crashable thing. This is just a synchronization bug. If I let this continue, it probably would crash. Yeah, I've got to be careful when I crash the when I'm running like into validation issues. Sometimes draw commands can crash the GPU. So how do I guard against this? Yeah, the real way to guard against this is to make sure that this stream on a different stream on a different computer. I can answer that with a command. There you go. Hopefully the Nightbot is still alive. There we go. So that's my setup. Yeah, so it's just a NVIDIA GeForce. Oh no, it's fine. You didn't know. And also, I don't mind typing it out. It's a good question. That's why I have a command for it. But I also don't know how to inform people about commands. I don't know what I'm doing with streaming, honestly. Okay. Yeah, it's a pretty decent card. Let me see here. So, are we not transitioning? This is the question. Is this not running? Let's see here. If I just do one, let's just do one. So we take a compute. We can't. The compute shader must have finished. We're taking this from L. It should be a transfer read actually. Oh, I think we might have missed a step actually. We might have missed transfer read. Oh, did I make a mistake? I might have made a mistake. You're on a GTX 750 Ti. Yeah, that's an older one. That one. It's a good one. It's a good old one. Yeah, I hope you got your RAM before the prices went up. Unfortunately, it's on an older motherboard. If you look at my CPU, it's like an older CPU. So yeah, it wasn't that expensive because no one wants the, what is it, like 280k read-write or something, read-write speed. And you got the RTX 6070. Damn, that's intense. Alright, so I think I may have made a mistake. I think I've missed something. I'm probably not transitioning the memory completely. So let's just look. So we do a fill first, then we do a transition from. So these should be connected. So transfer read. Let me think about this for a minute. So we do a pipeline transfer, and then we do another pipeline transfer. So we are doing 3 transfers on 1 buffer, and I'm only doing 2. So yes, we are missing a step. Now what am I missing here? This is pre-shader. Okay, so what have we got? So is this shader read yet? Is this shader? So this is the indirect. So okay, so we've missed. Yeah, so we got to transfer. Okay, then we need to transfer them again. For goodness sake, we missed a transition. Okay, so we need to do a transition. Transition of memory here again. Okay. Right. Right, let's transition this memory. Yeah, so what I need to do, basically, I think what's ended up happening is I haven't changed it to a shader write. Yeah, shader read write. Okay, so yeah, this is the problem. So we're not actually doing anything with the buffer once it's filled up with zeros. Which is not good. So I'm just going to take the... I'm going to be inspired by code I've already written. Kind of down here. Oh my goodness, synchronization is so difficult. Right, so... so I'm going to go compute. And then compute, yeah. So this is the problem. We're trying to transfer stuff that isn't even in that memory type. So take all this, do this. Yeah, let's comment this out so we don't end up causing a bunch of IntelliSense issues. So yes, actually we need to access the buffer first. Let's put them just both at the top. I think it's just going to be more convenient. Right, okay, cool. And then this transitions to... Right, so now we need to work out the... No, this is the indirect. This is not what I wanted at all. Yep, oil, ocean zone. There we go. It's sick, isn't it? So, as far as I'm aware... I'm confused here. Rasterization stage. So, give me a second. Yeah, okay, so we need to do the compute shader, and then, yeah, this is valid. So the indirect shouldn't have started, and we should have a vertex shader. Vertex shader bits. Hi Fixie, Fixiable. How are you in general? Yeah, not bad. Yeah, I'm doing good. We're just trying to transition the memory to the correct types, which I haven't actually managed to do. We'll have to move to synchronization 2 though shortly. Yeah, okay. So as far as I'm aware, this is all correct because I've written this before. So hopefully, yes, this makes sense. Now we're moving to a compute shader, so we need to make it compute shader is good. And it's writable. Thank you for joining us, by the way. Fixable. Just restart the music. Wherever we are with the music. There we go. Cool. So this is the count buffer. So this is a transfer. Yes, we need to move from transfer. Okay, this is all making sense now. So I'm gonna have to change my notes. This is a write. And then this is the, it should be an access stage mask. And there should be read writes. Fantastic, so we're writing to a buffer. Fantastic. And now we need to do the same thing as before. Oh my goodness, this is so complicated. For one, you know what we're going to draw when we finish this, guys? Literally one rectangle. So it is intense. Right. Okay, so but this will allow us to do many different things once we've got that far. So this is the, what I'm going to call this, not barriers. This is going to be the compute barriers. This is why it's taken me hours to get this far, because it's like super fragile. Holy shit, one rectangle, exactly. It's going to be mind-meltingly good. Actually, we don't need it to be shader read write, I don't think. Oh no, we do in that shader, but we don't in the next transition. Which will be the L2 cache, which will be writable, yeah. It needs to be indirect. Read, which is for the indirect buffers. Cool, fantastic, fantastic, fantastic. Okay, cool. Now, hopefully, we don't get the same error. Oh, we get a different one. That'd be nice. We got a different one. Dependency compute info, yep. And get these in. Push this here, and barriers. Oh, I'm an idiot. This is the one I want to keep the same. And this is the one I want to say is compute. Oops. Excuse me. And there we go. Okay, so that should be all the redefinitions of things. Let's see. Oh dear, that was a bad one. That was a bad one. Have I lost the stream? Have I lost the stream? Come on. Oh, dude, that was close. That was close. We nearly lost the stream. Okay. You're an inspirational. You're inspirational in my case. You don't. Ah, thanks, dude. You good? Yep. When are you implementing fonts? We'll have to see when we get to that point. Yeah. Fonts is a bit of a rabbit hole, so I'm saving that for a different one. So right now we're just going to work with textures with text on, which I know isn't ideal, but I missed escape point. Yeah, hit. Sure. Why did you say I missed escape point? I don't understand your mind, Ratchet. All right, so I think we can pretty much say that our we could make it readable. Oh, wait, that's kind of dumb. Yes, this needs to be I actually don't know. Hang on, I'm gonna make this readable again. I also don't understand my mind. Fair enough. Yeah. Yeah, the reason that if anyone who doesn't know, like, rendering fonts is quite difficult. Well, text in general. There's a lot of things you need to do. You keeping up with the World Cup? Sorry if this is off topic. No, but I know England's in the final 16, right? I've been trying to like. I'm not much of a footy fan, to be fair, but I know we're getting close to the quarterfinals, right? It's one of the great mysteries of life. Fair enough. Okay, so what I'm going to do is remove, to avoid crashing the GPU, I've got to be very careful now. So the indirect, so the VK draw, indirect count, right, let's see. I think that's going to, I think we have safe to say, Danny Bid is in Mexico. Ah, great match. Ah, yeah, that's sick. And I'm glad you enjoyed the match. I know, isn't Harry Kane carrying the UK team? So I know. Crash the stream. Let's see. I didn't expect that to crash the stream. Yeah, okay, so it looks like we're good. Again, okay, so that's not, it's not the indirect draw call that's causing that. It's the part before, it's the compute shader. Right, okay. So when we transition this memory barrier, let's just make sure everything's good here. We then, so I think it's the dispatch, right? So let's see. Right, let's see. Yeah, okay, so we're not dying because we haven't done anything. Right. Next is to figure out why are we getting this problem? Right, what's this number actually? Let's figure this out. It could be the numbers, you see. It could be like something silly. Number of threads 1. Yes, thank you. That should be good for a single. Wait, it should be 32, right? Alright, I'm going to set this to 32. As far as I'm aware. Okay, so let's just make this compute shader do nothing, so it doesn't freak everything out. So literally I'm not going to do anything. I just want to see if it runs with the correct memory. He's up there in goals. Yeah, that's really cool. Yeah. Yeah, it's good stuff. We'll see if football's coming home, as they say in the UK. I doubt it, but a lot of people would be happy. I definitely don't think we're the favourites, right? Okay, cool. So that is... We're not crashing the GPU then. Cool. And that's good. So, now it's going to be figuring out... Unfortunately, I'm going to have to probably crash the GPU again. Like, what is going wrong? It's just a uint. It should be 0. Anyone but Argentina, please. England's got a chance against Norway. Yeah, I heard Norway's oh, what's his name? He's got the superstar that's in Norway now. Erlong or something. Yeah, I'm sure. Yeah, he's the yeah, okay, so that's it. Yeah, we had to check because I'm not sure what's going on. So we're trying to... Holland, that's the one, yep. Ireland, Holland or something. Are we good? We're still live. Everything's chilling. Nice. Yeah, he's been the Man City ace for a while. I mean, I know a little bit about football, but like barely enough to keep conversation. I know more about F1, but I'm not really into that either. I don't know why. It's a funny one. I just never got into sports somehow. In fact, you know what I could do here? Instead of doing something fancy, this atomic ad. This might not work. We might have to... we need to increment by 1 per instance. I'm not a C++ developer, but I don't know why you're using headers instead of modules. Aren't modules objectively better compared to... modules are broken on every single compiler in existence. Yeah. I've tried to use them. They're very difficult to get working. Really awkward. It just make things take longer to compile. Committee shoved in the garbage because they are they are idiots. Yeah, well, there we go. Can't we just get AI to do it though? Anyway. Right, okay, so what I'm going to do actually is, because we're only running this once anyway, and we've got 32 threads doing it, I'm literally just going to do this. Now, I'm going to see if we can even write out to our buffer, right? Are we able to do this? Nope. Jeez, it's really, really unhappy. Jeez, I'm going to crash the... something about IBM wanting to use C++ in systems without a file system. Oh man, that's crazy. So I've got to really be careful here. This is very fragile, and it looks like we just cannot read this data like I want to. Am I missing something? I feel like I might be. Let me look at my other shaders here. I just want to make sure I'm not doing something dumb. So we have a reference, which then references the data, right? Yes. Which is data, vertices, and the vertices is this struct itself. When I was reading about them, they said modules weren't meant to be faster in the compilers. Yeah, I don't know what's going on. They could have copied Rust modules, but no. Grok, add a better module in C++ 7. Yeah, standard. Yeah, exactly. Yeah, that'll work. Maybe I should go for lunch, because I'm struggling to understand what is going on here. I wonder if we've actually uploaded the data to the GPUs. Maybe we've just transitioned them and we're just accessing data that doesn't exist. That might be an issue. Yeah. Okay. That actually might be it. But if you've got a buffer device address and we've allocated the buffers, trying to access them in the push constants that we've got with our buffer device addresses might be tripping everything up. I don't know. I really don't know. I don't know what I don't know if it's the push constants or the buffer's device addresses either. I never understand why people let large companies drag them down. IBM can fork C++ and maintain their own file system. I don't understand what's going on with that. That's really strange. So the committee shoved a garbage version because they are idiots. Something about IBM's wanting to use C++ in systems without a file system. Very weird. Yeah, Grok fix C++, no mistakes, please. Exactly. Yeah, the companies have weights in the standing committee. Well, I mean, at the end of the day, if you really hate headers, you can use... where is it? Where's this handmade, regular stuff? Yeah, handmade CPP. Like, he doesn't use headers, I don't think. He has one header, and then everything's linked with CPPs. You can do it like this. If you don't want to use headers. I mean, there's some headers, but there's like very low amount. Alright, man, gotta head out for work. It was nice to find your channel. I'll take a look back on your other videos. Take care, man. Yeah, thank you, Dan. It's been a pleasure meeting you. I hope you have a good day at work. Good luck with your journeys with programming as well. I really wish you the best on that. Yeah, I'll see you soon. Yeah, as you can see, basically everything in here is just CPP files. So you can use module. This is to Casey hates the linker effectively, and yeah, pretty much everything he's like, even in is that just all the builds? Yeah, so he literally just has CPP files. Yeah, please do. Yeah, I would love to see your progress, dude. Yeah, I don't do C++, but whatever. I use C, and I always wrote both implementations in the definition of the header files. The downside of doing that is incremental builds get slow, but you know, generally speaking, that's fine. If you wrote code that compiles fast anyway, then you're chilling. Got ya. Right, okay. I'm probably going to break for lunch because my brain's a bit fried, I think, with these compute shaders. So I'm going to find a video real quick, and then we can watch that together. And then we can investigate why anything I'm doing in the compute shader is causing an issue. Oh yeah, pre-compiled headers. That's what you're saying. Right. So let's have a dig. We won't watch get a skill. Well, that would be good for me. Has Nathan come up with a video? Actually, you might watch that. Alright, it's probably a YouTube short. By definition, it's too short. I've got too many subscriptions. We can. Is there an Ace Roller video left that we've got? Exposing all my YouTube subscriptions. Oh no. Why indie doesn't mean independent. Yeah, I think we already know that. I'm sure Generative. I don't want to hear Ace Roller's opinion on anything other than graphics. So not this one. Making a game that creates life. Meh. Have I done this one? The procedural generation. How do you implement object-oriented programming in C? Oh, it's a 4-minute video. I thought it would be like a 3-second video. It says you don't. End of video. No. Very. I kind of in the mood for. No, I'm kind of in the mood for like a vulcanized thing, actually. Like just a bit of a vulcanized, you know, a bit of something nice that we can kind of chew on. Just a bit of Vulkan video. Speed of light of Vulkan. Yeah, we could do it. What's your benchmarking marking video? Just, you know, test the speed of light. That seems interesting. And it looks like it's about 20 minutes long. I probably won't sit around for the questions. This is perfect. All right. Object-oriented programming is a dirty low-level trick for x86 implementations. Yeah, who needs Vulkan? Chad uses software rendering, exactly. I know, yeah. Virgin's program for hardware acceleration. Chad's just do software rendering. All right. Let me check the audio levels real quick. I think we're moving to study now. So we're not going to have that playing. Turn this up to full.
Welcome from Rainer to talk us about tuning and benchmarking. Yeah.
So thanks for the introduction. So this talk
How's
is
that, guys?
essentially me
That seems good.
prototyping ideas that people usually implement.
Alright, so hopefully this is a interesting video that we can all watch and get better at Vulkan together. I'll just grab my lunch real quick, and if you've never been here before in these live streams, hi Boom, sorry I missed that. I was swatching between things. Hopefully you're having a good day. Yeah, let's watch the 40-hour. I don't know how to say his name. Tessoding software rendering stream for a quick lunch break. Yeah. So for those who are, I'll just pause this. So for those who are new, who are like tuning in for the first time, what I do at lunchtime is I obviously watch a video instead of coding the whole time, and eat food while we do that. Now, to avoid you hearing chewing noises and cutlery noises, which, you know, is obviously going to be horrible to listen to, I will go on push to talk. I will still be responsive to the chat if you are, you know, if you do send a message, but I won't be talking for basically all of it unless I have something I want to object to in the video. Yeah, and I usually take about 20 minutes-ish to finish lunch, and then we'll go right back to what we were doing. So yeah, that's how we do things. And I'll just put a... I'll just grab my lunch out of the fridge, because I make a packed lunch for these streams. So I don't take up everyone's time. So yeah, I'm just going to grab that. And the cutlery. I'm in the kitchen, by the way, so I probably hear you from here, maybe. Yeah, so I'm very close to the kitchen, because I'm basically in the kitchen. Yeah, Soding does so much cool random coding stuff he doesn't need. Yeah, so I'm gonna watch this vid. There we go. My chair is rolled all over the wires. Hang on. You know how it is. All right. Cool. And I will let things play, and I'll go and push talk. Okay. So hopefully this video is. And I'll just start the study timer, because this is actually relevant to work. Cinema mode. Alright. Let's enjoy.
Welcome for Rainer to talk us about tuning and
let me know if it's too quiet or something.
Benchmarking.
Yeah. So thanks for the introduction. So this talk is essentially me prototyping ideas that people usually implement in vendor-specific APIs. I'm just trying to do this in pure Vulkan. And the whole idea is that we want to extract the few last % of performance on some devices. And so I became interested in this while I was building acceleration structures on the GPU. And usually nowadays this implies that you first have to sort your triangles using a sorting algorithm. And so I thought we could start off this day with a small quiz. So given these tunings or configurations for a state-of-the-art sorting algorithm, one sweep, what do you think is the best configuration for the given device? And so if you were actually brave enough to take a guess here, I can tell you you're absolutely right, because all of these configurations are the best configuration for some specific input number of triangles. So what I'm plotting here is all the tunings that I've tried, binned into a histogram with their relative performance on a large input size. And the colored ones here are actually the best performing configurations on some different input size. So
yeah, that's a good point, that. Yeah, if you remind me next time, we might watch the WGPU. Something on that anyway.
This one being the best configuration for one input size does not imply it's the best configuration for another input size. we can actually look at these tuning parameters and see some structure with our eyes. And we could play the same game with a fixed input size, but different GPUs. And if you're lucky enough that your configuration for one GPU compiles on the other GPU, this does not necessarily imply that this configuration is a good configuration for the other GPU. So what we can conclude is that Vulkan is portable and performant, but shaders themselves are not performance portable, and especially there's not one single best shader. So how do we solve this issue? And the straightforward approach for this is that just at runtime, we try to select the best possible tuning for the given input parameters. And this is a well-known software development pattern called the policy pattern or the strategy pattern. And when we apply this to our problem domain, auto-tuning for GPUs, this looks roughly like this. So first, we try to select some decision variables. So the first few of these are specific to our logical operations. So sorting, what we want to know is the element type and the problem size. We also want to know some things about the platform that we're executing on, so capabilities and limits of our device that are relevant to our algorithm. And we want to have a device fingerprint. And what I mean by this is that we want some kind of indication if this potentially unknown device that we are running currently on is similar to a device that we know a good tuning for. For now, you can just imagine that this is a list of device IDs, and we will talk about this at the end of the talk. So given this set of decision variables, we can select the best performing policy or an implementation, and this implementation knows how to set up its pipeline, its temporary memories, and its descriptors, etc. And this allows us to just dispatch this best shader. Okay, so there's one obvious question. How do we find these policies? So let's look at the development workflow. And for this, first, some GPU expert has to create these tunable shaders. So for this, he will look at a profiler and figure out which subunits of the GPU could actually need more work or should have work removed. So we will introduce a tuning parameter for this. I think Jeff showed this off yesterday quite well. Yeah, right. So let's just look at an example quickly. So we are computing a histogram here. Our initial implementation is tuned to accept some tunable amount of input elements with each thread, and we just write it back with global memory atomics. We could then notice that most of the time the histogram fits into shared memory, so we could use shared memory atomics that are more performant. We could be worried about the throughput of these atomics or congestion. So we add an additional tuning parameter that allows us to privatize this shared memory region to subgroups, half work groups, etc. And we could also notice that the type of this shared memory histogram is dependent on the workgroup size. And we could reduce the number of global memory atomics by introducing tiling, so each workgroup processes multiple input ranges. We don't have to stop here. We could continue here and introduce, for example, run-length encoding or other things. But I think my point is already illustrated. This optimization space or this tuning space grows quite quickly, and it becomes really hard to judge manually what numbers you should plug in here for this to be performant. So given these tunable shaders, we will then continue to just brute force benchmark all the possible tunings for this. And for all homogeneous benchmarks, meaning they have the same configuration for the logical operation, so same input size and same input type, we can then just rank these implementations. And in the last step, we want to convert these rankings to policies. And here we are super lazy. We're just creating two policies or two shaders. We prefer the shared memory variation if the histogram actually fits into shared memory. With some tuning, that's okay for all problem sizes. And otherwise, we're falling back to the global memory variation. We want to do this for two reasons. The first one being that it's just more efficient to select the implementation this way because it's less data intensive. And the second one being that this will reduce the number of pipeline creations, because if you go back and you actually look at this ranking here, there are a lot of variations that have very similar performance. And so if you benchmark many different problem sizes, there will be some noise in their ranking. So you want this decision to be a little bit more uniform across inputs. Okay, that's already the whole pipeline. Let me just point out that this is an iterative process. So you want to revisit your tuning space, maybe remove stuff. For example, the histogram privatization that I talked about didn't do anything on all the GPUs that I tried, so you can remove it again. And you maybe also want to reparameterize your tuning space to just reduce the workload that you have to benchmark. Okay, so in the rest of the talk, I want to go over a few points here in more detail, but let's first cover some background so that the GPUs that we will look at have a fixed number of multiprocessors or SMs, and each of these can process a maximal amount of threads or subgroups at once. So if you do a dispatch, your work groups will be distributed to these SMs. And as soon as your device saturates, the other work groups will be serialized subject to some hardware load balancing. At any point in time, you could just measure the amount of resident threads and compare it to the maximal amount of resident threads. And if you do this at any point in time, you get one of these occupancy timelines. Okay, so when you're benchmarking, you're essentially asking what's the duration from the first work group starting to the last work group ending. And Vulkan makes it really hard to go wrong here. You create all your stuff upfront. You wrap or batch your submission into a command buffer, and the things that you want to measure are surrounded by timestamps. You wait for this work to complete, take the difference from the timestamps, multiply it by the timestamp period to convert this to nanoseconds duration. Let me just show you what you have to do if you want to compare this to an implementation that you have in CUDA. This API is less explicit. So one thing that NVIDIA developers recommend is that you introduce a block kernel. So when you run your kernel for the first time, this kernel might be JIT compiled. So your first measurement will be off anyways. And you also don't have this explicit batching. So the recommendation with this block kernel is that this block kernel is actually occupying the GPU until your submission is ready, and this should hide all the overheads. I found this to be unnecessary for our use case in Vulkan. But you have to look out for two other things. And this is background activity. Of course, you're not touching your system while you're benchmarking, but this can be something more subtle. For example, you might be writing to your console window while you're benchmarking. This will trigger a re-render of your console window, and this might end up in your measurement interval. Something that came up in a few talks and in panel discussions already is clock frequencies. So we are benchmarking here for quite some time. So you may run into thermal power issues where your clocks are reduced, or you just interrupt your benchmarks because you have to write back results, you have to validate your results, or you just want to write some images for debugging. So in this case, your GPU might get back to idle mode and you have low clock rates, meaning that the first few next benchmarks will be unreliable. An easy way to fix this is by fixing the clocks themselves. Let me just point out that this can actually...
You were freaked out by my voice? This is someone else.
affect your ranking for algorithms that are sensitive to this, so you have to be careful. Okay. And so another mechanism that you can use to measure your runtimes are in-shader timings. We essentially have two functions for this. I'm showing the GLSL syntax that differ in their scope. So we have device consistent clock and the subgroup consistent clock. And the specification on them is quite loose, but the intent behind the specification is quite clear. So the first one should just map to some wall clock timer on the device, and the second one should map to something like a cycle counter. And on some architectures, you can just look at the disassembly to verify this. You just have to be careful that this clock is not necessarily the clock that you have in Vulkan with your timestamp period. And on other vendors that are more secretive about their API, you can do this through small experiments. So you can just sample both of these clocks a few times, and under our assumptions, you should be able to compute the clock rate of clock frequency of the GPU with these measurements. And by comparing this to the actual clocks through a vendor API, this verifies our assumption. This also shows you how you can integrate a cool feature into your benchmarking library in pure Vulkan. You can just sample the clocks with these functions and then throw away all the benchmarks that have anormal clocks. And another thing you can do with this is implement the sleep function that we will abuse in the rest of this talk. Because what we want to do is implement this Vulkan application, and this is an occupancy calculator that people usually use during profiling to make decisions for their workgroup size or the amount of shared memory that they use. And for this, we will use benchmarks or timings as a side channel to get the occupancy. If you look at the blue curve here, this is essentially what happens if you vary your workgroup size and how this affects the number of resident threads. You can also use the same timing methods to derive some other information, like, for example, the SM count or the maximal amount of blocks on one of the SMs. So why are we using timings for this? We can understand this by comparing it to the actual occupancy calculator in the profiling tools of NVIDIA CUDA. So here you have to put in a lot of numbers that are simply unavailable to us in Vulkan. So we cannot use a data-driven approach like they use in this tool to get these curves. Let me just point out that this curve here is exactly the same curve as here. We're just plotting it slightly differently. Okay, so how can we get this information through timings? We can go back to this picture. Just this time, we're executing workgroups with regular runtimes, meaning each workgroup runs for the same duration, for example, because the workgroup just sleeps. So in this case, the workgroups will implicitly execute in lockstep, and I will call this a wavefront. And the case that we want to detect is this. We have enough workgroups so that the device saturates perfectly, and we can verify that this is the case by just adding yet another workgroup. This workgroup should serialize and double the runtime of our shader. So let's put this into an algorithm. What I'm plotting here is the size of the dispatch in threads on the x-axis and the runtime of the kernel on the y-axis. And we expect this staircase function because each time there's a serialization, we expect the runtime of the kernel to increase by the sleep duration. So what we can do is that we start off with a very conservative dispatch size, and we're just doubling the number of dispatched workgroups each time until we find a serialization or detect a serialization. And this gives us an interval between here 2 and 3 that must contain this runtime step. And afterwards, we can just use bisection to find the actual position of the step. Obviously, this estimator is kind of slow because we're doing a lot of dispatches, and we maybe have to repeat them a few times for reliability. You can optimize this in many different ways, but you can also just construct a lot of different estimators for the value P. You can, for example, just use in-shader clocks. So this time we only have to use one dispatch, and before sleeping, each workgroup just writes out its start time into a histogram. And on idealized hardware, we expect this histogram to be 0 everywhere, apart from some equally spaced bins that will contain the occupancy value P. On actual hardware, this will look like this. And if we plot it a little bit different, it looks like this. And so we can compare here the idealized position in blue to the actual position in red. And the shades of red are the standard deviations. And so what you can see is that the overheads and the variances here just add up with each wavefront. But I would also want to point out that the runtime here is really short. It's less than 1.4 milliseconds for the whole estimate. Okay, so how can you use this to estimate the occupancy of your shaders? A simple way to do this is by augmenting your shaders. So you have your shader that is symbolized by the blue code at the bottom, and you just wrap your main function into something that is opaque to the shader compiler that decides whether you run the estimator or the actual shader. And the idea here is that if you run the estimator, that your shader code is reserving all the resources that affect occupancy, such as registers and shared memory, but the actual code will not run. Yeah, and that's all regarding this. So why do we want to know the occupancy P? Let me first point out that this number is needed for almost any GPU software load balancing method. And a very simple example for this is a device-wide barrier that synchronizes the whole dispatch. And this is essentially just a spin lock that waits for all the threads that are resident on the GPU to arrive at the spin lock before letting them pass. It gets a little bit more complicated if you want to reuse it a few times. Let's just ignore this for the talk. And let me just point out that this is actually super useful. We have recently used this to accelerate a BVH traversal by a factor of 6 with a very, very lightweight patch. So why we actually want to talk about this as part of this talk is because it allows you to optimize your tuning space. And I brought you 2 examples. The first one is scan or prefix sum. You actually don't have to understand the algorithm in detail. What you have to know is that each workgroup is essentially doing its local computation, and each workgroup has some scratch memory that it uses to communicate with the other workgroups. What's important is that you have to reset this memory region each time. And someone from AMD came up with the great idea that you can just use a ring buffer instead. And this means that you have to reset less memory, so it's faster. And most of the time, you can actually just skip this. So the downside of this is that this introduces 3 new, quite tricky tuning parameters: the ring buffer size, how many workgroups are allowed to interact with this ring buffer, and the communication scope that is allowed for each workgroup in this buffer. So given what I've talked about earlier, it's quite obvious that the number of workgroups that should be able to use this ring buffer at once is just P. And if you understand this algorithm a little bit better, the other ones are just a function of the fairness of the hardware scheduler. So you can do 2 of one things. Either you just hard code the size of this ring buffer to something that is conservative, but relative to P, or you just introduce one tuning variable that is a multiple or encodes this fairness factor of the hardware. Right. And the second example, we have talked about this earlier, the histogram. You really have the wrong incentives to process way too many elements in a single workgroup. And what you will end up with this is shown in A. So either you don't saturate the device at all, and that's why your shader is inefficient, or you're suffering from the tail effect, which means that you only have a few wavefronts and your overall throughput is just reduced because a large portion of the dispatch is just this tail wavefront. How people usually fix this is by using a persistent threads approach or using a grid-strided loop. So persistent threads, you essentially have a fixed amount of processor workgroups and an explicit work list to fetch tiles. And in grid-strided loops, you have an implicit work list, and you configure your dispatch essentially as through a tuning parameter C that is essentially encoding how often the hardware is allowed to rebalance the workload. Just looking at the persistent threads approach, this approach is efficient if you configure your processing workgroup count to be greater or equal to P, with it being most efficient if you set it close to P. And the unavailability of estimators for occupancy is also the reason why, for example, in the official nanite implementation, you can see them hard coding a really large value for the number of threads. Right, and these are 2 examples how you can reconfigure your tuning space. So I want to talk about one last thing, and this is this GPU similarity problem. In this talk, you've seen quite a lot of very dangerous shaders that make some assumptions about the GPU hardware and about the GPU forward progress model. In this cases, it's absolutely okay to just check the vendor ID or the device ID. That's what they are for. But for the case where we want to know if one GPU is performance similar to another GPU, we want something like a compute capability or an architecture ID. And the way to do this that ties very nicely back into the talk is if we return to our occupancy calculator. This time I'm not only varying the workgroup size, but also the shared memory size. So what we get is an occupancy surface. I'm just plotting it here as a grayscale image. And this image essentially fingerprints the SM. So it's different between generations from the same vendor, and it's different between vendors. But if you actually look at this picture from different GPUs from the same generation, it's the same picture up to a scaling factor. And the scaling factor is just the number of SMs on the device. And I think I've said earlier already that you can just get this number also by looking at the surface and doing some math. So you can fingerprint performance similarity by just sampling the surface and then using an equality test. That's all that I wanted to talk about without you asking questions. So let me summarize. So we talked about benchmarking very quickly. There are a few APIs that are missing for our purpose, like an API that lets us fix the clock rate. The in-shader timing APIs are a little bit underspecified for our use cases. We also talked about the devisualized programming patterns, so patterns that use the occupancy value P for optimization or for correctness.
I'm ignoring Intel. Oh, they're ignoring Intel. I thought you meant it, yeah. That's true, yeah. No one really thinks about Intel.
We are simply missing an occupancy API to work with this, but we've shown that you can use timings as a side channel to get this value. And one of our motivations for this was auto-tuning, which is really a hard challenge for an API like Vulkan that has portability at its heart. Yeah, and so the core issue of this is how can we map performance similarity between devices. And that's all. I hope this talk was interesting to everyone, and thanks for listening.
All right, questions?
So first of all, great talk. So first question is, what made you use, I guess, write timestamps versus calibrated timestamps for calibrating your shader clock? Was there something missing in there, or what's your experience of that?
I think the main reason is that I made this talk before this was published a few years ago.
Okay, gotcha.
Right.
That's completely fair. And the second one, so with some of the missing clock extensions you're thinking of, what would you look for in like a fixed clock sort of scenario? Like, it can be very difficult in Vulkan to sort of, even if you fix your clocks, sort of, balance it out to a bunch of processes. But
yeah, some benchmarking Vulkan stuff, which is cool. Hello, Boudwen. Just finishing up my lunch break. Just finishing up this video.
But would you just need, like, say, run the clocks at full power all the time, or would you need some more control or something like that?
So what I essentially use, for example, for NVIDIA is a really simple API that I think has 3 states. And the states are, the hardware is allowed to do whatever it wants. So frequency scaling is on. You can fix it to boost, or you can fix it to something that should be reliable for hours. So thermal stable mode. And I think that's enough to benchmark the space. So why I'm interested in this is because you don't want to.
What's my config? Do you mean my specs?
Repeat your measurements too much. If your clocks are variable, you have to repeat your measurements more often. And you would like to do one pass over the whole thing. Throw away the really bad configurations and then maybe revisit the other ones. So I don't know too much about the hardware details to actually make a suggestion, but I guess the answer tells you what I would want.
Hi, great talk. One question for the shaded clock. So I remember that when I was testing this, like there are like 2 ways of measuring. One is on the subgroup level, another one is on the device level, right? In your case, which one have you used? And there were like some challenges depending on device or subgroup level.
Yeah, there are a lot of challenges actually that I glanced over. So One of them being that, for example, on AMD, you have to be careful to not read the clock with too many threads. If you read it with too many threads, you get ghost steps. But you can actually differentiate these because they are rounder than the actual serialization steps. And another issue, for example, I told you, you can just sample both clocks to compute the clock frequency. On an AMD card that I have, this cycle counter only has 20 bits, and that's like 0 point something milliseconds. So this is also kind of a challenge because you cannot sample it once before your benchmark and once after your benchmark to get the average time. You have to essentially sample it all the time to register all the wraparounds of the timer, and otherwise it doesn't work. So yeah, definitely challenging.
Yeah. Thank you.
Any other questions? If not, thank you very much.
Yeah, thanks.
All right, hello everybody. My name is Richard Everhard and I work for a company called Advanced Application Design Inc. Depending on how you arrived at this year's wonderful Vulkanized, you might have seen our work. That's because we're a digital signage company. We do digital signage primarily for international airports, which means we are extremely interested in optimizing visual acuity. And a big component of that is handling color.
Guys, I'm gonna have to sort something out for real quick. It's gonna take me like a couple of minutes, so hopefully that's okay. Something's just come up. It's annoyingly getting in the way of coding, so be right back. I apologize for the delay, and I will try it again to sort this out. I'll be right back. Sorted. Well, for the most part, anyway. And we'll see if that works. Let me just is there anything more nerdy than this? I know, yeah. I'm just gonna clean up real quick. Be right back. Well, I'll be able to talk to you guys. Just need to make sure there's no flies and stuff, you know, because it's a hot day. Just washing the dishes. I'm right next to the kitchen. Okay, should be good. There we go. Let me just get you guys back up. There we go. Yeah, apologize for the delay. Hopefully you enjoyed that video. I know I did. Yeah, I was just trying to... For some reason, Google can't recognize my identity, so I've like had to send it multiple attempts to look at my details, which is very annoying. For some reason, it just can't... There's clearly an AI bot, like just not being able to read things. Which is very annoying. But anyway, right, what I'm going to do is, the first thing I'm going to do, play some, adjust the audio. So about 40 is good for you guys. You listen to, no, this is stage 3, I think. Anyway, right, so the first thing I'm going to do is reduce the amount of threads down to 1, and then turn a timer on and see if that's the issue, right? I'm not sure if my use of compute shaders is completely botched, so we might end up having to do some compute shader stuff in a minute if it just keeps crashing. The first thing I want to try is... See, I'm not entirely sure. If I look at the Arseni's renderer, we have a graphics pipeline set up. We have Streets of Rage music, yeah, 100%. It's sick, isn't it? Gotta love it. I've got loads of Mega Drive music on this playlist. Or slash Genesis. I don't know if you're familiar with the European. For some reason, it's called Mega Drive. Genesis was called Mega Drive in Europe. So yeah, as far as I can tell, we're doing everything the same, except we're not doing any of the complicated stuff, right? He literally just does an add, and this is, you know, accessing a shader, which just adds 1 to it. So if we should be adding 1 to literally a number and returning. But we still need to write to this buffer, so let's look at this. So if you look at our really babies first compute shader, this is as simple as it gets. We add 1 to 0, and then we just index into that. I think. And we should have something written to it. So I'm going to use 1 thread, which is obviously slow, but I don't understand why this crashes the GPU. So hopefully, I've turned off the draw call. What's up, Detri? How you doing, dude? We're crashing again. Very annoying. Sorry about that. Hopefully we didn't lose the stream. Let's see. Did I lose you guys? Stream health. Are we good? Yeah, I think we're good. Yeah. GPU's doing good. As far as I can tell, this is this number is 3. Number 1, sorry. So I'm not gonna run this compute shader. 1, 1, 1, 1. Now, if I do we here, thank you for the help. Yeah, I check on the if most of the time it survives, but sometimes it goes down, so I've got to be careful here. I'm trying to do an atomic add, but if I've got 1 thread, I guess it doesn't matter. Can I even access? I don't know if I can access these, to be honest. Right, question. Is this even possible to do this? Oops. Let's comment this out. There we go. So I don't know if it's the push constants or the data accessing or what, right? I don't know why this is dying on me. Oh, interesting. Out of bounds read 4 bytes at okay. Is this because I made it right only or something? I'm confused here. What? Why is it telling me there's a out of bounds read? I mean, that would make sense for the crash, right? 4 bytes at the end of buffer device address. Right. Clearly we're not uploading things. Build. The build boots up directly into the game project. I think so, yes. I'm kind of just running... Yeah, I think we got an empty buffer, basically. I think that's right. It is a bit confusing because this is the simplest thing of all time. I think we should be able to read-write this thing. It doesn't really matter. And I think the data... Let's just make sure the data is actually... When I transition it. So when I transition it, I go, okay. First things first. Set everything to 0. There's 4 bytes long. Then I transition the memory. To be... Okay, so the count buffer is the only one we're interested in at the moment. Yeah, it is read. It's definitely a read shader. This is only write, so we should be able to read something from this. Next, we do this. Okay, so let's just check. When I'm using any other types of shader that isn't this compute shader, what do I... Am I doing something wrong? I feel like I'm doing something wrong here. Like, is there a secondary thing I have to do with buffers? As far as I'm aware, you... Do I have to do them differently based on the frames in flight? No, I don't think so. We would get a different error. So we do it before we draw anything, because that's how it works. And we access 2 buffers, which should have something in them, which were created here. These were created beforehand. Let's just make sure these are actually ran. That's the first thing. Yep. Okay. So first things first is to make sure we're just not getting an early return with a bad. I need to obviously not run the compute shader, otherwise we'll crash again. So for now, I'll just comment this out. Oh, yes, we need to press start. Okay, right. I thought... What I don't understand by that is why didn't we... Okay. Alright, so we shouldn't do that again. Cool. Okay. Oh yeah, we got tons of stuff we haven't deleted, which is fine for now. So we have the command buffer, we have number of threads. So we're definitely not hitting here. We have we should see something like with valid memory. Let's just see. Yep, that's fine. What do we have here? We have handle 22 and handle 23. So we do seem to have allocated some buffers. If they are buffer device addresses, I think that's still. Hang on a minute. I think we create other buffers, right? In here. Yeah, VK storage. I think it's the same thing, but yeah. So yeah, once transfer, just indirect. And we're not using this buffer anyway, so we're only using one buffer. What do we need to do to get it into the shader? I feel like I'm missing a step where I just like push the data into the shader, but that's not how it works. We kind of just create the buffer with this, and then you have a buffer, right? It's like it's device only local, which is by design. We're not going to touch it on the CPU at all. We have the VK buffer. It would be null pointer. It's a success. If this is null, there would be something wrong. We do have a name for it because it does crash. We do get like a, oh, by the way, you can't read this thing, buffer device overflow. The thing I don't quite understand though, which might be interesting, is why is the command buffer all C's? So let's run the. So I think it's pretty safe to say that the shader is fine. What I'm looking for here is, sorry, the compute shader. I feel like I don't know. I feel like I've missed something. Right, let's go to the create buffer because that. Oh, we don't create a buffer here? I guess not anymore. That's not what I wanted to do. So, hang on. Buffer creation. So we have a, okay, uniform buffer. Oh, that's for the yeah, material, so that is uniform. And I'm confused. So if we let me think. Might get some tea in a minute. For moral support. I am confused. Yeah, no. Buffer creation. Let's do that. Alright, so when we do this positional buffer thing, we create a binary buffer. You have the handle, we do a buffer usage. Ah, right, okay. I made that mistake. Well, that's one big mistake. that I can fix immediately. And I need to use this everywhere that I've done this. So if I go into my game and I go in the this setup, so buffer usage. Yep, it's also this. And that's true for everything. So buffer usage again, it is a buffer device address. We do use it as a buffer device address, I guess that would be the right word. And now let's just see if that's the issue for our first step. So yeah, this isn't as a violent crash. Nope, still the same issue. Okay. But this is confusing. This C. Yeah, because we're not trying to write anything at the moment, so we don't have yeah. Okay. So we have a push constant when we are pushing up things that we've got here. And this is the size of... Guess I could do this. I don't know. I don't know if that's going to make any difference. Like, are we actually getting the data up there? I don't know. Nope. Okay, so we have a compute shader, which is fine. Okay, so everything's good here. It looks like we have one thread. We have the simplest shader of all time, which is just doing an axis. And it's still just falling over immediately. And this is an integer, so it's not exactly the most complicated thing of all time. Alright. Okay. Why is this falling over? Yeah, with one draw call, this turns into one. Alright. Let's just check for other mistakes that I made with creating the buffer, because I've had to use a completely different setup for this, because it doesn't do what I want, so yeah. So create buffers, create buffer, right? Okay, so when I run this code, it's always transferable. Yeah, but it's the bindless one I need to look for. This is the difference. Okay, so I'm not sure if we're doing this properly. Yeah, so let's make sure we're actually getting this buffer device address properly out, because we might not be getting it at all. And if we're getting a junk thing, which probably does exist, but it's like it doesn't know what it is at all. Where is the thing I was just looking at? Okay, so yeah, we literally aren't getting the right thing here. So buffer VK memory. Right, okay, so yeah, I've made a massive mistake here. No wonder this is not working. This is what happens when you have to do things for the first time again. So that goes there. Oh, hang on, that's the same thing, right? Now we need to make this a buffer device address. Yes, because we're not actually doing any buffer device address stuff here. Right, okay, and then we're expecting the shader to know what to do. Okay, so that's an easy fix again, but that's also another massive issue. Right, so the bindless one is here, and we need to do this to make it accessible, as far as I'm aware. This is the only thing you need to do. No, game. So, I'm glad I took a break because I clearly made a load of mistakes here. So indirect buffer, and then so GPU, and then this guy, and then we just need to make it for the other fella. So this needs to be the count buffer. Alright, cool. So now we actually have a valid buffer device address. Next, let's see if that's good. Okay. Indirect. Okay, okay. We might be getting repeating music. No, okay. Okay, let's see. So hopefully that bug goes away. Yay! We can access memory in the shader. Whoa, 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 whoa. Okay, cool. It's just me not setting up the buffer device address accesses. Right, next is to see, fingers crossed, we get... Right, if I'm going to do this, I'm going to do them all. Otherwise, there's no point. Oops, it crashes with them both. So, you know, if I do this, let's see. Sorry if we lose the stream, I apologize. Nope, there we go, that's fine. Okay, so it looks like, as far as I can tell, we have filled up some buffers and we've transitioned the memory properly. Next is to see if we have a indirect draw call issue, which is the next step. Okay, I did comment out the draw call itself. But as far as I'm aware, this is what we're supposed to do. I could be completely wrong, but yeah. And we're only going to do one thing. Max draw call count is offset buffer count, max draw call count, and the stride. Let's see. Please don't crash the GPU. Alright. Okay. No. We should see a billboard rendering, but it isn't. But we don't see a crash either, so it's kind of tricky to see what's happened here. I don't know if we've got all the right data. Is the light following us? I just wonder. No, it's not. Okay. Right. I'm not entirely sure this is correct. I don't know what it needs to be. Because the arguments are buffer, offset, and then stride. Like, I don't... Is the stride 0 when we don't need to stride over anything? Or is it all just zeros? I actually don't know. So I'm going to try zeros and just see what happens. But we should have written... I think I'll look this up in a minute. If this doesn't immediately work. Because this is my other guess. I don't know. Okay, yeah, it doesn't like that. Stride is invalid. Okay, so it just needs to be that, which is fine. Thank you, validation errors, for clarifying the stride at least. The offset, we're not really offsetting into anything here. As far as I'm aware. Yo, there we go. Look at that. There we go. www.w@w. Oh, an indirect draw call. Finally. Holy, that took hours. And it was just me basically not creating the buffers properly. Ah, man, you have no idea how difficult that was to do. I'm just going to explain it just because I want to. Right, so why was that difficult? So, a draw call count requires 2 buffers to be able to do a draw call with. And the way you want to do this is you want to use a compute shader to fill up that buffer. Okay? Yeah, I got it there. So, I'm going to explain it just because you'll appreciate how annoyingly complicated this is, I think, if you bear with me. So the first thing we need to do is basically have a buffer with 1 number in it. Very cool. I don't know why we have to do this, but this needs to be a transfer, storage, and indirect buffer, which is going to be used for indirect. This only needs we can only make this on the device property stuff. We create that buffer. Very good, very good. Next, we create the second buffer, which has to contain enough size to store all the data for each draw call, right? I've made this really big because maybe we want thousands of draw calls. Then we do the same thing, but again, it has to be GPU device. And I think this is straightforward so far. We need the buffer device address pointer, basically, to be created. Next step, here's where it gets tough. So step 1, access the draw buffer count. Then we start setting up the pipeline, the memory barriers. Memory barrier 1 for just 1 buffer, right? And this buffer has 1 number in it. Nothing can start. No indirect draw calls stuff can start. The L1 to make things accessible. This needs to be put to. We need to grab any L1 reads. Then we want to do a transfer. Change this to a transfer. So a transfer we have to wait for any transfer to wait on any transfer. So this can't start. We have to wait for a transfer to happen before the transfer memory happens. The count needs its own buffer indeed, yes. Because we need to be able to know how many draw calls we're actually generating from our buffer, right? So that needs to be unfortunately a separate buffer. Then we need to make this transfer writable. Okay, it's pretty straightforward so far. We obviously do this for the whole buffer, and with that we can do the simplest thing, which is fill a buffer with zeros, which just means we're setting things to 1. What if you want to count the beginning of a buffer and then set the offset of the draw calls by 4 bytes, lol? Oh, it's because of barring. Yes, that's... yeah, it's already been 7 hours. OMG, indeed. So, this is why, though. I'm explaining. So, so then, basically, once we transition this from... we've got to remember, right, why are we transitioning immediately? Well, we've got to remember that this is a loop. So we've got to transition this from the previous frame. And the previous frame was doing an indirect draw call, right? So this was in indirect draw call memory read mode. This is in indirect draw call pipeline state. So once we finish, we have to then transition once we've got to indirect draw calls. So this is the beginning. This is like, again, you've got to remember that we're not starting from scratch here. We're starting from an initial loop. We fill that up with zeros. Then we do 2 other buffer memory transitions. We take the count. I'll do the count one first. So the count one first has to go from its transfer write mode into a compute shader bit read write mode, and this is because it's going to be using a compute shader. We have to take our indirect draw calls, not the count buffer anymore. And we have to take that to from an indirect draw calls vertex shader, which is what it was in, into a. Oh, so this is what the memory type was. So it was readable in the shader, and it was used as an indirect draw call read, right? Then we transition that into a shader we make sure the shader pipeline stage hasn't started yet before the transition has happened, and it needs to be the memory needs to be visible in access shader write mode. Okay, we transition that memory over. Then we set up, I'm not going to go into this, but we need to make sure we match the amount of threads that we're going to run per draw call. I think, right? I think that's what this is doing. I'm not quite sure yet. But yes, those buffers that we've just transferred into basically compute shader readable, we then push them into the push constants we have specially for this compute shader. Then it runs this shader. This shader takes in the buffers, the draw count, adds one to it atomically. So if we have multiple threads here, all the threads get updated with that piece of information, and then we write out the draw call data that we're going to be used to generate the draw call. In our case, we are using the simplest indirect draw call, and we're not doing any culling right now because we just want to render one thing and see if it works. Right. Next, once that's ran, we have buffers, but we need to then transition them out of that state that they were in the compute reach state. So the next memory barrier is we take them from compute shader read, the compute shader stage, which was currently in shader write bit, which is where it was visible. Put that in the L2 cache, and then change this to vertex shader indirect and read, which we have here as well. That's what the memory needs to be. So that's the pipeline stage that can't begin, and this is the memory it needs to be in, and that needs to go to the visible L2 cache. And yeah, that then gets transitioned to that. Same with this, but we don't have to read this. We only make this as an indirect draw call command. Then we go to the renderer, and basically the same as before with the compute shader, but we're just doing a different buffers for rendering, right? Different buffers for rendering. So we're in the render loop now, and then at this point we set the indirect draw call with the buffers that we just wrote to in our compute shaders for both count and sorry, this is the count one, for both the count one and the indirect count one. Then based on that, the GPU will construct a draw call by itself based on these buffers, which have only ever existed on the GPU. That's important. So this is purely a GPU driven all the way through. So these buffers are purely on the GPU. And then it runs, where is it? It runs this shader, right? This vertex shader. And then obviously the fragment shader afterwards, where it does the billboard calculations for us. And then we start that loop again, where we have to transition them out of indirect draw calls back into clearing mode, and then clearing mode goes into compute mode, and then compute mode goes into indirect and vertex mode, and then it can be drawn. Right. Do GPUs have lock-free atomics? That's dope. Pretty much, from my limited compute shader understanding, atomic add is pretty efficient. It's really good. You can do, I think it's just as good as using subgroups operations, atomic add. Hey, how you doing, dude? I was just explaining. So it's really powerful. So yeah, that's why it's taken me like, I don't know how many hours to do this. But yeah, it's intense. Oh, let me just put you there. I was messing around with my thing. Right, now we've got to figure out how to use this in a way that actually makes sense. We've actually slowed our renderer down, by the way, by doing this. The reason is there's a lot. Running this compute shader is like a massive level of indirection, but this stuff is cool, man. Thank you. Why did we do this? Why did we do this super complicated step? Well, now here add the particle logic, and what we can do as well, plus if we want culling. Now you can imagine this, right, where we do the particle logic, we'll also have to write out another buffer, so unfortunately we're going to have to do more of the pipeline barriers to carry over the data that we need, but we can do compute-based particle physics, right? Yeah, they're not implemented with locks. I don't know. It's some kind of black magic, to be honest. But yeah, that's the whole point of doing this. And this is the backbone of a GPU-driven renderer. And eventually we'll probably do this for everything, where we'll just do compute shaders that can occlude things based on the camera. And because we're doing these with buffers that only exist on the GPU, then it's fully GPU driven. The CPU doesn't have to slow us down at all. We can blast ahead with this rendering. Right. Now I have to learn how to do shader-based particles. So hopefully that made sense. I know some of you aren't Vulkan heads, but I will say this. If that was confusing to you, I think it's safe to say that Vulkan synchronization is the most confusing part of Vulkan. So if you're like, whoa, that was intense. As far as I'm aware, when it comes to general use of Vulkan, maybe there's some extensions out there that are harder than this. General use of Vulkan, synchronization takes the cake, I think, in difficulty. But yeah, so yeah, now we can do particle stuff in this compute shader and cull them. View frustum can probably be done on the CPU with AABB, but modern occlusion culling techniques are done with compute. Yes, you can do. The reason you'd want to not do view frustum culling on the CPU, even if you can, is because then you don't lock up other drawing things, right? Let's just say at the beginning of the frame you have to do a view frustum cull, but for some reason a compute shader is doing some physics. Like, it doesn't need to know this data, so it can just blast ahead and do its own thing. Assuming that your synchronization is set up where everything in sequence is happening correctly, you can basically allow other action commands to just run. Like, let's just say, maybe that's a bad example about physics. Transfer commands, right? Like, a transfer buffer command can happen, right, while we're doing a compute-based view frustum cull, right, rather than having to let that wait. So that's why you'd want to do this. Yeah, transfer is probably more accurate. Or some image, something, you know, with processing some image thing, scaling something up or something, you know, all that kind of stuff. I don't know. So yeah, that's why you'd want to do this. It's like generally, I heard that some are running really low res software renderers for occlusion culling. Yeah, that's probably yeah, it's Hasflow, my beloved indeed. That I think is for nanites, but if you want to do occlusion culling, I don't know if I'll do this, but you have to build occluders, or you'll have to do mesh shading, because holy, it makes things easier. Basically, you run the same algorithm. It's really cool, actually. So occlusion culling with geometry in the scene, even with the view frustum, you need to bound things in something that's preserved by what is it called? It needs to be preserved by the perspective distortion, right? So, for example, if I have a model in model space and and then we don't apply the, I'm going to change the music, it's looping, and we don't apply the perspective distortion, then it's not actually correctly you know, everything's not correctly done. So you need to kind of like do this thing where you wrap a you need to do this thing where you kind of put basically a piece of geometry around it that stores the perspective geometry, so perspective distortion, and then you have this like safe conservative test. Now, if you do that on meshes, that works fine. You don't do it with mesh shading. But if you do it with mesh shading, you can do that same sphere-based technique on meshlets, like the individual like sub meshes of meshes, right? and you can get like really advanced. You can build them as occluders. I'm going to take a shower. See you guys. See you, man. Thanks for your Angelica is cutie. Yeah, so it's occlusion culling has given me the most trouble out of all the graphics techniques I've tried. Lol. Yeah, it's a tough one. I've only ever done it with meshlets, and that has given me issues as well, due to the fact that occlusion culling. Let me think about this. Occlusion culling. Yeah, animation. Animation made that impossible, basically. If I animated something, I would need to, like, you basically... Oh, it's really difficult. You basically need to build up a bigger sphere that surrounds a meshlet when you move... So, as you're probably aware, when you do bone-based animation, right? I think I've talked about this before, so feel free to... feel free to step in and say, you know... how long have I been a software engineer? Probably 6 years and 11 months, I would say. An employed one, anyway. So, if you do meshlet culling with these spheres that have perspective distortion on them, so you can do like occlusion culling against other meshlets, you have to worry about the fact that animation distorts the meshlets, so it moves out of the way of something else that would been if it was in a static, like T-pose, for example. So you get this issue where you get holes in the geometry. It's really annoying. Luckily, I have simple geometry, so pre-depth pass. It's pretty cheap. Yeah, that sounds good. Recalculating the AABBs every frame to test against that. Yeah. What you have to do basically is build that bounding sphere bigger, based on the whole sweep of the animation that possible meshlet can follow. So if you've got a meshlet that has like a tiny little sphere, but it animates crazy, like because it's on a dragon's wing, right? Like on the edge of the dragon's wing, you have to basically make a massive sphere, so it doesn't get occluded by the view frostum, and that also goes for occlusion culling as well. Like, so it's I got 3.5 pre-insurance 30th of June. Well, I hope you have fun in your new job. So yeah, it got very, very complicated very quickly, and it's one of the reasons why I started again. I needed to like take a step back and not do meshlets. Anyways, yeah, right, okay, so I'm really happy that worked. That was sick. That was I'm just gonna look at it again. The indirect draw call madness that we just went through. There we go. There it is. Indirect draw call. All right. Very nice. Now we have to do a bit of a research task because I don't know how to do particles. Very well. Or how to do them in a compute shader at all. So what I think I'm going to do is start to look at the book that we had out yesterday, right? Zen GPU is probably in here somewhere. Again, I own this PDF, so please support the authors of Zen GPU. Don't just rob. You know, if you can afford it. I'm not going to say that. Some of these books are extremely expensive. I'm very aware. Where is the GPU Zen book? There it is. It seems all the cracked devs use Firefox. Lol. Yeah, I well, thank you for calling me cracked. I think that's what you're referring to. Yeah, I like the fact that the it's not Chromium based. All right, so let's see, 1, 2, 3. Okay, so we were looking at this yesterday, right? And we got as far as, oh shit, we're going to have to do some indirect draw calls here. I've been playing Arkham Knight, and damn, that game looks good for over a decade old now. Yeah, it's sick, Arkham Knight. Yeah. Arkham Knight, Arkham City. Probably not Arkham Asylum. I feel like Arkham Asylum is a bit dated just because of how it decides to do colour. Guilty of not being a crack dev. Escape point is cracked. It's I don't feel cracked, I'm not gonna lie. But you know, it is what it is. Right. It's giving me more confidence now that I can do this for other for the index draw calls as well, because I've only done this for the non-index draw calls on purpose, because we're not going to use just so you're aware as well, this is quite useful. If I look at this, this is our index buffer, right? So we don't need to store a separate buffer, we can literally just index through it. It's never going to change, we're always going to draw a quad. Right, let's get open our... So that was really good. I'm really happy with that. That's really good. So let's get open this. Whoops. And start to figure out exactly how we should be doing things. Browser choice is a decisive factor for a title of cracked dev. Everybody knows that. Well, why is my ID showing? There is a good question. That's because an extension I'm using for my shaders doesn't understand more advanced shader stuff. So it's saying this extension is not supported, this extension is not supported, this extension is not supported, and then it doesn't understand how you can access buffers via a buffer device address. It just kind of completely falls apart. So you can see it here, it's pretty terrible, pretty gnarly. But the only reason I have it is because of syntax highlighting and a little bit of auto completion. Otherwise this would just be text, which would be hard to read. I should try and turn this off actually. Let's see if I can do that. But I think I tried this once and it just disabled the installs and... Oh, hang on. Maybe there's a better version. Because this is for... Hang on. I just realised this says for Visual Studio 2020. Let's disable it for a minute. Browse. GLSL. No, okay. It's still this. Okay, enable. But I think there is a way to... maybe I should use this instead. Let's try it. Because I really just need a syntax highlighter. Is it installed yet? Did it install? Oh, yeah, we'll wait for this, because effectively that's all I need. But yeah, because I really don't need, like, advanced error checking, because the compiler complains. Maybe you can update as well. So everything's taking forever for some reason. Yeah, I often make more mistakes when I write in plain text. Installing Chrome will make all dev knowledge instantly leave your body. I see, yes. Yeah. I feel like if you installed Internet Explorer, you've kind of gone full circle, and you've become cracked again. How are things? Yeah, not bad. I'll show you. We're trying to install. I don't know why nothing's working at the moment. We're trying to update our extensions. But yes, we got an indirect roll call working, which is very nice. And now we can start investigating how to make this better. Yay! Yeah, I don't know what is going on. Oh, we need to clean that up as well. We're not deleting tons of resources that are on the GPU. There might be a way to enable C syntax highlighting on a file extension, but I'm not 100% on that. Yeah, I've got to be careful with the file extension because the compilers need to... The GLSL validator compiler needs to know what this is. That's why it's called vert, frag, and comp. Like, they're not named for my sake, it's more for the compiler. Now, you can mess around with them and, try and get rid of the final extension, like .c or something. But the problem is with that, you've got to write a lot more CMake to get that to work. Because you've got to exclude the final dot, it's kind of a pain in the neck. So, for most part, yeah, I don't know what is going on with this extension. Yeah, VS 2016 is very heavy, but it shouldn't be this long. Maybe it's... Right, I'm gonna try something 1 minute. Let me cancel out of this. Because I'm not administrator on this, so maybe running as administrator will work. Or the extensions are just not working at all. What? New project, I guess. No, go back. Yeah, open a project or solution. Where are we? Oh, we're over here. Let's not do that. Oh, why are we even... Jeez, we're in a complete wrong place. Where's the C drive? There's so many things here. C. Where's the user? Onga. And let's see. Run this. And maybe the extensions now will install. Who knows? Okay, let's see if this updates. Wait, why is Copilot installed? Who installed that? Uninstall. Uninstalling this extension will launch Visual Studios. I don't care about whatever that is. As it enables... Oh, I can. What, have you found something? Where's the Copilot thing? I think it's Copilot snuck on here. I'd prefer it not to be on this thing at all. I don't see it though. Okay, it's GitHub, no. Have I got rid of it? I do not see it. What? MSVC ATL build just in time. This is a bit of a procrastination this. We could just be doing something else in a minute, but I don't know. Oh, okay, so yeah, there's some stuff down here. Okay. Whatever. Let's look for Copilot. What? Where is it? Oh, it's removed it. Okay. Modify, yep, sure. There we go. That's what it was, yeah. GitHub Copilot. My bad. I thought I threw you off your whole floor. It's fine, it's fine. We'll, oh, right, okay, yeah. Let's try again. Oh, now it wants to do it. Okay, for goodness sake. The new update is fucked up. Mojang nerd sniped me into a building redstone display. What? Damn. Modify. Okay, so now right, I think I'm gonna disable this and try and install the other one. I've kind of gotten used to it, but getting used to this is kind of stupid. And then we can go into the particle investigation. I don't know if this is going to teach us that much, to be honest, but I am kind of curious, because the problem with this is it's super complicated. And I think what I need to do is not have a bit field buffer at the moment. Okay, cool. And that's gonna be fine, I think. Oh, I don't care. Just forget it then. How is every national here speaking better English than you? A British man. Yeah, GPU is my Zen 3, yeah. Oh, yeah, that's true. I am, like, half reading, like, trying to half pay attention. Okay, so now it just doesn't work. Oh my goodness. So let's remove that then, if it just doesn't work now. Okay, it's been removed. Okay, so now if I close this, hopefully it'll install, and yes. Okay, so this is how you're supposed to do it. I didn't realize they had to close the program. Very weird. Oh wow. Someone posted a load of assembly in the Discord. Flipping heck. Yeah, reading things live, yeah, makes it harder, I guess. Yeah, I don't understand this installation process. Well, I didn't say Visual Studio was good. I'll say that. Right, so maybe we have syntax highlighting now that isn't insane. No, okay, we have the same issue. Oh well, back to square one. Well, that was a big roundabout waste of time, eh? Alright, so how is managing Microsoft toolchains always so complicated? Unix toolchains would never, yeah, I don't know. I'm kind of used to it, but so it's not the end of the world. Okay, so bit masks, we have particle sets. I wonder if there's like a intro to, because this seems like an advanced, you know what I mean, like I need to go against a white belt in particles, right? Not a black belt like straight off rip. I mean, I could do it, but I'm just gonna have a little Google search actually, just to see if there's like a compute based kind of thing going on. Compute-based particle, maybe just like an article out there. It's like articles, because that would be nice. Because I just don't know the algorithms really to run and what I need to do in the compute shader, and how that interacts with the. I think we're okay with the draw calls and stuff. I just need to make sure that I, you know, get the velocity working properly and all that kind of thing. This might be like a case for maybe write it. Yeah, hang on. Let's just experiment for a bit. let's just experiment. Let's just experiment. If I have, instead of doing that, let's just experiment. Oh wow, Powell's out, version 1. Nice, that's sick. Is it doing well? So what we're gonna do, I thought the I'm glad the what is it called? The suing hasn't taken it down or anything. So particle logic. So this is obviously at the end of the shader, right? But in the meantime, outside of this, we need to be able to write some data to a buffer that updates, that gives us a position change. And then we can pass that over to the, what is it called? To the vertex shader for vertexing. So if I look at this, we have a quad position thingy, right? And I think what we want to do here is write to our compute shader. Actually, the other thing I want to try is if I go to my compute shader, you know, when this is being built up, this is supposed to be 64, and I'm kind of curious if we do this with 64 threads, is it gonna like break? Please don't break. Yay. Okay, so it just behaves normally. Thank goodness. In theory, that's gonna be way faster in the future. Right. That also means that we need to change something in the game code. Actually, we should commit this. We should commit this. We're about to do a massive change. I made this mistake yesterday, right? Where I started working on stuff and I didn't commit anything, and then I broke everything, like instantly, and I didn't have a place to go back to. Yes, let's commit. We have an indirect draw call working. We have a compute shader doing its computing. All right, cool. Yes. Let's not forget to do a commit. That's extremely important. When will you write the Minecraft, Minecraft in Vulkan? Yeah. Apparently it's not very good, the Vulkan renderer. Ratchet has thrown it in. Yeah, this is still work in progress 100%. But we need to commit this, otherwise I'll lose. I don't want to lose work. What is the new vertex shader 2? What is this? Actually, what is the difference? Oh, what is the difference? Literally, what is the difference? Alright, let's just diff these quick, because I'm not actually sure. I think I did this as a development thing, but I'm not entirely sure if I want to. So, I'm just going to open these up and meld. Can I do that? No. I'll just copy this then. Yeah, it's still mostly OpenGL. It's got a experimental what is it called? Renderer. But it's not finished. And according to Ratchet, he looked at it by throwing it into RenderDoc, and he found they're doing a giga. Okay, they're identical. So I just can get rid of the new one. Let's get rid of that. Don't want to commit more than we need to. Source. Yeah. According to Ratchet, he's thrown it into RenderDoc himself and had a look at it. He loves Minecraft, by the way. That's why he did it. And they're using giga barriers, right? Apparently. So one barrier at the beginning of the frame and one barrier at the end of the frame. Which isn't good. You know, you've already seen how many barriers I have for one index draw call. That's like normal, like you're supposed to do that. That's because despite it looking like it's slower, you allow other commands like to just not get touched by that barrier. Do you program C++ at your job? I used to, yes. Currently unemployed. That's the only that's why I'm able to stream so much. Right. Microsoft employees lost access to code, so they can't. You can't blame them. Yeah, fair enough. Yeah, there we go. Can't blame them for that. Yeah. Right, get rid of this. We don't need this. This is exactly the same file. Sorry, let's get rid of this. There's often complaints if I don't do that. Yep. I am. Right, let's give this a commit. Yeah, I've been... Yeah. Hey, Heisenberg, how you doing, dude? Let's do another git add, because that'll be a file removed, I think. Git status. We have done a commit. Let's do commit. Added a indirect draw call that is completely GPU driven for rendering one particle. Yeah, so there we go. Employed in this economy, yeah. Imagine, yeah. Please censor that word job. It's sensitive to my neat brain. No. I'm kind of just seeing, like, if I can make something, like, before I go back to work, like, something cool. I did save up a bit, like, while I was at work, so... that's, like, what my, that's my whole thing at the moment. Okay, so we need to regenerate the project. You know where you pressed title? It pop. And it pops up at the top. Yeah, don't quite know what that means. There we go. Okay. Oh, forgot to clean up everything. I completely forgot about that. Okay, so let's yeah, that's good. Yeah, as long as you're working hard and stuff, that's important stuff. Okay, so this is completely balked. Let me just restart. Oh, my message mentioned commander and got filtered. Lol. Microsoft is watching you. Yes. Right. Let's clean everything up that we've. I'm gonna have to commit again because I've done that by accident. Didn't. Well, we all know that more commits equals better game developer, right? So. Right. Let's go in here and figure out. I don't think it's that complicated. We only have 2 buffers and a graphics pipeline to delete, so this isn't going to be that difficult. Actually, it's just 2 buffers. So on shutdown, we just need to shut these down. Yep. So what is it called? Counts. Lazy mode activate. Okay. That should be that. Commander sounds like the most useless thing, by the way. Let's just make sure this works now, and then open the game. I was told I should commit every 5 to 20 lines. They'd be lucky if I commit it. Jeez, that's nuts. Why would you commit that much? Yeah, there we go. Okay, so that's all I was missing. So I will just commit that as well, because we do want... I do want a complete clean... even if we have to go back to commits, that we kind of... commit... Added... sorry. fixed allocation, deallocated everything correctly on shutdown. Cool. Yeah, same. I saved pretty well, so I don't have to jump to a same job. Yes, to his new job straight away. Yeah. Commit some changes. Yeah, 979 lines added. Yeah, that's funny. That's funny. That's exactly the real Giga Chad way of committing stuff. Anyway, right, okay, so we committed everything. Now we can fall back on stuff if I break everything. So my experiment is that I want to write to a... So we are reading in a buffer right now. And let's look at this buffer, right? And we might actually not be reading anything in. Let's look at this. So we have this, which I don't know what it's doing for us at the moment. So we have billboard position, right? So I want to be able to write to this in the compute shader. You know what that means? Pipeline barriers, woo! Minor fix 420 lines modified, yeah. But yeah, you're right. There are better and more mature out there, yeah. LGMT. Yeah, I just about learned what that meant yesterday. Yeah. It means lithium, gold, titanium, manganese, right? Manganese, yeah. Or magnesium, right? Yeah, I can't remember if it's manganese or magnesium. Yeah, something like that. Yeah, it looks good to me. Yeah, I know. It's that we had this conversation yesterday where I ended up thinking it was literally that, which is quite funny. Anyway, right, let's dive into the next step, which means we want to write to a buffer in our compute shader, which means we need to make it accessible, which starts with the thing I love about buffer device address accessing stuff is you can just throw it in, and you don't have to worry about bindings or anything. It's so nice. You put it on pull requests when you don't read it at all. Yeah, senior dev thing, indeed. Right. So, what do we need here? We need to grab quad position data. So this needs to go inside our compute shader. So this is my goal here. We need a... Alright, I need to start putting stuff in includes. So what I'm thinking is having a 2D and 3D include, where we just kind of have the same things in different places. Because right now we're going to have... What do we do in the actual regular shaders? Hang on. I think we just like put the same thing in multiple times, right? Yeah, so if I'm using that again, then like I think model positions is used in 2 different places. Let's just see. Yeah. The problem with that is if you modify it once, you end up breaking it if you don't modify it everywhere. So let's go terminate mode. Yeah, terminate mode. I like that. Let's go total mode. Yeah, that's also a good one. I always feel like I ruin it by explaining to myself. I just got to clarify. I always feel like I ruin it by explaining myself, but I got to clarify. I'm not really offended. Oh, I find that. Sorry, I find the title of senior offensive. We prefer burnout. Yeah, that's good. All right. So what we're gonna do, I think, before we continue, is due to the fact that things are getting a bit complicated, meaning that we have like multiple definitions of things all over the place. I think I'm going to start putting stuff in headers. I've just got to decide what that is. I think the easiest one right now, anyway, is I'm just going to do it for the 2D shader, right? And then we're just going to include that Google include extension, whatever it's called. What is it called? In fact, I think what I'm going to do is actually I'm going to ignore. I'm not even going to Google it. I'm just going to wait for the error message. Because we need this quad data in 2 different places, I am going to put this is the first thing I'm going to move. I'm just going to do it like one thing at a time. So let's go into our source shaders. I wonder if our CMake supports this. So it's gonna look for it's gonna look for the headers as well. Do we put the headers in? Yeah, we do. Okay, so that's good. But it's only gonna look for it in the shader file, right? Yeah. Okay, cool. So in here, I'm gonna put a new file, and I'm gonna call it like senior devs here, and pretty sure. Oh yeah. Pretty sure Escape is dyslexic. Oh, sorry. Did I read something like stupid? You're like an English teacher that reads the sentences over to find the meaning in them. What does the author mean by that? Yeah. Yeah, that's it's chill. I don't think he meant like I'm reading things poorly. But yeah, thanks for looking out for me, Detry. But yeah, no need to worry. So anyway, let's get this in. So let's. That was the goal list. 2D data, but you can do that, right? You can call things 2D data. That's my Windows noise. Senior dev here earned my previous salary in a month. Yeah, it's I know what you mean. Like some senior devs get overpaid. Some, not all. I will admit, some are absolutely cracked, and it's just like they need to be paid even more. I just want to make sure when I'm reading stuff, I don't misinterpret what you're saying. Where is the? Yeah, I'll tell people off if they're being rude. Right. That's regenerate, please. Yep, thank you. Hi, just saw your new video on AI use to learn. Wanted to ask, is it counterproductive to even learn about theory from LLMs, like clearing from clearing some theoretical doubt? Okay. Well, there's consequences to using technology, and I would say the problem is with LLMs when it comes to learning theory, even if it's not, you're not copying and pasting code, is that you can end up in a situation where, one, you learn it wrong because the LLMs get it wrong, right? And two, you end up losing the ability to extract stuff for yourself, right? So I would say, in my opinion, this is probably not as popular as what I said in the video. But I didn't bring this up because I don't want to tell people what to do. But if you're asking, I would say I wouldn't use AI to help with anything other than search engine stuff. That's my personal approach. Just because of AI is unreliable, and you degrade your own ability to sift through resources yourself. Just like the same way people who use calculators eventually start to degrade their ability to do arithmetic, right? So, I personally value that skill of being able to learn theory from books and YouTube videos and take notes and stuff. Hence this obsidian thing that I mentioned in the video. So it's like, I would end up losing that skill if I just went to LLMs every single time I needed to learn something new. So yeah, I would personally stay away from them. The only time I've personally used them is to make quizzes for myself. And even then I ignore what it says when I've answered the questions. Because I know because I don't trust the theory that it spits out. So hopefully that answers your question. What am I doing? I'm trying to think. I don't disagree with that. But Europe, yeah, makes things. Yeah, they are. I don't live in London, so that helps. Yeah, so it is more. And what are the people who heavily rely on AI going to do when their services, services outage, take days off? Yeah, it's Midnight Polygon's exactly right there. You, in my opinion, I think it's a tool that can be used usefully, like for search engine stuff, maybe for making quizzes and stuff. But I think it's like it should, in my opinion, if I was to I don't know, mentor someone to become an amazing graphics programmer, assuming that I'm amazing, right? That's a big stretch already. I would immediately say, like, just don't use it at all. Anyway, so that's what I would say about that. I'm not a big AI hater, I should just mention. Like, I actually think the technology is cool. I think it's cool that we can get computers to retrieve information and parse human speech. That's kind of cool. It's kind of cool piece of tech. But using it to replace your thinking, I don't think it's a good idea, in my opinion. In most contexts. Oh wait, all the red squiggly lines are gone. That's cool. Right. Maybe it has worked. Let's see. Alright, so I've deleted that. Can you work out what this is? And I'm going to compile. I think we're going to say we're missing an extension here. So, yep, what is the extension though? Oh, I was hoping it would tell us what the extension is. Hire people that know what they're doing. Yeah, yeah. All right. What's the including extension for a GLSL? Right. So include extension. For GLSL. Yeah, I mean, our CEO did, like, basically sank our company. It's like a Google one. What is it called? Google. Actually, I can just look at this. It literally has it in here. It's literally just there, right? Yes, this thing. It's not included on every single... Is this included everywhere though? Hang on. Let's put this here. How widely supported is this? Support. Do I have... Can I look at my bookmarks, maybe? In this? For... No, that's that. I'm not interested in that. I'm interested in... Surface memory formats, properties, version extensions. Let's try... I don't know if this is just Vulkan extensions. Okay. Right. I think we should be good. I think the spiv is fine. I'm sure the spiv just is able to copy and paste stuff, but I think we're good, right? Oh, interesting. Do I need to put it immediately after? Hang on. Why aren't we getting the... vertex... Where are we? Vert... 9. Could not process... Why? Can't you do that? Maybe you can't do that with the name. All I see is Detri say, I'm coping. Oh dear. When the bubble bursts. Oh yes. It's going to be amazing. Yeah, I don't think it's going to be good for us, sadly, but... At least people will be punished for their hubris, I guess. I don't know when that's going to happen, so I'm not going to count on it popping anytime soon. Right, okay, so this is being awkward. Why is this... I'm going to Google this just straight up and see. Like, what the heck? Obviously remove this. See what Stack Overflow says. Maybe enabled is correct here. Enable. But I am saving this, right? Require. Or do I need to add? Hang on. Is there more to this story? I bet there is. I bet there's an annoying, like, oh, you need to put it in the... I thought it was literally just this. Hang on. I definitely... Yeah, Stack Overflow is tragic. Hello, hello. Welcome back. Squeaky clean. I don't understand what's going on here. It's you have to remember that the market can stay irrational longer than you can stay liquid. Yeah, I like that. That's a really... That's how I feel. That's how I feel. The stack is overflowing, perhaps. No, I don't know what's going on here. This is kind of... What is happening? Alright, let me just look at things. Just make sure that... When it says mesh, is there anything that we're doing that we need to... No. They're just macros. Okay. There's nothing I have to do with that. Oh, the music stopped. Let's pick a different track. I don't mind this one, but that'll do. Okay, so alright, come on AI, get me to what I need to. Oh, is it called something different now? Okay, I think it's actually in Vulkan. Let me look at this up, yeah. See, that's how I use AI. You know, as a search engine. Is this a... Oops, okay, we're back here again. I want to see if this is an extension that we need to add. No, this is part of OpenGL. Right. Why is this not included by default in the shaders? I do not know. In GLSL validator. Oops. Nope. Include could not be passed. Okay, so. Thank you, YouTube bug. Yeah, I don't get it. It's really annoying. Are you talking about something you come into contract with? Oh my goodness. The afternoon slump, eh? I mean, I could change compilers. It doesn't really matter anymore. I stuck with GLSL validated because the SPRV is easy to parse versus GLSLC. Yeah, that's what I did. Okay, so that's not supported. Right, well, try again, but I don't think this is going to work. No. I don't understand this at all. Maybe they've taken it out. Oh, excuse me. Let's do a bit more Googling. Liquid MI 0.1 MI indie game dev. That's it. Oh, it messed up your ASCII. Oh, never mind. Oh well, indeed. We just talked BT. Oh, we just talked about it on short notice. Okay. Let's go with Vulkan, right? Because I don't quite understand what's missing. I thought it was a compiler thing. Anyway, GLSL validator perhaps. Oh, there we go. The command line try-l for linking a full store. Okay. Okay, so we just need to add a -l for no reason. For full linkage. Alright, fair enough. I was expecting we were missing something. Hello, just watching. How are you? Don't look at my server clutter. Oh, I see. You're talking about your Apache web browser. Yeah, we have ASCII. Yes, you can do ASCII for that. All right, let's keep going. Jolly good, jolly good. Fantastic. I'm glad you're doing well. All right, so let's see. Does that know what to do with it? Okay, hang on. It's just going to regenerate first. I have no idea. Does it need to be after the... I don't know where this command needs to go. There you go. Right, I'm also going to take the absolute path, I think. Yeah, let's just run it again. Nope. This is definitely -L, right? I feel like we're getting stuck on something stupid here. This is just... Alright, maybe I'll come back to this one in a bit. Yeah. Kain... Yeah. Za. Kainza. Oh my goodness. Alright, whatever. So this does nothing, and the world is a lie. So apart from that, we're doing great. This shouldn't be this complicated. I do not understand. I see them sometimes in mirrors, lol. Yeah. I'm not convinced this worked. Like, I don't think anything changed. Let's try again. Are you processing... Are you processing shaders to spiv? Yes. I'm trying to get the include to work, but I don't understand, unless you can like immediately see my mistake. I've got this in here, and I want to do like an include, just because things are getting like tricky to keep track of. Ye as in Jesus. What is this? So that's what I'm stuck on at the moment. It's not like a big thing. I can just like not use it, but it's still. I would rather use it. Maybe. What is that file include? Yeah, let me show you. So it still exists, and it's in, just so you're aware, yeah, it's in source shaders, right? And this is also in source shaders, right? So it's just a I was just like kind of testing the idea. Oh, I can't find it. Huh. Ah, okay. Yeah, we can try that. Morning, Mika. How you doing, dude? Uh-oh. That doesn't look like it knows what it means. But yeah, it can't could not process the directive for header file. Okay, so so I think it knows what it's trying to find. So I'm going to find what I'm going to do is I'm going to do the absolute path, right? Are you using slang compilation and reflection API to compile shaders on the fly? No. I'm just using GLSL. I did used to do that, but I don't think that's correct, but I'll try that as well. What I'm going to do is send the absolute path in. Let me just get the absolute path for this fella, and just see if it's just the pathing itself, rather than. So the reason I don't do that, by the way, is just because it's I don't need the hot reload of files, right? I should really do it the other way, because this both works on Linux and Windows. I don't know about Linux with the other, with //. Okay, I'm gonna head out and play some Payday 2. Well, enjoy. Good luck, Matt. Good luck on your games. Thank you for joining us, by the way. Right, so we're just gonna do that, and just obviously this is not good. No, okay, so it just does not understand what this means. I I just don't understand why. So it just can't understand the hash include. Which I thought it did. Oh, I thought it could. Maybe it's a bug in the compiler? I'm tentative to say that because often when I say it's a bug, it's me every single time. But this is too simple to be like anything that complicated. And it is GL Google include directive. Try inserting .h from the menu. You mean in Visual Studios? I would probably or only do that if I had generated the shaders, and yeah, that's what I don't want to do. No, Tokyo Spliff is live. There we go. Guys, don't leave me. No, it's totally fine if you do. Okay, so fine. I'll remove it and then re-edit. Move. In loyal, love that. We loyal. Don't worry. Yeah, it's all chill. I'll be watching him later probably. So when I stop streaming, I'll probably be in his stream. So I'm saying, of course. Add existing item. I haven't done this in ages. Whoops. Nope. Don't do that. Where is the... Okay, and let's do this again. Nope. Oh. Nope, same issue. I generally think it's... I've got a sneaking suspicion that we've got like a weird compiler here. Times it's human to be disloyal, yeah, pretty much. Curious what it's working on. Yeah, I'll have to check myself. I'm gonna stream for another 2 hours, so I'll probably be in that chat soon. Yeah, but we gotta grind, because if the goat's grinding, we've got to grind too, you know what I'm saying? We gotta grind as well, bro. Oh, you actually ran into ice the other day? Ugh. I jinxed myself, jeez. That's rough. I didn't know you were American. There we go. Right, I'm just going to ignore this. This is a non-issue anyway, so... Yeah, we got to grind for 12 hours, come on. Yeah, I do want to eventually do a super long stream. But you know, we've got to try hard. I was saying this earlier on. I think I gave like a bit of a rant, not rant, but like an advice stream. Someone was okay, we've got 6.5 here. Yeah, I was saying to people that Relics is actually here, by the way. You should make sure that you try to make sure you don't regret your life decisions by not taking life seriously. Whatever that may be, to forge your own path. So yeah, that was a good thing to be talking about. Okay, so we should have a device address, and I'm just going to kind of do the same thing here. Quad data, quad position, PTR. So what we need to do is be able, like, because that was a big thing. I am American, but not that ice lol. Oh, okay. Oh, you ran into an ice. I see. Yeah, well, that's good. Anyway, so we want to have a buffer device address now. It's increased in size, and we need to be able to do something with that. So what I'm going to try and do, guys, is at the very least, I don't know what I'm just going to change the position in the shader. Oh, thanks for just watching. That's really nice of you. Thank you. That's really nice. Thank you for the lovely donation as usual. You're honestly too kind. But I very much appreciate it. You know, I'll give you a heart and chat since I can't do it on the emoji. 2 hours motivation. Thanks, dude. They are going to deport me back to Texas. Honestly, be my guest. Fair enough, yeah. I think it's rupees, right? Indian rupees. Like, listen, it doesn't matter. Like, people can, if you want to donate to me, no one has to, obviously. But I don't mind if it's literally the smallest denomination. I very much, like, I do not have to, no one has to donate. So anything's, it's all very great. I'm grateful every single time, no matter what it is, right? You could give me 1 bean for streaming. Like, no one has to give me anything, right? So it's always nice, no matter what it is, right? It's so yeah, it's all very much appreciated. Yeah, and especially because you know, I always think, you know, even if it is a low denomination, like, that could be, from my point of view, if I was living in that country, like the equivalent of something quite expensive. So I'm always grateful for that, no matter what it is. Yeah, exactly. There we go. We rarely see them. YouTube don't play. If you're learning something, give something to the teacher. I like that. Yeah, that's I appreciate that. So yeah, okay. So we're gonna get rid of this. We'll come back to this a different day. I don't really care. And we'll remove this. And right, let's actually get on with something, right? I feel like I've been battling the hash include thing for a minute, so let's just try and get on to something. So the next thing I need to do is increase the Supaz, yeah. Yeah, I occasionally watch VTubers myself. My favorite YouTuber one is Doki Bed, but she streams like super early in the morning for me, so it's kind of hard to catch her streams. Right. Right, what are we doing? We're trying to go into our Where is the... There it is, that's what I'm looking for. And we need model no, we need quad position data. I have a bad feeling that I don't need to do this. Hang on a minute. I am going to try something real quick. I only watch Janice Gombolus. I don't know this guy. Or this girl. That's the only VTuber. I'm not really losing the plot, yeah. We are losing the plot. Honestly, it's very hot right now. Oh my goodness. It's climbing back up to the horrible temperatures. Right. More water, that's what we need. Alright. Let's what I'm thinking, right? We're going to hopefully get an error so we can easily debug this compilation error. So instead of this, so this is what I'm nervous about, right? If I just push whatever, like vertex data and scene address or whatever, then we push that up, which is the size of this fella. Does this work? It's cool today, but we had a fire yesterday. Oh, that sucks. Hope everyone's okay. What is it, like 30? Yeah, it is 30 actually. Let me look it up. I'll obviously not. I won't dox myself. So, can and weather. All right. So, no. Okay, you can't do that. I was wondering if you can get away with this. So the push constants is 24. Oh, that's it, right? Yeah, of course. Sorry, I forgot. We need to make this a larger buffer size. So yeah, currently it is reporting where I live. Let's just see. Sorry, I haven't got the chat open. Apparently it's 27. Well, I don't think it is. But anyway, it's gonna be hot tomorrow too. Not good. 28 is, yeah, it's 30 right now. What is a kilometer indeed? I like that meme. What the F is a kilometer? Shoots eagle noises, AK, what is it, AR-15 shooting in the air. Right, so we need to make this graphics pipeline 8 bytes bigger, so let's do that. 8 bits bigger, 1 byte bigger. Where's our graphics pipeline at? Sorry, our compute pipeline. Yeah, so 24. This is, I've got a sneaking suspicion that... Hi Raj, oh thanks for all the hearts, whoever's doing that. I can't actually tell, but it's always appreciated. Highbrow entertainment right there, indeed. Alright, so we need to go in and I'm going to check this thing works, right? Does this make sense? Congratulations on the 3K. Thank you, very much appreciated that. It's a big shock, honestly. Oh no, I've crushed the GPU. No! Okay. Sorry, I crashed the GPU. Are we still alive? Yeah, okay, so we're still going, thank goodness. Yeah, thanks for that. It's honestly a shock that we got to 3K. My goal for the people who have who have joined recently, my goal was to get to 2K by the end of the year, and we got here way faster than that. So it's always appreciated. Yes, this is Vulkan. Thank you for joining us, by the way, in the lovely stream. Yeah, we had 3.11 yesterday. Now we're at 3.24. There we go. Look at that. Yeah, it's all you guys. So honestly, it's very much appreciated. You know, that's why it's always nice. Let's just. Can I push things up twice? I'm trying to work this out. Like, I don't quite understand how this works. So. Oh, we need a different buffer. Let's access the. Yeah, triangle's a great start, by the way. That's a good point. Just watching. Yeah. Right. So I'm just gonna access the positional buffer here. Now, obviously, the positional buffer. Does it need to be transferred? I can't remember. So let's just duplicate some code. Hang on. Let's move this down. Let's do it here. It's easier. So renderer 2D dot positional buffer handle accesses a buffer. Right, yes. So it's pair. I'm just gonna do one, just because I want to check this out. Positional buffer. All right. Swap chain setup is one of the hardest things to... Yes, it is. Honestly, it's really difficult. Yeah, Tokyo's back. I'm looking forward to seeing his stream. I'm going to sit... When I finished, I'm going to check him out. Excited. A chain... Yeah, Trainers challenge me, yeah. Uh-oh. Yeah, I'm using VMA. Yeah, it's good. So... Yeah, keep up with... well... It seems like you're already doing okay. But, yeah. Right, I'm going to pray this doesn't crash the GPU. If not, I'm going to go back to what I was doing. I'm just kind of like... redef... yeah, we're just doing that here. Right. Yeah, you're definitely on the right path. Right, so please don't crash. Oh, sorry. I crashed the GPU again. Have a nice day. Yeah, have a nice day. Thank you for joining us briefly. I hope you have a great day yourself, dude. See you soon. Yeah, good luck with Vulkan, indeed. Yes. Okay, so that was a big fail. So, but we do need to do this. Actually, this is actually quite important. And it's not. Okay, this is kind of stupid the way I did this anyway. So it is GPU. Current frames. You kids, appreciate that. That might be an auto translation, like to something it wasn't meant to. Dim lights. Oh dear. Oh yeah, yeah, so you're saying, yeah. Dim lights, underwear. Laying down on the sofa. I wonder how he I wonder how his lower back is handled. I feel like that's like a... I always wondered that when I saw him. Okay, let's just do this one more time. This is high risk, high reward, I guess. Because it would be nice to get rid of this... Oh, okay, no, that did work. Yeah, okay, so... Yeah, I had a feeling that was the case. Yeah, so that was the issue. I was getting something that was... We got there in the end. But now that's explained something to myself, that I don't actually need to have extra stuff. And these names are completely... they don't mean anything. At all. Oh, and I literally am getting the same... Oh, I didn't actually change this. Okay. Scratch what I just said. Let's try again. Okay, no, that did crash the GPU. Okay, so... oh. Okay, that was a hard crash. Okay, we're good. Okay, I'm not doing that again. I'm seriously not doing that again. Right, okay, so we've played with fire. Are we good? Yeah, okay, we're good. We're definitely good. Yes, let's not do that. Yeah, we played with fire. We're still here. Good. Okay, cool. Right, let's get back into it. So what I'm gonna do is I'm gonna restore what I did earlier. This is fine. We're gonna have quad position, which is the new push constant, which we're gonna push in, which is gonna be completely fine. We're gonna have it completely separate. It is 24 bytes. There is nothing wrong with this. We are going to have... now, the problem is if I'm accessing the buffer at two different places, that might cause an issue. So I'm not quite sure. What am I going to do? I'm not entirely sure, right? 07 indeed. Hello, 5090 please. Oh, yes. Maybe one day, who knows? All you have to do is... yeah, sign up with my... sign up to BitConnect and you'll be rich in no time. That's a deep cut for anyone who knows, you know. I won't explain what that means. bank robbery. Yeah, that's basically what it means. That's basically what it means. Alright, so I'm going to get rid of this. And we are not going to do this like that anymore. We're going to put the compute pushed constants back. Oh, I know that probably why that didn't work. I just had a thought. Okay, never mind then. I'll test that later. Indirect. Yeah, because I haven't actually set this up to point up. Oh, shit. Yeah, okay, so that's done. And then indirect count. Right, okay, so now we need to get in the positional buffer to write to it. So actually we're going to initialize it here first, almost. Okay, this is quite tricky. Right, yeah, because we need... I'm going to see if it also breaks in the same way. I really hope it doesn't. I wonder if this needs to be atomic. I don't think it does. That's the whole point of doing a compute position. Okay, so... indirect... So positional buffer. Let's just see if this is bad, right? Can we access it twice? I have no idea. So I might actually not render things just to make sure it doesn't crash. Alright. Not render the 2D stuff, that means. Because I might have to do some... Yeah, if I can get the thing moving in the shader, that would be fantastic. Because that at least gives us like a footing in what we're supposed to be doing. And then it's just about building up the algorithms, right? But now we need to we need to be able to communicate with not just the indirect draw calls, but also like the actual data that's being updated, right? That's what we need to do. Right. What I'm trying to do is... right, we get rid of this. Don't need that anymore. Yeah, we want to disable the drawing for a minute. That's what we're trying to do. So the drawing code is not anywhere close to all this. Gubbins. We need to get rid of this, just so we don't crash the GPU. What I'm interested in is what do we actually need to transfer it to be readable in the shader. I think it's host visible actually. That's one thing that this buffer is different. So maybe the transfer of memory is actually not what we need to do. Alright, so... Okay, right. Now question, does it crash when we try to render? So that worked fine. So when we actually do reuse that buffer again, what ends up happening? So it does exist. Now the question is, in my compute shader, can I modify this data to be write? So write only. I don't know what's going to happen here, but I think at the very least I need to make this... Yeah, so we need to do exactly the same... okay, so... Yeah, what we need to do is... Okay, so the first thing we need to do is understand that this is a loop. And we need to transition it from whatever it was before, from read to write. And if I look at my pipeline barriers, I think we can do another one. But this time for a different buffer. So what I'm going to do this for is... this is for the positional buffer. So the positional buffer needs to be transferred from one type to another. And it needs to be read-write in the compute shader, and it needs to be whatever it was beforehand. And I'm not even sure what it was beforehand. I actually don't know yet. So I'm going to set these to question marks for a minute. Because then I've got to obviously, after it's been written into in the compute shader. So this is the positional particle, particle? I got insane. Particle buffer barrier, right? Particle compute barrier, right? Throw this in here, right? And then throw this in here. Whoops, why are you doing that? Thank you. Okay, so put that there. And 3. And, okay, so that's what it needs to be. It needs to be read-write. I think it actually... Do we want to read it? I think we do. So we take that positional buffer, we read it in the compute shader. We do the compute shader work. Then we need to transition it out, which is going to tell us what it needs to be in at the end, which is good because that I'm not sure. So obviously it needs to be these two for the pipeline stages. So that needs to be done, and that needs to be an L2 cache. I think actually we just say write. Yes, so compute stage. So this and this. So that tells me half the story, right? The other thing I need to make it for is so if it's accessible in the vertex shader, it needs, yeah, okay, so it needs to be, okay, that's it, that's exactly what it needs to be. It needs to be the vertex shader stage can't started, and it needs to be readable in the shader. So that's what it needs to be, and that will tell me what the pipeline barriers are for this barrier in the in this early stage. So this needs to be a, what is this? Vertex shader bit, and it was in read mode. So as far as I'm aware, that is what we change it back to on every single loop. So it's read write, we write to it, and we need to say this is, we need to put this in here. Right, I'm going to say just compute barrier, a particle barrier. Now this is going to be the simplest change that we're going to do, right? But we need to be able to do this in the shader, otherwise this defeats the point of doing indirect draw calls. So now we need to put this in here as a 3, and we've transitioned the buffer hopefully to be readable in Derry, my foot is for member only stream. What? So this needs to be pipeline. Okay, so that's it. Okay, it needs to be readable. Now I don't, because this is host visible, I'm updating it on the GPU anyway. Yeah, we can't do that now. No, we can't use the same buffer. Yeah, nah. Yeah, nah. Our buffer needs to be on, it needs to be the same thing. Alright, so this unfortunately has increased the complexity again. The reason that we can't do what we're doing here, I love this song, please keep playing. So this is fantastic if we're going to read this in the shader, but the problem is we're using a host visible piece of data here, And if we're going to use particles, right, this is what the problem is. To update its lifetime and position, we're updating it in the shader, not at runtime, not making it host visible, meaning that unfortunately we can't reuse the same buffer, which is unfortunate. So yeah, what we're going to have to do is take out in our shader this guy, and now the question does suggest that we could probably do everything in a compute shader, but I don't want to do that because that's kind of awkward. So what I'm going to do is unfortunately just make oops. So float pad 3. So when we're messing with particles, we need to use a different struct, and that means unfortunately, annoyingly, we're going to have to make changes to every single thing that we've been doing. Particle position, particles, so particle data. Right. So this is going to take in a position, not a mat4. So what I'm going to do here is float. So we're going to do a vec3 position. We want a texture ID, that's still valid. And we want texture coordinates, which are still valid. Or is it? How do we update the texture coordinates in a compute shader? Or do we want to? Hang on. So we have color. Yeah, because the reason that we do this is because now we could get rid of this, but we lose the ability to use sprite sheeting. But I think, as far as I'm aware, let me think. Oh, this is tricky. Now everything's good apart from, well, we don't need transform. Everything's good except for this. The reason is because we have a delicate sprite sheeting system that we end up using, and that is only available because we make our buffers CPU visible. Now if our particle is purely on the GPU and it's going to be textured, how do we deal with the fact that it's going to be a texture, right? So the problem is here is we could literally just set this to you know, 0 0 0 and then 1 1 0 0 and then 1 1 1 and then 0 0 0, right? That would be the entire texture. Oh no, sorry. I'm doing too many zeros here. Oh no, not. That's legit. No, that's how you do it. It's 1 1 1, and then it's. That's it, right? That's the actual texture coordinate. That would be the entire quad. The entire texture that we pass in. If we have a lot of particles that have different textures, we can't use a sprite sheet in that case. We have to upload individual textures to our particle system, meaning that we could run out of texture slots for our bineless textures. In theory, that's what I'm kind of worried about here, and I'm just kind of curious, like, how would you work out if it's not host visible and it's never going to be touched by the CPU? How do we know what data it should be? Who's the thief in the room? That's my dad. Yeah. Fortunately, the thief didn't get my laptop, so I can still read your messages. All right, I'm kind of stuck on this. But you see my dilemma, right? Let me think. How do I solve this type of problem? Should we just for now assume that our particles are just going to be one color? And we can still do textures with texture IDs and stuff. But we just have to assume that the texture that we're going to upload is just going to be, you know, whatever. It's just going to be the entire thing. I mean, at the end of the day, you know, if we have smoke textures, does it really, you know, make a difference? Am I worrying about a problem that doesn't exist? Let me think. Because what we could do is pre-compute the... Okay, so here's what I'm thinking then. To do, think about pre-computing the sprite sheet texture coordinates for a given texture. Now this isn't hard to do because I have a sprite sheet renderer and I can just extract out the texture coordinates, right? Why is the textures for particles? That would be good for like smoke, right? Because it'll be like half transparent or translucent materials. It's really hard in colors, like for example, I don't know if it's going to work anymore, but you know that blue texture? We can actually just see. That should be fine, actually. We haven't made it. No, never mind. So, what we could do is... What we could do is... Sprite sheets... Yeah, pre-compute them, or a given sprite sheet. This is quite expensive to do and quite time-consuming, but it would save on making this buffer accessible on the CPU, which is the whole point of doing a GPU-driven renderer. You try and get as much into the into the thing. So for now, I'm just gonna have to do a standard texture coordinates, which I believe is that. I need to look it up, to be honest. It's basically this, but it's not quite that. I think, just so I don't make a mistake, I'm just gonna load up an older game engine. And we're just gonna see draw quad in. Oh no, wrong engine. And we're just gonna for now do one thing at a time, right? One thing at a time. We can just get a texture up there. I'm gonna have to make a different texture though. And then we're gonna try and move it through space, and then hopefully in the compute shader we'll have the ability to absolutely go crazy with the amount of particles that we can generate. Which one is it? It's Tempest, yes. Yeah, this just has the... Yeah, fantastic. This is what I'm looking for. I just need the texture coordinates. Yeah. So, for now, every texture coordinates in the compute shader is going to have... wrong engine. So in our compute shader, we're going to have a write only. So we're going to use the same idea here. That's just for reference. So we need a vec to text quads 4, which is equal to... I hope I could do member initializing lists here. Right, so we're going to do this. I don't know any way of doing this, like working out the sprite sheet thing, right? So as far as I'm aware, that's legit. Next is so the quad position. Actually, no. We need to copy over what we've decided to call this particle data, and right. Okay, so throw this in here instead. Now we need particle data. Nope, data. No. Let's see, particles. Particle data. Yeah. And then do this particles. Particle data PTR, right? Right, so we delete this and oops. Now we can start filling this up, data up with stuff. The texture ID is going to be tough as well. Like, how do we know what texture we're on? This is tricky. Texture data. Hear me out. We could have a material buffer, and that tells us, based on the information we could have, right? So this is writing. What I'm thinking now is we have yet another buffer, right? And this is the materials. And what we're going to have in here is, we're not going to set the color. No, we can set the color. We're just not going to set the position, right? So what we're going to do here is we're going to have a read-only buffer. And with this shader, is this going to break the GPU-driven renderingness? Because we need to pass data into this shader from the CPU. Like, how do we give it any data at all otherwise? I don't think this is bad. So what we could do is literally have another device address for this push constants, but this is read-only. And this is material data, right? And materials and material data. Use bindings to bind data to shit. That's what I'm going to try and do, but I'm going to try and do it with buffer device addresses instead. That's the idea, yeah. So we're not going to have a layout descriptions and all that kind of stuff, because otherwise it's kind of tricky. I don't want to have to deal with what are they called? Bindings. It's is it bindings? Yeah, it is bindings actually. Yeah. So the idea anyway is basically based on, what do I want to do here? This is kind of tricky. Now I've got to figure out. This is hard. I know I keep saying that, but I am. Oops. Comment out, please. So the idea anyway is we send up data and then we write it out. This is read only. Alright, so read only based on something like yeah, what we could do is grab the draw ID. So based on the draw the problem is in compute shaders you have less way of accessing your arrays. You can do this, but I don't think it's going to work. Let me type it out anyway. So if I have a... Oh, no, wait. Global invocation ID. I'm going to have to look up what that means, but I think that might be a way to grab out the data in here. Okay, so we need to use the pointer version. And then, you know, access the color, text calls, and all that kind of stuff. So the idea here is that we do like this, and then in the other buffer that we're writing to, the particle data. Now this is obviously going to have more than... Do we use the same thing? DI? That would make things easy. So that would allow us to basically set the texture coordinates, the color, and the texture ID, right? So we can then pass that over to different parts of the shader. So that was worse. Okay, so texture ID. And text chords. Like that, right? And move this down here. So effectively we do this for each we don't want to do so this is per draw call. So if we want more draw calls, let me do this. But per this is per particle. And I think what I want to do is obviously then also you know, set the position to, I don't know, vec 3. Hi bot, how you doing, dude? .f 0.f, right? So it should be really high. That obviously this is a stand-in for doing something with the positions, right? Now as far as I'm aware anyway, let's get rid of this. That seems like it would work, but I'm in a restaurant so I can't really hear you. Oh, fair enough. Enjoy your restaurant well. Let me do this then. Enjoy your meal. So we have a buffer that we're going to read in that's read only that we have. It's just we're going to make it bindless. We're going to put it up, but it's going to be host. It's going to GPU. I don't know if this makes sense. Cool. I don't know if this breaks the GPU drivenness. I don't know. Do you know what I mean? If I have a buffer that's interacting with another buffer that's host visible, does that break everything to do with this? Because if it does, then I don't know. It's still GPU driven in the sense that so sorry, what am I saying? Cool indeed, yes. So what am I trying to do here is figure out if I have two buffers and I'm writing to one. You know what we could do first is just figure out if this is going to work at all, right? Let's just, okay. Okay. I'm not going to do this for a minute. I'm just going to figure out, I'm going to hard code these values in and not do a secondary buffer. Yeah, let's not do the secondary buffer thing yet. What we need to do is actually get this working before we touch the idea of having a material buffer that's passing data up to each individual particle's. I'm being stupid, aren't I? We don't do anything. We don't do anything with materials in this, but why am I doing materials here? I do materials in the vertex shader. What is the point? Yeah, okay. Which is good, that simplifies everything down. If I want to have colors and positions and all that kind of stuff, we just put it in the vertex shader. Yeah. And we can keep track of that easily by just saying, okay, what particle set are we part of, right? We say particle set 1 has this particular material set, then we can index into whatever we want, right? Easy. Alright, so particle set, right? So we have a particle set number. That's going to obviously be set to 0. Yeah, okay, so the particle set is just going to tell us what material to use in the vertex shader. Level of indirection, we just have another pointer. Easy. We don't have to pass in anything here. We can get rid of this. Okay, that makes things way easier. Okay, fantastic. Okay, now we can do what we needed to do earlier. Now, what are we accessing here? We're not doing it per draw call. That's what this is for. What are we doing? We want to access things. I don't know. We want to access this buffer not in sequence like this. Let me look at the other renderer. It might do, it might be doing something cool. Yeah, so draw index, which we're not doing. Is there anything else though? Don't think there is. So I think these are all draw indexes. Yeah, draw index is using, yeah, it's the same access pattern every single time. So we just need to be accessing them. What does this do? What does this do? Is this just like per thread? Because, you know, if it's unique, then it's fine. What is this? In compute language, global invocation ID is a derived import value containing the n-dimensional index of the work invocation within a global work group that the current shader is executing on. The value of the global invocation ID is equal to work. Right, okay, so work group ID, work group size, local invocation. What's this? I don't quite get this, to be honest. Let me read that again. In the compute language, GL global invocation ID is a derived import value containing the n-dimensional index, okay, of work invocations within a global work group. That the current shader is executing on. But define a struct here. Maybe. I'm trying to avoid. I've got to be careful here because the compute shader is running at 64 threads at any point, right? But I don't want to cause a race condition within the thread, right? I don't know what these values are. So basically what I need is like unique numbers. Oh no, yeah. It's OpenGL's been at 4.6 for years. Excuse me. Excuse me. Excuse me. Okay, so let's see. So what we need is basically every time I run this thread, we need a different number. What's this? Okay, so in the compute language, GL local invocation ID is an input variable containing the n-dimensional index of the local workgroup invocations within a workgroup. The possible values from this range from 00 to okay, so that's not what I want. I think I do want this. So workgroup times by workgroup size plus. Yeah, I just need to know what all these mean. I just basically need a unique number per run of. So for example, let's just say I run this multiple times, right? I need 0. I need like. This is just in theory, right? And I run this. I run this n times. In the compute shader, I need to get each thread. So obviously I could run this more than 64 times. That's just how many threads are going to run in this instance, right? So I need to know like how many like what's that value going to be, so I don't get a race condition. I basically need a unique number that increments by 1 across all of them. So in the work group size is 3-dimensional. Possible values range from 0 to this. So if okay, so work group I size, I think I did ID. In line 35, I think you misspelled particle. Oh, did I? Oh, I did, yes. Thank you. Yeah, that's right. There we go. Cool. Right, so what are you? Okay, we're on a completely different thing. Okay, in the shader language is contains a work group declared by the compute shader. The size of the work group XYZ in each dimension is stored in XYZ components. The GL group size. Sorry, the GL work group size. The values stored in. It doesn't need to be in sequence. It just needs to be. Maybe it does. Hang on. All right. Oh, this is tricky. Yeah, so right. What is this? Layouts. Okay. I'm gonna go to another document because the rest made sense. I don't know what this is. Okay, so let me try again. In the compute language, it contains the size of the work group declared by the compute shader. The size of the work group in XYZ dimensions is stored in the XY components of the GL group size. Sure. The values of group size match those in. Okay, so it's just these, whatever this is. Okay, layout for a compute shader. I'm gonna risk it, you know. There's only one way to find out if this is gonna work, and that's just to do it. I think I do want this thing. I think this is gonna give us something that's like in sequence, writes to the buffer, everything's chill beans all the way through, right? So what I'm gonna do is just assume that this is data index, right? And then I'll be able to do this. Remember, this is running per thread, right? So hopefully this is going to be like 0, and there's going to be one called 1. So this, we're going to go, I'm going to set the position and the particle set to 0, which we'll just kind of roll with at the moment. Yes, GL documentation. So this is equal to vec3 0.f 8.f 0.f, and then we're going to do this. Particle set, right? Oh, I spelled particle wrong again. Okay, particle sets. We're gonna have a particle set, and we're gonna do this, and obviously this is gonna be 0. Okay, so even this layer of indirection isn't good enough, but at least it simplifies things. You can only have one particle set. Yeah, I think we're gonna have like multiple buffers here. Material buffers and particle set buffers. No, sorry, material buffers are the particle set buffers. But anyway, this is layer of indirection regardless. Anyways, so that should write out what we need. We need to create this buffer now on the CPU. And unfortunately we're gonna have to do exactly the same dealio again. So if we take our work that we did earlier. Oh, yes, go on the compute shader thingy. Yes, we've got quad position. And that was particle data. Particle data. And we're going to move this back to... I'm going to go back into game. And what we're going to do is... I'm going to take this. I'm going to first create another buffer. I'm going to make particle data. Particle data handle, and we're just going to literally, whoops, come back. Close that. That's what I wanted to do. we're going to take all this. We're going to make another buffer. We're just going to use particle handle. So, and we need to change this to particle buffer data, maybe. And just go through. Whoops. Right, that. We should see that. Why is that tabbed out weird? Right, cool. Next, we need to. Okay, so the particle buffer. Yeah. Its size is. We need it to be a vec. So 4 vecs. So there's 4 times 4 is 16. Might be a bit off topic, but how big is the average buffer? It depends. Oh, that's a. There's lots of different buffers for lots of different things. One. It really depends on what you're trying to do. So, for example, buffers really change in size quite drastically. So, for example, in this case, in particles, right, what would it be? For this particular type of buffer, you'd want this to be very small. So this would be as small as possible. That's why I'm trying to refer to it. It would have age. Yeah, it would be probably the size of it would be. So the individual elements of this buffer would be really small. But it would be, say, 60, it would be 24, right? 24 would be one particle. And if you want to do a million, it would be 24 times a million, right? Assuming that you use the same data. Because that's how particles work, right? They're tiny pieces of data multiplied all over the place. So this particle buffer could be huge, depending on how many buffers you've got, right? So yeah, that's what it could be, right? That's 500 XP. Woo! Well done, well done. So what does this need to be actually? So it's not an indirect buffer at all. It's a storage buffer. Is it going to be transfer destination as well? It's going to have obviously this. It's not an indirect buffer. It's just a storage buffer. Are we ever going to do a transfer command on this? No. It's not a transfer buffer. We're never going to do transfer destination. Because we're going to write to it on the GPU like it's the indirect draw call. And yeah, there we go. Okay, that's what it's going to be like. Particle buffer. Right. Is there anything else in here that needs to be done? Let's just build. Ah, yes, it's going to break. So yeah, anything called count I need to find. because that's where I copied it from. And yes, so the rest just needs to be called particle something. I feel like the music's got really quiet. Let me turn it up a bit. Yeah, there we go. Particle, particle, particle. Esc, do you want to integrate? No. I want to keep my render as simple as possible. Not really verbose like Vulkan, and same performance. Well, it depends. I think. I'm sure it's got like good performance. I'm not going to say it's bad or anything, but I think. No, I'm pretty okay with what I've got at the moment. It's not bad, right? I don't mind Vulkan, by the way. I'm sure if things let me do things this way with the there we go. That should be it. There's no count left. So we should now have access to this, which is going to be written to. We're going to transfer it. So we're going to call this. Oh, okay. Now it's really loud. Jump scared by a. What is it called? Megamanian. Okay, and then this. So it should now be readable. Now we need to make this readable in the vertex shader. It'll be even simpler and iterate faster. I'm turning you up because I can't hear you. This is what. Bot switching. All right. Yeah, no problem. I love this song. Okay. We need a vertex shader that needs to read in data. Yeah, particle data. We decided that we're going to do a set ID here. So if particle set. Okay, so we're going to read in. It's going to be read only buffer. Alright, so let's take this from the compute shader actually. It's going to be the same old, except the only difference is we're going to say read only. Yo, Emmanuel, how you doing, dude? Right, particle data and get rid of that. So what we want to be able to do now is basically what we used to do here. So we're going to duplicate this and we're going to take out particles. We're going to do particle data PTR. And in here we're going to take in, so instead of the instance ID, which is completely chill beans, but we are not going to do things by instance. Your learning system has exposed you. Oh no. What? In what way? Whoa. Have you so being at, since you started streaming, I tuned in and yet I only got an hour of actual learning done. Oh no. Yeah, it's tough. Well, like I said, well, put me on the second monitor, put me on mute, and then That might help. Hello. Hi, Relics. How you doing, dude? Good to see you again. Hopefully you had a good night's sleep. Didn't, Hello again, indeed. Still grinding away. We got the, You got enough. Very good. We got the, indirect draw calls working. Now we're just working on the next part. So particle data. Okay, so we've got to be careful here. So we're reading in this buffer, this particle data buffer. And instead of, where's the texture coordinates? That's what I'm after. Yeah, so I'm going to take in, yeah, text codes. Where are the text codes? Oh, we passed them in directly. Okay. Oh, okay. Fine. We can do that. No problem. Sure. Yeah. And then we just say, yeah, maybe we don't need this set particle thing. Okay, I'll just use it as padding then, maybe. Anyway, so all we're going to do is delete this and replace it with our particle pointer, which we filled in the GPU shader, the compute shader. Then we take the particle data. And how do we access the data then? What particle are we going to do? Okay, yes, we need to do per instance because we're still doing instance rendering. And then position. Yes, we're still going to do instance rendering. We just need to fill that instance rendering data within the compute shader. And we're not going to worry about the draw, because the draw calls are only generated for the draw call command itself. The instance data is going to be for us as we pass it in. Fantastic. Okay, so assuming that we've got a read-only buffer that's actually valid, that's vertex to the vertex shader, we have created it, we transition it into a compute shader one, we run it on the compute shader, we write it out, we then transition it to the vertex shader, and then we just keep repeating over and over again. So let's just see how we did. Do we need to do anything with this? Oh yeah, we need to do our push constants to work. We haven't finished yet. I've been refactoring my off-screen rendering targets, render targets, set up to cleaner and higher level work with by offloading a ton of heavy operations to source files, minimizing the expose. All right, yeah, expose and headers, nice. Okay, so we're very much close to being done here, which is sick. Well done, dude, on thinking about these type of things. Right, so we need to go into our 2D renderer and realize like there is another thing that we can push. Cool, fantastic, actually. So we do have another thing in here. We say particle data, and we're going to push this in here. Okay, I think it's okay if we don't have everything pushed in. We'll see. Oh, we need the buffer handle. Right, so what I'm gonna do is if we're gonna do indirect, if we're gonna use the indirect draw call, then it's pretty much giveaway that I definitely need the buffer handle. Particle buffer, particle data handle. So I don't know a better way to do that yet. Alexa said before any public SDK release for my simulator, it will go through a refactor to lock down what I want my 3 third parties to have access to. Nice, that's quite smart. I've kind of let them just... I think I've isolated them pretty well on my end. I just set them all to private in CMake. Oh, you're talking about other people accessing your stuff because you got a standard development kit. Wow, okay, cool. That's actually really cool. I have the I don't have any problems with this actually. All right. Because I don't think anyone's going to use this engine. All right, so we've done that. Now we need to push this. I haven't pushed it. Particle data buffer. And then once it's pushed into, then we do our push constants. There we go. And we should have our push constants working now. Oh, we need to resize it, which is fine. 224. I just hope that doesn't mess things up if I don't use parts of it. I think it's fine. Alright, so as far as I can tell, we're done. But this is very prone to crushing the GPU yet again. Yeah, okay, so what do we want to do here? Do we want to compile yet? Are we ready? I think we're ready. I think I've done everything correct. I just hope that the compute shader knows what we're doing. I've made a massive assumption here that this is going to access this at 0 and pass in something that makes sense. So anything that compute has, yes, that's true. Anything that's possible to compute. So let's let it rip, eh? So line 52, 58, apparently doesn't work. In what shader? Vert shader 58, okay. Vert shader 58. Oh, we don't have the struct, I don't think. Oh, I spelled particle wrong here as well, so let's correct the spelling. What are the other errors? We have... Oh yes, no overload for this. Which is by design, because I need to send in the particle handle. Redefinition of result again. Get rid of this. And that should be all the errors up to that point, as far as I can tell. Base mindset. No one is going to use my shit anyway, so... yeah, that's their problem, 100%. So what have we got next? Particles comp, line 53. Yes, I need to do a bit more work than that. That's only the pointer. Okay, so that should be us filling up the data in the compute shader, just like here. We're just going to do exactly the same stuff and give that a run. Right, fingers crossed we don't lose the stream. Dun, dun, dun. And we're crashing. Yeah. Right, okay, so first things first we need to discover is, one, can we even access this stuff? Because sometimes, let's put this at 0, right? We're only going to run this once anyway. And when we do this, do we crash? I'm going to do this as well. No, okay, so now next question is... Hi, file saved. Good to see you again. Hope your day has I hope your day has been well. How are things coming along with your project? I'm just moving it. I'm trying to do GPU-driven rendering for our particle system. So yeah, it's kind of fun. I managed to get indirect draw calls working that get built up in the command buffer. It's Quake Engine. It's gone. Oh no. So I'm going to do this as well and just see. Does this make sense? Oh no, that doesn't make sense. It didn't. Hated that. So we can't write to it for some reason. Let's just make sure our stream is still good. Otherwise I'll be talking to no one. Looks good to us. Fantastic. Okay. Right. Cool. So we are crashing when we're accessing stuff. Okay, so it's likely the data isn't there. Or write into something that doesn't make any sense. So this is write only, which is fine. But when we are trying to get this to work, in the compute shader, what's the buffer look like? Let's see. So I'm just gonna carefully go through the buffer because we saw this last time when we did our indirect draw calls. Our buffers were wrong. So we have a size of 16. I'm gonna say we might be too small. So I'm gonna make this just like 64. That's too big. But eventually we're gonna have to make this big anyway, so it's not really like how much of a big deal. We have storage buffers. It is gonna use a buffer device address. It's gonna purely be on the GPU. That's why we're writing to it on the GPU only. We have the VMA allocator, we have this, and this, all part of the new buffer that we've done. Fantastic. And we set the name particle buffer. Allocated particles, which is good. And then we have the buffer device address set up. And then we get this back and we have particle handle. Fantastic. Okay, so that looks legit. Sweet, I've been gone from the world of programming due to summer break. I'm finally back in my apartment to start working on my engine again. Nice. I'll be using your streams as motivation. Ha ha ha. Nice. Yeah, I do the same thing, so I'm very grateful that I can provide value. And hopefully you absolutely smash it out the park with your engine. And it does all sorts of cool stuff. So yeah, looking forward to what you end up making. Okay, so the compute barrier pipeline stuff. Let's just make sure this is set up in the most obvious way. So this should be a vertex shader read, and we're transitioning to a compute shader read write. So we have read write access, and the destination is, oh yeah, that's wrong. Okay, I guess. Wouldn't that be read write? Thank you. Parrying it back to me, I like that. So we have that. We have in. Oh dear, that's. Oh shit! Wrong buffer. I'm messing around with the wrong buffer here. Yeah. So particle compute. Go down into here. This is still right. So this, I think this is wrong. If it's read write, we need to move it from compute to. So the compute needs to have finished. It needs to be read write, goes to vertex read. Yep. Okay. And it is the particle buffer. This goes in here. Let's just make sure that we are using the right buffers here. Yep. particle buffer. And this is 3. Okay, so as far as I can tell, we are good. It could be the push constants, to be honest. So let's just check that. So when we are doing the compute thingy. Oh, this is 64 now. There we go. Okay, that's the mistake. That will be crashing it. We don't actually set up the buffer device address to work at all. So in our compute shader, we're not actually doing anything with that piece of memory, and it just dies. All right, particle data. There we go. Okay, so that's going to be a massive issue. So I'm going to try and bring back everything in here as it was, like this included. So now we should be able to, yeah, we just couldn't access the actual data itself. Right, let's get out of here and look at the buffer. Okay, so yeah, so this is right. Push constants is the same old. And so yeah, I just missed something there. Yeah, shader read. And yeah, shader read. Okay. Nice. Okay, let's see how that works. Please don't crash. Fingers crossed. Oh yeah, we've got to do this first. Okay, didn't crash. Yes! Yes! Look at that. We updated the position in the compute shader. Yay! Okay. With indirect draw calls, this is going to get real fast, real quick. That's fantastic. That's really good news. Now, I don't think I'm freeing everything, so I'm not going to commit yet. So let's free. Sweet, nice work, thank you. Yeah, so to do particles, like loads of particles on the screen, I need to be updating them in the compute shader, which includes the position. Obviously, they also need lifetime. But yes, it's going to be really helpful to update these MFs in the compute shader. So if I have, where is it? Shut down. We need to also shut down another buffer, and this should be it. Now, I don't exactly know how to do particles very well. Outside of that, that's like what we needed to do. First time we have gameplay. Straight up computing that shit. Yeah, exactly. So, all I'm interested in here, it's going to look at our particle again. Nice. And then, does everything get cleaned up? Yep. Okay, so let's commit this. Get rid of this because this never worked, unfortunately. Next would be to test 2 particles, and I think that's the next step. This is just going to make sure that the race condition, we don't have any terrible race conditions, right? So we've got to run this in a sense that yeah, we've got to for each instance up to a certain point, we need to increase the instance count. So we need to instance draw these guys. So that's the next step. Instance draw, let's just say 5 particles, right? If we can do that, we're moving in the right direction for like adding like billions of particles. Well, millions of particles, that's an exaggeration. Anyway, git status. Added. Oh, that's also. Hang on. The CMake file has been updated. Where? Oh, okay. Doesn't really matter. I thought it added something and I didn't want to keep. All right. So, particle 1 particles position gets updated in the compute shader. So now we need to do more than one. And it shouldn't be that harder. It shouldn't be that much harder. We've set the groundwork up. That's the foundation. Now we need to basically think about how we're going to do this when we run more than one instance of this compute shader. And what I think I'm going to basically do is, based on this, I think we don't want to increment this by. We only want to do this once, which is kind of tricky to work out because this is going to make more draw calls. What we actually want to do is increase the instance count, not this, until the instance count gets too high. Then we make another draw call. So what I'm going to assume is that we can do some hacky maths, right? And go, okay, until data index is greater than or equal to 20k. We need to do it once though. Let me think about this, because we got to be careful here. So we need to have one draw call, obviously, but we then don't want to do it again. Until we exceed a particular level of things. Put this here. This is the idea anyway. That's the instance count. So then we have indirect draw called instances. But I don't know how to do this once for the first time, right? So the first time we need to. Right, let's think. How do we do this for the first time? Going from 1 to yeah, going from 1 to what is it? 1,000,000 particles is only going from, is it 100%? So yeah, it's literally, I'm not even gonna lie, that's gonna be easier than going from 0 to 1. 0 to 1 is a pain in the neck. Now I just need to figure out the logic for making sure that we don't have a draw call for every single particle, right? That's what we're trying to figure out now. The next step after that is just, you know, increasing the amount of data in this particle buffer. So now we need to think about how to do that. Right, let me think. Right. I can't guarantee. I don't know if this is always going to be 0. I mean, I could do this, but I don't know if this is going to work. You know? Like, no, that's not going to work. If the data index count is 0, I know it seems crazy, but what if, like, shout at me if this is the wrong maths, but draw count equals, is it equal to data index modular 20k, and if that is equal to 0, then we're chilling. Basically, we have a true condition, and we could just say if draw count is equal to 0, increase draw count maybe. So, as far as I know, the remainder of a division by a number, if this is 0, this will be 0. But if it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, blah, blah. That, I don't know if that's true though. I think it has to be a prime number actually. Right, so it has to be prime or a multiple of primes. If it's 20,000 and this is like divisible, yeah, it won't have a remainder. But if I make it so that this, it's just a simple division. If that is equal to 0, no. I don't know, closest prime near this. Just do pair primes is kind of strange. I feel like this isn't that complicated. I'm just kind of overcomplicating it. But it seems you guys are still going, yeah. Going strong, even though I'm a bit tired. A prime or a multiple of primes, do you mean? Yeah, that's what I was thinking, yeah. Do you mean integer? Yeah. I think, yeah, 20,000's remainder will be a remainder even if it's a fraction of it. And obviously 0 divided by that prime number. Let's go with something like that. That's I know it seems a bit weird, like to do a prime number thing. I'm gonna make it a bit lower as well. Closest. Maybe I'll come back to this look tomorrow and be like, what the heck was I thinking? Prime to. I'm sure that exists, right? There's a prime calculator. Nearest, yeah, nearest prime finder, that'll do. Okay, that's a convenient prime. Okay, so if that is equal to that, then let me increase this draw count. No, it still doesn't work. The reason is because this needs to be done at the end of the this needs to be done at the end. Because we need to collect this, right? Like the last thing. We still need to like have a number that's added. Yeah, I think I'm just gonna unfortunately have like an atomic add here. Just come up with a formula for the closest prime. Can't be that hard. Yeah, I know. Okay, so what we're going to do here is we're going to do another atomic add. And I think I can just throw this in here and be like, alright, draw call count, right? And it's going to start off as 1. And I don't know, it's kind of awkward, this, because it's in a multi-threaded environment. This is why it's tripping me up. Why are you using instance invocation ID as instance count? Invocation. Oh, right, yeah. So I want this as invocation count. So if we have like 20,000 compute shaders all running in different threads, we want to be writing to... Alright, which one was it? This one, right? So I don't want it to be locked to the workgroup size. But I assume if we have thousands of compute shaders running, then it's not locked to the amount of... I don't know, I'm going to leave it. Unless you can tell me otherwise. That basically I want to be in a situation... thank you for the stream. Yeah, no problem, TT. See you soon, man. So... I'm struggling with the multi-threadedness. How long have we been rocking and rolling for? Let's pause the timer briefly. So I've coded for 8 hours today and a half, and we have been live for 9 hours and 18 minutes. Oh man. Alright. I think it might be worth looking into how compute shaders work a little bit. Because right now we have this... I'm in a bit of a not catch-22, but I'm a bit stuck. Yeah, okay. I guess this is still game dev. I'm a bit stuck because I'm like, what do I want to do here? We want to only have a new draw call every set of instances. Nine hours, yes, going strong, kind of. We've made a lot of progress though. We've done indirect draw calls. We've got, and you've done 5. Hell yeah, brother. That's really sick, actually. Well done. Okay, so what am I trying to do here? Tomorrow hopefully will be another 12-hour stream. Yeah, maybe. Just 3 hours for you. Damn. That's something. Listen, 3 hours is more than most people do. Even in a professional setting. I'll tell you what, people are like mega lazy. Yeah, okay, so this works really well for one thing, right? Let's just... How do I... Right, forget doing the instance thing, right? Forget that for a minute. We want to run this X amount of times. And we want to only run this once. How do we do that? And at the end as well. That's really tricky. Yeah, let me look at the compute shader in here. So we have this global instance ID thing. And what we're trying to look for here is how on earth he decides if there's a draw call or not. So he has a visibility step here that works out basically if the thing has been called based on a a viewport. We got the game to actually function. Yeah. Not just yeah, gripe the GPU. I mean, yeah, we crashed that motherfucker many times. Yeah, if you get 20 minutes, I agree. Like, most people just don't stick with things at all. So yeah, I don't think there's any. Let's go in here. Yeah, as far as I can tell, I don't think there's any way that he stops the draw calls. He does a draw call every single time anyway, and he doesn't do instant rendering. Okay, I've got to figure out how to do the instance rendering now. Because we could do a draw call every single time we have an instance of this compute shader, but that kind of defeats the point of doing millions of particles. So we need to set this up in a way that makes sense. How do we do... Right, I'm going to say, how do you make things run once at the very least? Because if we can make things run once, we can probably make things run a set amount of times. So if you have a compute shader, how do we make things run more at once in a compute shader? Oops. Because we don't know, one, the order of things are going to happen, and two, what threads. We could atomically add, but I don't exactly know how to do that. What I mean by that is, well, if we add a number over and over again, that is going to be, you know, just increasing by value until it finishes, basically. And then we've got to decide, like, basically at the end to do a draw call, to generate a draw call in the GPU. I don't even know if GPU driven renders even use bloody instant rendering now. It's like confusing. So I think that's what I need to figure out is GPU driven rendering instancing. Like, how do you do that? GPU instancing, I guess what it's called. Yeah, that's what I'm trying to do. But obviously, okay, so this might be an option. I don't know what this is. This feels like AI. Like an AI written thing. Like, I'm gonna get out of that. I don't know what that was. Okay, so he's using DirectX, but I think we can extract value from this. A screen hiccup. Oh, I didn't really look at anything interesting. I just looked at shaders. Let's just see our shader. Our stream. Are we still good? Yeah. Okay. There's no single library for GPU resources. No, I don't think so. Oh, well. Is there a single library for GPU resources? No, I think you have to define them. Whatever the GPU resources are. Anyway, I'm going to share my Discord server real quick, guys. Here you go. Right, okay, so that's the... I'm going to have to call it here. As you can probably tell, I'm getting tired anyway. But yes, it is time for me to go. And go about the rest of my day. I hope you've all had a fantastic stream. I hope you've enjoyed this very long stream. This might be the longest stream ever that I've ever done. I think the last... I don't think I've ever peaked into 9 hours, so that's really cool. Yeah, so thank you all for all the lovely comments and staying subscribed and being awesome in the community. It's been fun hanging out with you guys, and I very much appreciate you all. So yeah, I shall see you all soon. I don't think I could stream tomorrow, right? Okay, just so you're on the same page. But yeah, stay locked in indeed. I will do. But I'll let you know, guys, how that goes, okay? All right? Anyway. All right, bye, guys. Bye, 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 bye.